Hi everyone, welcome back. So in this video we need to study about even signal and odd signal, and this will be our last video for continuous time. Continuous time signals are completed. After that we need to study about discrete time signals. So in continuous time we need to study about even signal, odd signal, and conjugate symmetry and conjugate anti-symmetry signal. Okay, these are very simple, very straightforward, and you might have studied all these kind of signal in your 11th 12th classes as well. Okay, so this will be a very easy video. So what do you mean by even signal? So let's just say an xt signal is given, this kind of xt signal is given. So what you need to do, you will put x of minus t, in place of t you will put x of minus t. Then if x of minus t is equals to x of t, that means it is an even signal. Okay, so if your signal has the ability of eating up the negative sign, that means it is an even signal. So have we seen this kind of signal anywhere in our standard signal? Yes, delta of minus t, that was equals to delta of t. Do you remember this? It has the ability of eating up the negative sign. Other thing also we saw, rect of minus t, it also had the ability of eating up the negative sign. What else we saw? Triangle of minus t, it also has the ability of eating up the negative sign. What else we saw? In your trigonometric function, which will be an even signal? Cos, right? Because cos of minus t would be equals to cos of t. So cos also has the ability of eating up the negative sign, right? So how will you check if a given waveform is given? Then how will you check whether it is even or odd? So the method is, you will check at t equals to 0 plus and you will check at t equals to 0 minus. If both are same, that means it is an even signal. Okay, so at t equals to 0 plus, what is the value? 0. At t equals to 0 minus, what is the value? Nearly 0 only, right? Here at t equals to 0 plus, what is the value? 0. At t equals to 0 minus, what is the value? 0. Both are same. Yes, it is an even signal. Or what you will do, you just need to take the mirror image about y-axis. About y-axis you need to take the mirror image. If you take the mirror image, only one mirror image you need to take about y-axis, and you will get the same structure. If you are getting the same structure, that means it is an even signal. Are you getting this point? About the y-axis you need to take the mirror image. If you are getting the same structure, it is an even signal. Or you check by this, t equals to 0 plus, t equals to 0 minus. I would recommend checking both of the things. At 0 plus, 0 minus I will check. Also I will take the mirror image as well. In this one, what I will do, at t equals to 0 plus, what is the value? Let's call this value as a. At t equals to 0 plus, the value is a. At t equals to 0 minus, also value is a. Just a second, guys. Yeah, so at 0 plus the value is a, 0 minus the value is a. That means it is an even signal. Or what you will do, you will do the mirror image about the y-axis. If I take the mirror image about the y-axis, what do I get? I get the same thing, right? If I take the mirror image about y-axis, then I will get the same function. This mirror image, I am getting the same function. That means it is an even signal. Okay, we will get back to it. We will see more example, but let's study about odd signal now. So what is the property of odd signal? It will not eat up the negative sign, but it will take out the negative sign. It will just take out the negative sign. Okay, it will not eat up the negative sign, it will take it out. Example, if you remember sine of minus t, what was that? Minus of sine t. Do you remember tan of minus t? What is that? Minus of tan t. Doublet function is also an odd signal. Okay, we are studying about odd signal. So it will just take out the negative sign. So doublet function is also an odd signal. Okay, so if you remember doublet signal, what was the doublet signal? We started from here. We saw that this will be differentiated. So there will be one impulse here and other impulse here. So kind of you can say that at t equals to 0 plus, whatever the value I am having, at t equals to 0 minus I am having the negative value. Although doublet function has no physical meaning, but at t equals to 0 plus, whatever that you are having, just after 0, although both of them are actually at 0, but by the definition if you see, so just after 0 whatever that is happening and just before 0 whatever that is happening, both are negative of each other. Amplitude is same, but they are negative of each other. Kind of you can say the amplitude here is infinity and here the amplitude is minus infinity and here the amplitude is plus infinity. So kind of they are negative of each other. That's why doublet function is also an odd signal. Okay. How will you check here? First thing what you can check, at t equals to 0 plus you will check whatever the value it is having, 0, and at t equals to 0 minus you will check what value it is having. This is your 0 and this is kind of 0 minus, right? At t equals to 0 plus you are having 0 value and at t equals to 0 minus you are having minus 0. Basically you are going in the negative direction, right? Are you getting this point? Or you can check at this point as well. At t equals to 1, you are having value to be 1, but at t equals to minus 1, you are having value to be minus 1. So from here what you can see, x of 1 is equals to minus of x of minus 1, or this minus can be taken here as well. This minus can be taken here as well. So x of minus 1 is equals to minus of x of 1. This is what the property says. Put here 1 is equals to minus of x of 1. So better we check at t equals to 0 plus only, but you need to see one thing, that it is plus 0 and it is minus 0. Although both are 0 only, you will not say that sir x of 0 plus is equals to x of 0 minus. You will not say that like that. You will say that sir this is plus 0 kind of and this is minus 0 kind of. Or if you are not satisfied with this one, then you will check at some other value. X of 1 is plus 1, x of minus 1 is minus 1. Or what is the other thing? You will take the first mirror image about y-axis, and then you will take the other image about x-axis. First about y-axis, then about x-axis. So if I take the mirror image of this particular function, then this will be the mirror image. Say yes or no. First mirror image about y-axis, then next mirror image about x-axis. So this will be the function. So yeah, it is becoming the same. Are you able to understand the point? One mirror image, then other mirror image. Here what did we do? We took only one mirror image. So if I take the mirror image of this one, I am getting the same function here. So in even function, you will take only one mirror image, but in odd function, you will take two mirror images, one about y-axis, then about x-axis. So one fold here, then another fold towards x-axis. So multiple ways I have told you how to check even and odd signal. All these will be used when we study Fourier series. So in Fourier series, I will be using all these kind of even signal, odd signal. There we will study about half wave symmetry, odd half wave symmetry, even half wave symmetry. So there also I will tell you particular method. Okay, I am not expecting that first you will do the look. I am not expecting that first you will make the diagram of x of minus t, then you will make the diagram of minus of xt, and then you will check whether both of the diagrams are same or not. This thing we are not going to do, because it will take a lot of time. So we have to develop some method. So at x equals to 0 plus, at x equals to 0 minus, I am checking. From there you can get to know. If you are not satisfied with that, then check at some other value. If you are not satisfied with that, then take the mirror image. Okay. So this process we will not do that. We are making the waveform. Just by the looking at the waveform only, we should be able to tell whether it is even or not. Okay. What about this one? Is it even or not? This is a sinusoid function only, but check at t equals to 0 plus. Some positive value is there, that is plus 0, and at check at t equals to 0 minus. Some negative value is there, that is minus 0. So yeah, it is an odd signal. Okay. Or what you can check, at this particular value you are having plus 1, at this particular value you are having minus 1. Or what you can do, take the mirror image about y-axis. If you take the mirror image about y-axis, this is what you will get. Then another mirror image about x-axis. So another mirror image about x-axis. So this is what you will get. So yeah, I am getting the same structure. That means it is an odd signal. What about this one? Mirror image. Let's check by mirror image, or let's check by t equals to 0 plus. So 0 plus some positive value, 0 minus some negative value. So yeah, it can be an odd signal, right? But now if I take the mirror image, or I can check here as well, whatever the kind of positive value I am having here, the same kind of negative value I am having here. Or you take the mirror image. First mirror image of this one, this would be the mirror image. Second mirror image of this one, this would be the mirror image, right? First and second, two-fold, one fold and second fold. So one fold, second fold, yeah, I am getting the same structure. So this is also an odd signal. Is that clear to you? Even signal, odd signal. How will you analyze? Just looking at the waveform. You are not going to make these waveform again and again. You can draw the graph of x of minus t. You can draw the graph of minus of xt as well. But this is not what we need to do. We can check at certain values, and if we are satisfied with that, then we will proceed. Okay. But it is not always necessary that the signal has to be even signal or odd signal, right? What is u of minus t? U of minus t is neither equals to u of t, and it is neither equals to minus of ut. Both cases are not there. Neither it will eat up the negative sign, nor it will take out the negative sign. That means the negative sign will remain there as it is. The negative sign will remain there as it is. Nothing will happen to negative sign. That means it is neither even nor odd. Okay. Neither even nor odd. What about other function, r of minus t? Can you eat up the negative sign? No. Can you take out the negative sign? Absolutely no. I can only take out the constant value. This constant value can be taken out, but I cannot take out the negative sign. So r of minus t would be equals to r of minus t only. You cannot do anything about that, right? That means this r of t, this is your neither even nor odd signal. This is also neither even nor odd signal. More examples. It feels like that there is a symmetry, right? It feels like that there is some symmetry. But check at x equals to 0 plus. What is the value you are having? Let's call it a and let's call it minus a. At t equals to 0 plus, the value is a. And at t equals to 0 minus, at t equals to 0 minus, the value is 0. Are both of them equal? Basically, is this the case that t equals to 0 plus is equals to, at t equals to 0 plus is equals to 0 minus? Is this the case? No. Or is this the case? At t equals to 0 plus is equals to minus of t equals to 0 minus. Because in case of even, what was the scene? That t equals to 0 plus was equals to 0 minus. So that was even. And in case of odd, what was the scene? That 0 plus was equals to minus of 0 minus. T equals to 0 plus was equals to minus of 0 minus. Right? Is this the scene? No. If this is not the scene, what does that mean? That it is neither even nor odd. Okay. So this is also not the case. This is also not the case. It is also not the case. That means it is neither even nor odd. Or you can take by mirror image as well. If I take the mirror image of this one, this is how I will get. Right? If I take the mirror image of this one, this will be the mirror image. Then another mirror image I need to take. So this will be the another mirror image. So both are not the same structure. It feels like that both could be same, but solve it intelligently. One mirror image, one folding, then another folding about x-axis. That means the folding will be somewhat like this. Positive A would become negative A. This value will become negative. So folding would be like this, not like this. So there is no mirror image here. It feels like that there is mirror image, but actually there is no mirror image. Although the mirror image method will take some time. So better way is always check at 0 plus and 0 minus. If both are coming equal, even signal. If both are coming negative of each other, that means odd signal. That's it. Here also check the same thing. At t equals to 0 plus, what you are getting? Nearly 0 value. Let's call this value as a. So 0 plus nearly 0 value and 0 minus nearly value a. So both are not equals to each other. There is no like both are not equal, or neither you can take out the negative sign. Neither this is the condition. Neither this condition is there nor this condition is there. That means it is neither even nor odd. Or from here only, if you just see it, you will get to know. Second thing, take the mirror image. So if you take the mirror image of this thing, what you will get? This thing you will get. If I take the mirror image of this particular structure, if I take the mirror image of this particular structure, then what will be the mirror image? This straight line will become straight line here, and this line will become mirror image here. So this will be the mirror image. Is that same? Both of them are same? Absolutely no. That means it is neither even nor odd. So when we study Fourier series, there it will be used. Now you feel like that, sir, it is very easy, but when you are calculating Fourier series in the examination whole or in the test series, there like you will see this kind of signal and you will say, okay, this is an odd signal. It happens with a lot of students, because they will see, okay, this is the positive part, this is the negative part. In a hurry, they will say it is a odd signal, but it is actually not a odd signal. So best way is check at 0 plus, check at 0 minus. You will get to know whether it is odd or not, or even or not. People will say this, people will see this one, okay, you will feel like that it is a symmetric about y-axis. So that means it is a even signal, but no, it is neither even nor odd. How you are getting to know? You will check at 0 plus and 0 minus. That's the best way. Check at 0 plus, 0 minus, you will get to know whether it is even, odd, neither even nor odd. All fine? Okay. Let's see some properties now. So what we need to do, what is this function? This is neither even nor odd. Neither even nor odd. Now I need to break it down into even part and odd part. What I mean to say is that this is my xt, right? So every xt can be broken into its even part and odd part. What do I mean by that? Can I break down this function? Can I break down this function something like this? Something like what? Something like this. What I'm gonna do is that I'm saying that the slope here is 1 by 2. What I'm saying, the slope here is 1 by 2. and the slope here is minus 1 by 2, right? Because the graph is like this, so slope will be minus 1 by 2. Graph is like this, slope will be plus 1 by 2. And here I am saying this slope is 1 by 2 only, and this is the same graph, the slope is 1 by 2. If you add both of them, will you get the same graph? Say yes or no. If you add both of them, will you get the same graph? Yes. Why is that so? Minus 1 by 2 plus 1 by 2. Slope is 0. You see this portion minus 1 by 2 and 1 by 2. When you add two graphs, always the slopes are added. These things we have seen in a very in-depth manner, right? So whenever we add two graphs, slopes are always added. So minus 1 by 2 plus 1 by 2, slope will be 0. Yes, slope will be 0. And at here we are having 0 value, that means it will always be 0. After that, slope is 1 by 2, slope is 1 by 2. So slope will be 1. Now let me know one thing, whether it is even or odd. This portion is even, odd, or neither even nor odd. This is a even portion, right? This is a even function. And what about this one? Is it odd, even, or neither even nor odd? So what you will do, at t equals to 0 plus I am having plus 0. At t equals to 0 minus I am having plus 0. Here what you will say, at t equals to 0 plus I am having plus 0. And at t equals to 0 minus I am having plus 0 only. Both are plus 0 only, that means it is a even function. What about this one? At t equals to 0 plus, at t equals to 0 plus I am having plus 0. And at t equals to 0 minus, at t equals to 0 plus I am having plus 0. At t equals to 0 minus I am having minus 0. So what kind of function is that? It is a odd function. It is a odd function. So the given function was neither even nor odd. I have broken down into even and odd part. So how did I broke it down? There should be any method, right? It will not click to me that break into plus half, minus half, or plus half, plus half. There should be some method, right? So what I am saying, any xt could be broken into x even of t plus x odd of t. Now what I am gonna do, I am gonna put in place of t, I am gonna put minus t. In place of t, I am gonna put minus t. So I will have to do the same thing here as well. What I am saying, this is the even part and this is the odd part. So what is the property of even? That what it has the ability of eating up the negative sign. And what is the property of odd? The property of odd is that it will take out the negative sign. So the same thing they can do here. It has the ability of eating up the negative sign. The property of odd is there that it will take out the negative sign. This is equation 1. This is equation 2. Add both of them. What you will get? 2x even of t would be equals to, if I am adding both of them, what I am getting? X plus x of minus t. So x even of t, what that would be? X of t plus x of minus t divided by 2, right? So this is the even part. And when you subtract both of them, equation 1 and equation 2, when you subtract both of them, what you will get? X odd of t would be equals to x of t minus of x of minus t divided by 2. So this is the odd part. So if xt is given, and they ask you what is the even part, what is the odd part, can you find it out? Yes. Okay. If xt is given, you can find out the even part and odd part. So let's take an example. If xt was rt, this function was rt only, no? This function was rt only. So xt was rt. So what would be the even part? Even part would have been r of t plus r of minus t divided by 2. That means 1 by 2 I can put here and 1 by 2 I can put here. So 1 by 2 rt, 1 by 2 r of minus t. That means slope would be half. Slope would be half. This is half rt. This is minus half r of minus t. Basically, if I ask you to write down the equation of this particular function, so what will be the equation? It would be slope of half for positive side and one slope of half towards the negative side. One slope of half, slope is minus half, right? Slope is minus half. So r of minus t, this guy is saying that slope should be negative. So yeah, slope is minus half, but the graph is looking towards minus infinity. That's why r of minus t here. So this would be the even part. And are we getting the same even part? Yes. What about the odd part? Odd part would have been r of t minus of rt divided by 2. That means half part here, half part here. So this guy is saying that slope should be plus half. And this guy is also saying that slope should be plus half, because Here one negative sign says slope should be negative, another negative sign says slope should be negative. So negative into negative, slope would be positive. All these things we have seen when we were studying about ramp function. So here also the slope should be half. One should be looking towards plus infinity, one should be looking towards minus infinity. So yeah, this guy is looking towards minus infinity and this guy is looking towards plus infinity. So if I ask you to write down the equation of this one, so 1 by 2 r of plus t minus 1 by 2 r of minus t. Say yes or no. Okay. So even part and odd part, this is how we broken it down. Well and good. Find the even part of signum t. What you need to do, xt is given. You need to find the even part of signum of t. So what is the even part? Even part is given as x of t. First make the signum t graph. Do you know how to draw the graph of signum t? Certainly you know. So this is how we draw the graph of signum t. This is plus 1, this is minus 1. This is the graph of signum t versus t, right? So what will be the even part? What do you think, what kind of function is that? What is the value of x of 0 plus? 1. What is the value of x of 0 minus? Minus 1. So x of 0 plus is equals to minus of x of 0 minus. What do you think, what kind of function is that? Odd. Now I am asking you about the even part. So let's calculate the even part. X of t plus x of minus t divided by 2. What is x of t? Signum t plus signum of minus t divided by 2. What will be the property of signum of minus t? Can I write it down in this manner? Signum of minus t would be equals to minus of signum t. Say yes or no. Signum of minus t, that means you need to take the mirror image. Signum of minus t, that means you need to take the mirror image. So if I take the mirror image, what kind of mirror image I will get? This kind of mirror image I will get. Isn't it equals to minus of signum t? Yes. So this thing I can write down about signum function. That signum of minus t is equals to minus of signum t. Take mirror image and it is negative of this particular graph. So signum of minus t is equals to minus of signum t. So signum t minus signum t divided by 2. So even part is coming out to be 0. And surely it should be 0 only because it is an odd function. So for an odd signal, even part will be 0 only, no? It is very obvious. A given signal xt is given, which is an odd. So even part has to be 0. It is completely odd only. So even part is 0 only. And if you calculate the odd part, what you will get? If I calculate the odd part, so what is the definition of odd part? This is the definition of odd part, right? So signum t minus of signum of minus t divided by 2. Signum of minus t is equals to minus of signum t. So this will be 2 signum t, 2 and 2 get cancelled. So what we are getting? Signum t only. So odd part will be the complete function. So from here I got to know that odd part is equals to function only. Odd part is equals to xt because xt itself is an odd function. So complete odd part will be the same function and even part would be 0. This is very obvious. So yeah, these are just the things which are written in the textbook and we are studying it. But there is very rare chance that any question would be coming up from this particular topic. But if it is coming, then it would be very easy. You can just find out in this manner. So only part to remember here, even part you will find out like this and odd part you will find out like this. Even if you forget this formula, you can derive it within seconds in the examination hall. X of minus t, okay, this is coming, then x of even t would be this, odd t would be this. Okay. Now some interesting point we will see. For a even signal, if you are taking the integration from minus infinity to infinity, can you break down the limit? How will you break down the limit? So let's try breaking down the limit. Can I break it down in this manner? Minus infinity to 0, x of t dt plus 0 to infinity, x of t dt. If I am breaking down the limit in this manner, then there is one point which is very important, and that point is that your function should be defined at t equals to 0. Wherever you break down the limit, then function should be defined at t equals to 0. That means I don't want that at t equals to 0, your value of xt is infinity. This should not happen. Are you getting this point? Whenever you break down the limit of any integral, so wherever you are breaking, this function should be defined at that particular point. I don't want that at t equals to 0, the function is going towards infinity. Okay. So this is very important point whenever you are breaking down the limit. So I am already taking this consideration that my function is not going towards infinity. Then only I can break it down. Now just let me know one point. From minus infinity to 0, whatever the area you will get, and from 0 to infinity, whatever the area you will get for an even signal, both will be equal or not. Take out the example of any even signal. Was this an even signal? Yes. So whatever the area I will get here, the same area I will get here as well. Take more example. Was this an even signal? So whatever the area and whatever the area combined you are getting, the same area you will get here. Because it is symmetric about y-axis, no? So same area you will get. So can I break it down like this? That it would be equals to 2 of 0 to infinity xt dt. Because this area and this area both are equal. Or you can write down in this manner that it would be equals to 2 of minus infinity to 0 xt dt. Always remember the limit should be from lower to higher. Lower to higher. Tell me the answer of this particular thing. Again break down the limit. Again break down the limit. Take out the example of any odd signal. Was this an odd signal? At 0 plus you are having plus a, at 0 minus you are having minus a. At 0 plus you are having plus a and 0 minus you are having minus a. Yeah, this is an odd signal. So whatever the area that you are having here, the same negative area you are having here. More example you can take. Sinusoid you take. Whatever the area that you are having here, the same negative area you are having here as well. So what does that mean? That this area would be negative of this area. So what should be the answer? 0. Or what you can write down? That minus infinity to 0 x of t dt would be equals to negative of 0 to infinity x of t dt. Say yes or no. Right? So if this graph is given, and you start from minus infinity to 0, so what will be the area you will be getting? Negative area. And then you go from 0 to infinity, what area you will be getting? Positive area. Negative area, positive area. Both will be equal to each other but negative in sign. Say yes or no. Negative in sign but both will be equals to each other. So total area would be 0. Right? So this is the property of even and odd signal, that in even signal you can break down twice, but odd signal will have the total area to be 0. So do you need to mug it up? Absolutely no. You can simply derive it, or you can simply think about it in the examination hall. You don't even need to derive it. Odd signal, okay. Odd signal, you take example, positive area, negative area cancel out, 0. Even signal, this area, both will be same. So twice of that. Always remember the limit will be from lower limit to higher limit. Okay. So this particular question is given that ft is written into even part and odd part. Ft is written into f of even t plus f of odd t. So from 0 to infinity, even part is equals to 3. So what you need to find? Minus infinity to infinity ft dt. So what I need to find? Always in the examination hall, no matter whatever the question is there, first you write down whatever that you need to find. Then what you need to do? Minus infinity to infinity. What is your f of t? F of t is equals to f of even t plus f of odd t dot dt. Minus infinity to infinity f of even t dot dt plus minus infinity to infinity f of odd t plus dt. Can you let me know what will be the value of this? For an odd function, if I integrate from minus infinity to infinity, my f of t could be anything. If that is broken down into odd part, let's just say that will be broken down somewhat like this. If that is broken down into odd part, so whatever the area I will get here, the same area I will get here. That means this value will be going towards 0. And what about this? About the even part? My function is broken down like this. So whatever the area that I am getting here, the same area I will be getting here. So that can be broken down like this. So 0 to infinity is equals to 3. So 2 into 3, your answer would be 6. Okay, 6 is the answer. Very easy question. That's the answer. Right? So you can think in this manner. Very, very straightforward problem. Yeah. So comment on the nature of ZT. That you need to do on your own. So what do you think? If I multiply an even signal with odd signal, what I will get? So let's check that out. For even and odd, what I need to do? I need to calculate z of minus t, right? If my z of minus t is coming out to be z of t, that means it is a even signal. And if my minus sign is getting outward, that means it is a odd signal. So what I need to calculate? I need to calculate z of minus t. That would be equals to x of minus t into y of minus t. What is x of t? What is x of t? It is a even signal. That means x of minus t would be equals to x of t only. And y of t is a odd signal. If it is a odd signal, that means y of minus t would be equals to minus of yt. That means minus sign will get outward. So what is coming? Z of minus t is equals to minus of xt dot yt. Z of minus t is equals to minus of xt dot yt. So what is that? That is equals to minus of zt. So what you are seeing from here, z of minus t is equals to minus of zt. What does that mean? That it is an odd signal. So when you multiply an even signal with odd signal, you are getting an odd signal. Do you need to do all these things in the examination hall? No. What you will feel? Okay, even x of minus t will be x of t only. Y of minus t will be minus of yt because it is an odd. So one negative sign is coming outward. From here there will be no negative sign, but from here one negative sign is coming outward. So positive into negative, what you will get? Negative only. That means, and if I am having negative, that means it is an odd function. Positive into positive, what will be the answer? Positive. And if it is positive, it is an even function. Don't go by the numbers. Don't feel like that, sir, even number is 2, odd number is 3. So what is the answer? 6, even. This goes for number, not for the functions. So don't go by the numbers, okay? Number addition, multiplication of even into odd would be even in case of numbers, but not in case of functions. In case of functions, you need to put x of minus t, y of minus t. So even will not take out any negative sign, but odd will take out a negative sign. And if it is taking out a negative sign, that means it is an odd function, right? Here, both will not take out the negative sign. Basically, x of minus t dot y of minus t. So x of minus t will be equals to xt, y of minus t would be equals to yt. So that would be equals to zt only. It is a even signal. Directly you could have seen from here, if it is even, negative sign will not come outward. If it is even, negative sign will not come outward. So positive into positive, positive only, even signal. What about this one? Odd signal, negative into odd signal, negative. So negative into negative, what that would be? Positive only. So what is that? Even signal only. Negative into negative would be positive. So what you need to do? Z of minus t. What will be your Z of minus t? Z of minus t. X of minus t dot y of minus t. Right? So what will be the value of x of minus t? X of minus t would be minus of xt. Right? And what will be y of minus t? Y of minus t would be minus of it. Why is that so? Because both are odd. So negative into negative, that what that would be? Positive only. X of t into y of t. So what that would be equals to? Z of t. So what is this? Even only. Directly in the examination hall, negative into negative would be positive, that means it would be even. So odd into odd, what that would be? Even. But in case of number, 3 into 3, 9. So in case of odd into odd, it would be odd only. In case of numbers. But in case of function, it is different. Addition now. This time it is addition. So what do you think what will happen? Z of minus t would be equals to x of minus t plus y of minus t. Z of minus t would be equals to x of minus t plus y of minus t. So x of minus t would be equals to x of t only. But y of minus t would be equals to minus of it. So can you relate z of t and z of minus t? No. Can you anyhow relate z of t? Basically, can you write down these two things? Either this or this. Can you write down any of these? Because you are getting to know that x of minus t is equals to x of t and y of minus t is equals to minus of it. So this is what you are getting. So z of minus t is equals to zt? No. Z of minus t is equals to minus of zt? No. So it is neither even nor odd. Okay, neither even nor odd. Did you understand this point? Right? Because we cannot even relate, no. Z of minus t is not equals to minus of zt or z of minus t is equals to z of t. So we cannot relate, so neither even nor odd. What about this one? Z of minus t, what that would be? X of minus t plus y of minus t. So what will be x of minus t? That is xt only. What is y of minus t? That is yt only. And that is equals to zt only. So z of minus t is equals to z of t. What does that mean? It is a even function. So from here you will get to know that positive sign will come out. Here also positive sign will come out. So z of minus t would be equals to x of t plus y of t. That would be equals to z of t only. That means it is an even signal. What about this one? Odd and odd. Both are odd. If both are odd, so x of minus t plus y of minus t. So both will take out the negative sign. So minus of xt minus of yt. So what will happen? Minus of xt plus yt. That would be equals to minus of zt. So z of minus t, minus sign is taking outward. So what will happen? Odd. So what is the conclusion here? You can derive all these things in the examination only. It will take hardly 10 seconds. So you don't need to mug it up over even into odd into odd, even into even, odd into even. Not like that. Just think in the examination hall. Even into even. Okay. Two positive sign, it would be even only. Even into odd. One positive sign, one negative sign. Odd. Odd into odd. Negative sign, total positive sign. That means it is even. So this is how you need to think in the examination hall. Same goes for addition as well. Same goes for subtraction as well. Same goes for division as well. So you need to think in the examination hall. That's it. Okay. Let's solve this question. F of t is equals to f of even t plus f of odd t. F of even square t is equals to alpha from 0 to infinity. F of odd square t dot dt is equals to beta from 0 to infinity. Find out the value of f square t. Okay. So this you can do on your own. Try doing it. I will take a pause, drink some water, and then I will show the solution. But you should be doing it on your own. You will be able to do it. It is not tough. So just break it down in this manner. I am just giving you a hint. F square t dt. What you need to do? Minus infinity to infinity. What is ft? Ft is f even of t plus f odd of t square dot dt. Right? So break it down. Minus infinity to infinity. A square. Here there is no mode. Okay. Here there is no mode. So you are not going to break down with respect to mode. So f square t, f odd square t plus 2 f even t, f odd t dot dt. Someone will say, sir, y conjugate did not come. All these things would come if it was mode of f even t plus mode of f odd t. Right? But there is no mode here. So without even mode, we are breaking it down. So now after that, try thinking about it. That what will be the nature of this particular thing, what will be the nature of this particular thing, and what will be the nature of this particular thing. And based on that, you let me know your answer. Okay. So I am taking a pause. You can do it on your own. Yeah. So let's start. Okay. So what we need to do? Yeah. So we can break it down in this manner. F square t dot dt plus minus infinity to infinity f odd square t dot dt plus 2 minus infinity to infinity f even t odd t dot dt. So what will be the nature of f even square t? What is the meaning of f even square t? That means f even is multiplied with f even. Even into even. This will take out positive sign. This will take out positive sign. Positive into positive will be positive only. So even into even will be even only. So this is an even function. What is this? This is an even function. What about this one? Odd into odd. Odd into odd. This will take out negative sign. This will take out negative sign. So negative into negative would be positive. So what about this? This is an odd function, right? So what? Sorry, what did I say? Negative into negative, it will be positive. So what is this? This is an even function, right? Odd will take out negative sign. This will also take out negative sign. So negative into negative, it would be positive. So this will also be an even function because odd into odd is even. Here you can see odd into odd is even, right? So this is even. What about this one? This will take out positive sign and this will take out negative sign. Negative into positive into negative, what that would be? Negative. And negative means it would be odd function. So even into odd is odd. Even function into odd function is odd function, right? So what do you think? What will be the value of this? What will be the value of this? This will go to 0 because you are integrating from minus infinity to infinity for an odd function. Odd function. Integrating from minus infinity to infinity. Whatever the area you are having here, the same area you are having here. So where it will go? Towards 0. What about this one? Can I break it down in this manner? 2 into 0 to infinity f even square t. Because for a even signal, whatever the area you are getting here, the same area you will get here. So from 0 to infinity, it can be broken down into 2 into 0 to infinity f square t, f even square t dt. Same goes here as well. F odd square t dt. So value is given 2 alpha plus 2 beta, or you can write down 2 alpha plus beta. So this kind of easy questions can come, right? Just 1 second guys, just 1 second. Yeah, welcome back. So this is the answer. Okay, let's see some concept now. Now if a and b are real numbers, okay, a and b are real. If a and b are real numbers, then how I can break it? This we have already seen. I can break it in this manner, mod of a into mod of b. You can check by taking any number. Let's take a as positive and b as negative. Let's take both of them positive. So what that would be equals to 6 only. Mod 2 into mod 3, that will also be 6. 2 into minus 3, it would be mod of minus 6, that would be equals to 3. Sorry, that would be equals to 6. And here, mod of both of them, 2 into 3, that would also be equals to 6. 6, 6. Take this one as a negative and this as positive. Again, both would be same only. Mod of minus 2 is equals to mod of 3. Again, both of them would be same. And take this as well. What you will be getting? Mod of 6, that would be equals to 6, and then you take the mod both of them. So 2 into 3, that would also be 6. So you can check taking positive, 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 negative, negative, positive, and negative, negative. Mod of a into b is equals to mod of a into mod of b. That's for sure. What about this one? What about the addition or subtraction, you can say? Can I write it down in this manner? No, absolutely not. Check. Positive value we are positive values we are taking. So this will give you 5, and this will also give you 5, and that will be also 5. So both are giving you 5. For positive value, this is correct. So this is correct only when a and b are positive. Positive integers, or sorry, not integer, real number. Positive real number. Positive real numbers. What if one is positive, other one is negative? So mod of 2 plus mod of minus 3. What it will give you? Mod of minus 1. What it is giving you? 2 plus 3. This is 1, this is 5. This is coming out to be 1, this is coming out to be 1, this is coming out to be 5. So this guy is greater now, right? Previously it became equal. Now this guy is becoming greater. Take minus 2 plus 3. What will happen? Minus 2 plus 3. So this will give you 5, and this will give you 1. Again this is greater. Take minus 2 minus 3. Both are negative. Minus 2 minus 3. So it is true only when, because what this will give you? Minus 2 plus minus 3. So what this will give you? Minus 5, and this will also give you, 2 plus 3. This will give you 5, this will also give you 5. So when both are negative as well, then also it is true. So it is true only when both a and b, both are having same sign. That means if both are negative, then also it is true, and if both are positive, then also it is true. Say yes or no. But if both are having the opposite sign, so what will be the general way? General way would be to write down in this manner. This is how I can write it down. Say yes or no. How? Because I calculated this thing, right? This was coming out to be 1. But when I calculated here, mod of 2 plus mod of minus 3, what it was? 5. So this will be always greater. Mod of a plus mod of b will always be greater, or it could be equal. 5 equals to 5, or it could be equal. So this is how I can write it down. So this is a general way, and this is the another general way, that mod of a plus b is less than or equals to mod of a plus mod of b. And when it would be equal? When both a and b are having the same sign. Same sign, that means either positive or negative. If both of them are having the same sign, then you can break it down like this. Then the equal sign could be there. Otherwise, it would be less than or equals to. Okay? Or when would be the case of less than? When you will get the case of this thing. When both a and b are having the opposite sign. Right? Okay. So this is the general way I can write it down. You should also know that when both of them would be equal and when both of them would be less than. So is it tough to remember? You should keep it in mind, because these kind of questions are nowadays asked in your gate examination. Okay, a question based on this was asked this year, although that was on a Fourier transform, but basic mathematics question it was. So now you let me know, can I break it down in this manner? A lot of people, even some coaching institute also broke it down in this manner. Is that true? Can I break it down in this manner? Absolutely not. Why? Just take an example, right? You can take an example. Let's just say this is your function. This is your function. This is 4, this is 2, this is minus 2, and this is minus 1. So what is the total area? You need to integrate. What is the total area? I am calculating this particular value. So what I will do, first I will integrate and then I will take the mode. Then I will take the mode. So this is my process. So first I will integrate. That means first I will calculate the area. So what will be the area? 4 into 2. This area is 8 and this area is minus 2. So 8 minus 2, total area would be 6. So total area is 6. Right? And now I need to take the mode. So mode of 6 is equals to 6 only. So here for this one answer is coming out to be 6. For this one answer is coming out to be 6. But here what I need to do, first I will take the mode and then I will calculate the area. So when I take the mode, what will happen? This negative value will become positive value. When I take the mode, first I need to take the mode of ft. So this negative value will become positive value. So this negative value will become positive value. So previously what we were having here, minus 2 we were having. So that will become plus 2 now. So between minus 1 to 0, it will become plus 2. So what is this area? 2 plus 8, 10. So now what is the answer? 10. So this guy is greater. If f of t was positive, if your f of t was always positive, the magnitude of f of t was always positive. Magnitude of f of t was always positive. Let's just say this was my f of t. If this was my f of t, then for this particular integration as well, the answer would have been 10. And for this particular integration as well, the answer would have been 10. Because first I would calculate ft dot dt and then I would take the mode. So what would be the answer of ft dot dt? That would be 10. And then you take the mode, answer would be 10 only. And after that, I would have made mode of ft dot dt. Mode of ft dot dt. So if you take the mode of ft, that would be same only, because ft is always positive. If ft is always positive, then mode of ft would be equals to f of t only. So at that time, equal sign could have come. Otherwise, this value will be always larger. And you intuitively think about it, no? First you are taking the mode, that means you are already making this particular function positive. And if you are making a function positive and then you are calculating the area, then the area would be more positive, no? But here what you are doing, the function could be negative as well, positive, negative. So some part getting cancelled out. Previously what was happening, actually this was negative. So here some part was getting cancelled out. So only some positive part was remaining and that was being mode. So this value will be certainly lesser. A lot of coaching institute did this thing this year, that they simply took the mode inside. No, we cannot take the mode inside. When we take the mode inside, it will be going like this. Say yes or no. Are you agreeing to this point? Do you agree? Okay. So always take care of this thing. Always take care of this thing. So this is the final inequality. So you should always keep these things in your mind. So one complete mode, and when you take down the mode inside, then there would be a sign of less than or equals to. But this is not the case for multiplication. In multiplication, you can break down the mode. But in addition or in the integration, you cannot break down the mode like that. Okay. Same goes for discrete time signal as well. If you are able to understand it, then it is fine. Basically, I am replacing my integration with summation. This we are going to understand in the next lecture. Okay. In the next lecture, we are going to study about discrete time signal. So minus infinity to infinity. What I am doing, minus infinity to infinity, integration is broken into summation. Those who have studied this subject already, they would be able to understand. So in discrete time, integration is always broken into summation. In place of f of t, I am writing f of n, or I can write down x of n. Now if I take the mode, that would be less than or equals to minus infinity to infinity mode of x of n. Okay, so this goes for discrete time. Same thing is there, ditto same thing is there. Well and good. So these inequalities you will keep in mind. and you should not be getting confused in the examination hall because you can derive it within seconds. Yes or no? Now based on that you need to solve this problem. Take your time and solve it. F of t is given as even and odd. Which of the following statements are true? MSQ question it is. Yeah, one more thing can you let me know? If I say my even signal and odd signal will always be orthogonal to each other. What I am saying, if my f of t real, then my even signal and odd signal, when I multiply both of them and integrate from minus infinity to infinity, I will get the zero answer always. Yes or no? Because even into odd will be odd. So if it is a odd signal, then you integrate from minus infinity to infinity, you will always get the zero answer. What does that mean? That both are orthogonal to each other. What was the condition of orthogonality? The condition for orthogonality was you will take the integration. If it is non-periodic, then you will take the integration from minus infinity to infinity. You will multiply two functions x1t dot x2t, integration from minus infinity to infinity, and then if the integration is coming out to be 0, that means they are orthogonal to each other. So if I say a statement that a real even signal and odd signal will always be orthogonal to each other, is that statement true? Absolutely true. Okay. So even signal and odd signal are orthogonal to each other. So this integration will always result in 0. Now someone will say that, sir, what if it was your periodic signal? So periodic signal also will result in 0 only. Consider the example of sin t and multiply with cos t. What is sin t? Sin t is a odd signal. Cos t is a even signal. Sin t into cos t, what it will give you? Sin t into cos t, then you can multiply and divide by 2. So sin 2t. And for one time period, if you integrate sin 2t, it will give you answer to be 0 only. So whether it is periodic or non-periodic, if you are multiplying even signal with odd signal and you are integrating over a time period or over the complete period, your answer would be 0 only. That means even signal and odd signal are orthogonal to each other. Is that okay for you? Well and good. So this was one of the statements that we could have answered. Now solve this problem. That which of the following statements are true. So let's go with the first one. So in the first one, what I need to do? First, I need to calculate this thing, minus infinity to infinity, f of t dot dt. What that would be equals to? Minus infinity to infinity, f of even t plus minus infinity to infinity, f of odd t dot dt. Just let me know one thing. What will be the answer of this thing? If it is an odd signal, then integration would be 0. So minus infinity to infinity, f of t dot dt is equals to minus infinity to infinity, f of even t dot dt. Say yes or no? Right? Can I take mode on the both of the side? If I say 2 is equals to 2, I take mode both of the. If I say 2 is equals to 2 and I take mode on both of the side, 2 will be equals to 2 only. If I say minus 2 is equals to minus 2, if I take mode on both of the sides, then 2 would be equals to 2 only. So if two things are equal, you can take mode on both of the sides. Why I am taking mode? Because I need to answer something based on the mode. So if I take mode on both of the sides, what I am getting? This is what I am getting. Minus infinity to infinity. Is that true? Okay. Now in the final options, what do I require? I require this thing. That mode of integration minus infinity to infinity, f of t dot dt. So that means I require this thing. But do I require this thing? That integration minus infinity to infinity, f of even t dot dt, then complete mode. No. In none of the option I require this thing. I need mode of ft, mode of fe dot, mode of f even t dot dt. That means I need mode inside. So what I need to do? I need to take this mode inside. So do you remember one thing? This is the equation 1. This I am keeping as equation 1. But now from here I need to take the mode inside. So minus infinity to infinity, f of t dot dt. Now this mode I need to take inside. And if I am taking this mode inside, what does that mean? Less than or equals to minus infinity to infinity, f of t dot dt. Say yes or no. Whenever you take mode inside, less than or equals to sign would come. Say yes or no. So this is equation 2. All good? Equation 1 and equation 2 are there. This can be replaced with this. So from here what you are getting? Minus infinity to infinity, f of t dot dt mod is less than or equals to minus infinity to infinity f of t dot dt. So this is the statement we are getting, and first one is absolutely true. So whenever these mode kind of questions come, either it is mathematics, mostly it is mathematics only, right? So always have the patience there. You know everything, but you need to have the patience. So this is what we are getting, right? Second statement can be true? No. It would be less than or equals to, right? It would be less than or equals to. So if first statement is true, second will not be true. Basically, it will not always be equal. It can be equal, but not always be equal. So we need to write down a generalized statement. So generalized statement would be the first one. It will not always be equal. It can be equal. Now go with this one, C and D. What you are doing? You are doing f square t dot dt and then integrating over the complete time window, and then you are taking the mode. And here also you are taking the mode. In that manner you are proceeding. Option C and D are there. Are both of them true? So let's start. Let's start what I would have done in the examination hall. Let's check. So what you would have done in the examination hall, you would have started with this option, that's sir minus infinity to infinity f even square t dot dt. Then you know one thing, that sir, sorry, not even, f square t dt. You know one thing, that sir, it can be broken into f even square t dot dt plus f odd square t dot dt. Other thing would come, that is 2 even into odd, but both are orthogonal to each other, so this will throw out to be 0. So all this term will throw out to be 0. If I take mode on both of the side, sir, if I take mode on both of the side, f square t dot dt. So here also I will take the mode minus f even square t dot dt. Shall I put the mode here? Absolutely not. I am taking the mode of whole. So mode of whole I will need to put. So f odd square t dot dt. Both are even signal. This is also even signal and this is also even signal, because odd into odd has become even. So as a whole I have taken the mode. This is equation 1, right? Minus infinity to infinity f even square t dot dt plus, this is equation 1 I have put down. But do I require this equation in any of the options? No, in any of the options I don't require this equation. What I need to do, I need to take these mode inside. That means it is like mode of A plus B, mode of A plus B. This is your A and this is your B. So it is like mode of A plus B, and that is less than or equals to mode of A plus mode of B. So same thing I am doing. I will take this mode inside now. So what I am doing, minus infinity to infinity f naught square dot dt. So this I don't need in my answer. This I don't need. So what I need to do, I need to take mode inside. So if I take mode inside, what I will get, f even square t dot dt, this mode here, plus minus infinity to infinity f odd square t dot dt. Because I know one thing, oh sorry, not here, the mode would be here. Because I know one thing, what is that? That mode of A plus B is less than or equals to mode of A plus mode of B. Say yes or no. So this should be the answer, sir. Now this can be replaced with this particular thing, right? This is your minus infinity to infinity f square t dot dt. So this I am replacing with this, that is equation 2. So this mode is less than or equals to minus infinity to infinity f even square t dot dt plus f odd square t dot dt. Okay, so this is what is coming out, and you feel like that, sir, this would be the option. They are saying equal and equal here, doesn't make any sense. So answer should be, these should be wrong. But no, they are true. Why they are true? What do you think? They are true. I am saying they are true because there is a condition, no, that they can be equal as well, and they will always be equal. How? Just think about it. Can this value or can this value be ever negative? f even square t dot dt. Can this ever be negative? Isn't it like an energy? First you are doing the square of a function. No matter whatever the function is, if you are doing the square of that and then you are calculating the area, it will always come out to be positive, no? Say yes or no? So this number will always be positive. There is no meaning of mode. This number will also be always positive. There is no meaning of mode. And this number will also be always positive. There is no meaning of mode. So you can remove the mode or you can keep the mode. Although in the left hand side I require the mode, so I will not remove the mode from here. In the left hand side I require the mode, so I am not removing the mode from there, but from here I can remove the mode. And even if I am keeping the mode, then this sign would be equal, because if your A and B are positive, if your A and B are positive, then it can be simply opened. This sign would be equal. This would be equal. So here equal sign would come. If A and B both are, if this guy and this guy is positive, that means here the equal sign would come. And if here the equal sign is coming, that means this guy will be equal to this particular thing. That means this thing will be equal to this particular thing. So here equal sign can also come out. So this is correct, because although this is 100% correct, but here what we need to understand is that both are always positive, because we are doing the square. Here only I did not even need to do any calculation here. I would have seen here f square t dot dt. This will always be positive. This quantity, this particular quantity, after the integration, it will always be positive. This will also always be positive, and this will also always be positive. So there is no meaning of mode. And if there is no meaning of mode, this I already know, that my f square t dot dt is always equals to minus f even square of t dot dt plus f odd square of t dot dt. This I already know, right? This I already know, and I know that this is also positive, this is also positive, and this is also positive. So there is no meaning of putting the mode. Wherever you put the mode, nothing will change. If I put the mode here and I don't put the mode here, no issue. If I put the mode here, I put the mode here, I don't put the mode here, no issue. I put the mode at complete side, I put the mode like this. Wherever you want to put the mode, you can put the mode, nothing will change, because everything here is positive. And why they are positive? They are like the energy, right? F square t dot dt, isn't it like the energy? You are doing the square of the signal first. That means whatever the function is, let's just say this was the function. Now you are doing the square. That means the function will become positive, negative value will become positive, and then you are calculating the area. So area has to be positive, no? Same goes for f even square t, same goes for f odd square t as well. So function would become positive, and if function are becoming positive, no matter wherever you put the mode, doesn't matter. So C and D are also correct. So here the options were framed intelligently. So this is true only for this particular case. Otherwise, the generalized statement is this one. This is the generalized statement. But since all these are always positive, this is also always positive, this is also always positive, and this is also always positive. So the special case we need to take now. This was the special case, that it would be equal. If special case is there, then you can remove the mode as well. Are you getting this point? So this was the condition of a special case. That's why these options were also correct. In the examination hall, getting these kind of questions correct is very, very rare. Even AIR 1 will get these kind of questions incorrect. Okay? Because in the examination hall, it would be very tough to think. Because everyone would be like those who have studied from a good resource, they would be remembering these kind of inequalities. Like they would remember this inequality as well, and they would remember this inequality as well. And they will solve till this particular point. And then they will see that, okay, no option is matching. So this is wrong, this is also wrong. But the special case, that if the integration itself is positive, then equal sign can come. And if these are already positive, so there is no meaning of this mode, no? So even if I put the mode at one place, I don't put the mode at other place, how does that matter? Right? So C and D are also correct. So this was intelligently framed question, although I only framed it. So it just clicked to me and I framed it. So this was a good question. Are you getting the point? And from here we have understood a lot of points which I will be using in Fourier transform. So this inequality is very, very important. Whenever the mode goes inside in an integration, less than equals to sign would come. And in addition, whenever the mode goes inside, less than equals to sign would come. And by intuition as well, it is clear to you, because mode of ft you are integrating. Mode of ft will always be positive, and when you are integrating it, it will give a better result. And here it will give positive and negative. After combining whatever the result we are getting, that result it will give. So certainly this quantity will be always larger. And when both of them would be equal, if f of t is always positive, if f of t is always positive, then both of them would be equal as well. Okay. So yeah, this was a good question, good discussion. I guess yeah, that's it. That's it about even and odd signal. It was a very easy topic actually. Even and odd signal is very easy topic. Only in inequality in these kind of things they can puzzle you. So if they want to frame a good question on even and odd function, they will frame these kind of questions. Or if they want to frame a very good question, then they will frame these kind of questions. The point is you should have the inequalities clear and you should know how to break down a function ft into even and odd part, and then you need to take the square, and it should be clear that even into odd into odd, even into even, what that would be. That's it. Within 5 minutes, you can revise your even and odd signal. Well and good. Let's go to the other topic, that is conjugate symmetry and conjugate anti-symmetric signal. So again, just like even and odd signal, this will be also very simple. What you need to do, in even signal, what did you do? X of minus t, that was equals to x of t. So here what you are going to do, you will do x of minus t, but along with that you will take the conjugate as well. And if that is equals to x of t, then it is conjugate symmetry. And in conjugate anti-symmetry, what you will do? X of minus t, you will take the conjugate as well, and it should be equals to minus of xt. So it is giving you a feel of even signal and it is giving you a feel of odd signal, right? Conjugate symmetry, conjugate anti-symmetry. Say yes or no. What you need to do, in place of t, you put minus t and then you take the conjugate. So this is your x of t. So what I can do, first I will put x of minus t. First I will do x of minus t. So in place of t, I will put minus t. Then what I need to do, take the conjugate. What is the meaning of taking conjugate? Plus j will be replaced with minus j. Say yes or no. All good? So now what you are getting, e to the power jt. What was this? It is equals to x of t only. So in place of plus t, I put minus t, then plus j replaced with minus j. So what you are getting, x conjugate t, x conjugate of minus t is equals to x of t. What does that mean? It is your conjugate symmetry. Okay, conjugate symmetry. What about conjugate anti-symmetry? Let's take an example. You try thinking about the example on your own. The example would be this. This is the example. Okay. What you need to do, in place of t, put minus t. What you are getting? This you are getting. And then you take the conjugate. What is the meaning of conjugate? Plus j is replaced with minus j. So minus j, here minus j, that would become plus j. So minus j e to the power jt. So what is that? Minus of xt. So x conjugate of minus t is equals to minus of xt. This is conjugate anti-symmetry. Very simple thing, very straightforward. Conjugate symmetry, conjugate anti-symmetry. Take, in place of t, put minus t and then take the conjugate. Okay. So important points, let's just say if your xt is a conjugate symmetry signal, what does that mean? CS, conjugate symmetry. So what I need to do, x conjugate of minus t would be equals to x of t. Say yes or no. So first I need to calculate x of minus t. X of minus t. This will be your x of minus t. And then I need to take the conjugate. And that would be equals to at plus jbt. Now I need to take the conjugate. So if I take the conjugate, what will happen? Plus j will be replaced with minus j. In conjugate, what happens? Plus j is replaced with minus j. Plus j is replaced with minus j. Now I need to compare both of them. So real part will be compared with real part, imaginary part will be compared with imaginary part. So a of minus t is coming out to be a of t, and minus of bt, minus of b of minus t is coming out to be bt. Or what I can say, minus sign goes this side. If minus sign goes this side, then minus of bt. What did I do? I did nothing. X conjugate minus t is equals to x of t for conjugate symmetry signal. So what did I do? A of minus t plus j b of minus t, then I take the conjugate. So I just need to put in place of t you put minus t, and then in place of j you put minus j. So this is what you will get, and it should be equals to at plus jbt. So from here what I am getting, this thing I am getting, this thing I am getting. What does this mean? Even. And what does this mean? Odd. What was this? This was the real part. And what was this? This was your real part, and this was your imaginary part. So for conjugate symmetry signal, real part of xt is even and imaginary part of xt is odd. If you can remember it, then you can remember it. If you forget it in the examination hall, just derive it. Let's just say I give you a set of 10 signals. I give you a set of 10 signals and I ask you whether it is conjugate symmetry or conjugate anti-symmetry. So will you do this thing again and again? No. What you are going to do, you will derive this thing, you will get to know that real part even, imaginary part odd. So there you will see real part even, imaginary part odd, conjugate symmetry. Real part even, imaginary part odd, conjugate symmetry. If something else is there, that means not conjugate symmetry. Are you getting this point? So this is just a shortcut that we have created. In the examination hall, I am not gonna do in place of t minus t, then you take the conjugate. No. If I forget all these things, then within seconds I will derive it. X of t, x conjugate of minus t. That means real part even, imaginary part odd. So now I have the concept that if particular signals are there, if the set of 10 signals are there, then real part even, imaginary part odd. If I am getting this thing, that means it is conjugate symmetry. Derive the same for conjugate anti-symmetry as well. You can do it on your own. Derive the same for conjugate anti-symmetry. What you need to do? X conjugate of t, in place of plus t you put minus t, and that would be equals to minus of xt. So in place of t I am putting minus t, in place of j I will put minus j, and that should be equals to minus of at. That would be actually equals to, you will be getting confused, minus of at plus j bt. Say yes or no. So from here what I am getting, this is equals to minus at minus j bt. So from here what we are getting, a of minus t is equals to minus of at, and here minus of b of minus t is equals to minus of bt. So what you are getting, minus minus sign is getting cancelled out. So b of minus t is equals to minus of bt. So what is this? Odd. And what is this? Even. So for conjugate anti-symmetry signal, real part even, imaginary part odd. Oh, sorry. Real part odd, imaginary part even. Real part odd, imaginary part even. So in conjugate anti-symmetry, real part is odd, even part is imaginary part is even. And what if both of them are even or both of them are odd? Let's just say if this is the example, cos t plus j cos t, this is your xt. So this part is also even and this part is also even. What does that mean? That this is neither conjugate symmetry nor conjugate anti-symmetry, right? But what if this is the example, cos t plus j sin t? So you know this is your even, this is your odd. So real part even, imaginary part odd. What does that mean? It is your conjugate symmetry. And cos t plus j sin t can be written as e to the power jt. And we saw that e to the power jt is conjugate symmetry only. So we can verify it here as well. So real part even, imaginary part odd, right? And what if this is the scene? Just otherwise, sin t plus cos t. So what will happen? This will become odd and this will become even. So real part odd and imaginary part even. Real part odd, imaginary part even. That means it is conjugate anti-symmetry. Okay. So in that manner we can check. In this manner we can proceed. Right. So even signal, odd signal, conjugate symmetry, conjugate anti-symmetry, neither even, neither odd, neither even nor odd, and neither conjugate symmetry nor conjugate anti-symmetry. Say yes or no. Now let's solve some question. You need to comment on the nature of xt. pt, xt is equals to pt plus j qt. pt is given as alpha t plus alpha of minus t, and qt is given as beta t minus of beta minus t. Okay. Comment on the nature of xt. So I know that I can check here if this is even function or odd function. If I know that this is even and this is odd, then it would be conjugate symmetry. If this is odd, this is even, then it would be conjugate anti-symmetry. So I need to check pt and qt. So what if I do P of minus t. What I am getting as P of minus t? P of minus t would be alpha of minus t. In place of t, you put minus t. In place of t, you put minus t. And here you will get alpha of t. So alpha of minus t plus alpha of t. Alpha of minus t plus alpha of t. That would be equals to Pt only. So here what you are getting? P of minus t is equals to Pt. Even. What about Q of minus t? Q of minus t would be beta of minus t minus of beta of t. Can I take minus sign outward? Yes. So beta of t minus of beta of minus t. That is equals to minus of qt. So q of minus t is equals to minus of qt. That means it is odd. So real part even, imaginary part odd. What does that mean? xt is conjugate symmetry. That's it. Okay. So always if it is broken down like this, you just need to check what is the nature of real part, what is the nature of imaginary part, and from there you can tell whether it is conjugate symmetry or anti-symmetry. Same goes for this one. Just I changed a bit. From here what you will get to know that Pt is odd. How? Put P of minus t, that would be alpha of minus t minus alpha of t. Then you can take minus sign outward. So P of minus t is coming out to be minus Pt and Qt would be even. Directly you can see Q of minus t is equals to Qt only. Because if you put negative sign here, this would be negative, this would be positive, and both would be same only. So Q of minus t would be equals to Q of t. That means real part odd and imaginary part even. So now your x of t is conjugate anti-symmetry. Right? What about this one? Both are even here, right? Both are even. Pt is also even. Directly you can see P of minus t would be equals to alpha of minus t plus alpha of t. So Pt is also even. And what about Qt? Qt will be beta of minus t plus beta of t. This is also even. So even. Real part is also even and imaginary part is also even. So it is xt is neither conjugate symmetry nor conjugate anti-symmetry. Okay, none of them, neither conjugate symmetry nor conjugate anti-symmetry. Well and good. So in that manner we can check. Now you need to break down your xt into conjugate symmetry and conjugate anti-symmetry part. Yeah, and that's the last part. So just break down your x of t into conjugate symmetry and conjugate anti-symmetry part. We have broken down our xt into even part and odd part. Similarly, I need to break down into conjugate symmetry and conjugate anti-symmetry part. So what I can do, I can take the conjugate and put in place of t minus t. So I will take the conjugate. Basically, a plus b conjugate can be written as a conjugate plus b conjugate. So conjugate can be given like this. So x conjugate symmetry t conjugate plus x conjugate anti-symmetry t conjugate. Okay, there is minus t as well. In place of t, you need to put minus t. In place of t, you need to put minus t. Right? This is your conjugate symmetry part, right? So for conjugate symmetry, what you have studied, that in place of t, you put minus t and then you take the conjugate. It would be equals to x of t only. And in place of conjugate anti-symmetry, what did you do? What did you study? It would be equals to x conjugate t actually. And in place of conjugate anti-symmetry, what did you study? That take the minus sign and take the conjugate, minus sign will come outward. Say yes or no. Okay. So what I can see from here, x conjugate of minus t would be equals to x conjugate symmetry t, because this is equals to x conjugate symmetry t, and this would be equals to x conjugate anti-symmetry t. Right? This is equation 1. This is equation 2. Add both of them, what you will get? X conjugate symmetry t would be equals to xt plus x conjugate minus t by 2. And what about the anti-symmetry part? Anti-conjugate symmetry, conjugate anti-symmetry, conjugate anti-symmetry. So that would be conjugate anti-symmetry. So x of t minus of x conjugate of minus t divided by 2. This would be the second one. First one and second one. If you want to remember it, you can remember it. If you forget it, you can derive it in the examination hall. X conjugate t would be equals to x of t plus x of conjugate minus t divided by 2, and x conjugate antisymmetry t would be equals to x of t minus x of conjugate minus t divided by 2. Okay, so it might happen that there could be one question from this particular topic, but that is very rare. Till now, I don't think any question has been asked from conjugate symmetry and antisymmetry, but these are mentioned in the textbook. That's why we need to study it. But these are very, very straightforward. Nothing is complex here. Very straightforward. So within 1 minute or 2 minutes, you will be able to revise everything. Just you see, start from here. What is the definition? Then real part even, imaginary part odd. Then you see these kind of questions, and then you know this is how I can break it down. That's it. Conjugate symmetry and antisymmetry. This is also completed. Now these are also mentioned in textbook. Like there is something called causal signal, there is something called non-causal signal, and there is something called anti-causal signal. So what is the meaning of a causal signal? So causal signal means that it will be 0 for t less than 0. For t less than 0, it should be 0. That means it should be non-zero only for t greater than 0. It should be non-zero only for t greater than 0. That means for t less than 0, it could be 0. But for t greater than 0 as well, it could be 0. But after that, it could be anything. Basically, for t less than 0, it has to be 0. This is the required condition. That for t less than 0, I should not see anything. The next one is anti-causal. So anti-causal says that it should be 0 for t greater than 0. That means for t greater than 0, I should not be seeing anything. For t greater than 0, I should not be seeing anything. That means all these conditions should be 0. After that, here for t less than 0, it could be anything. For t less than 0, it could have any kind of function. So this is your causal, this is your anti-causal. What about non-causal? That is neither causal, neither anti-causal, that would be non-causal. Okay. So non-causal could be 0, non-zero, it could be anywhere or anything like that. So non-causal signal could be somewhat like this. That for t less than 0 as well, it is non-zero. For t greater than 0 as well, it is non-zero. So it could be somewhat like this. That for t less than 0, you can see it is non-zero. For t greater than 0 as well, it is non-zero. So somewhat like this. Very, very rare chance, like 0.1% chances are there that these kind of question would come. But you should know causal signal, anti-causal and non-causal, because these terms we will be using when we study transform. In Laplace transform, I will be using causal signal, anti-causal, non-causal. So you should be knowing what I am talking about. Causal signal, that means for t less than 0, everything is 0. For t greater than 0, everything is 0. That means anti-causal, and non-causal, it could be anything. Well and good. So that's it about our continuous time signals. Now we need to study about discrete time signal. So whatever that we have studied in continuous time signal, everything we need to study about. Everything we need to study in your discrete time signals as well. But that would be very easy, because for continuous time signal, we have spent more than enough time. At least, I guess, 25 hours we have spent, or 26 hours we have spent on studying continuous time signal. Now your discrete time signal would be a simple cakewalk. Within 2 to 3 lectures, maximum 3 lectures, we will be able to finish our discrete time signal. Okay. Thank you very much. Hi everyone, welcome back. So we need to get started with the discrete time signals now. So it is very easy. We have already studied about continuous time signal. Now we need to study about discrete time signals. Say yes or no. So from continuous time signal to discrete time signal, how do we come? By sampling. And that process we have already seen. From continuous time to discrete time, we will come by sampling. And that process we have already seen. And from there we made a conclusion that this is an integer. Right? We have already made a conclusion that this n is an integer. Why it is an integer? Because n shows the number of samples. It is not the time. N is not the time. N is the number of samples. That means it is the first sample, it is the second sample, it is the third sample, this is the fourth sample. This is -1 sample. That means before t equals to 0, we collected this sample. Then this was the second sample before t equals to 0. This was the third sample before t equals to 0. And this was the sample at, like this was the 0th sample. That means this was the sample at t equals to 0 second. So in that manner, we have studied it. So you already know that n should be integer. Now this is how we will show a discrete time signal. That means at n equals to 0, the value is 3, n equals to 1, the value is -2, n equals to 2, value is 0. So this is one way of representation. The other way could be, you will get started from here. For n equals to -4, everything is 0. For n equals to -5, it is 0. For n equals to +5, it is 0. If I am not showing, that means it is 0. For n equals to -4, it is 0. So those which are 0, that I'm not going to write down. I'm starting from n equals to minus 3. So I will always go from minus infinity to plus infinity. So at n equals to minus 3, your value is minus 3. At n equals to minus 2, your value is 0. At n equals to minus 1, your value is 2. At n equals to 0, your value is 3. At n equals to 1, your value is minus 2. At n equals to 2, your value is 0. At n equals to 3, your value is 4. At n equals to 4, your value is 3. And after that, everything is 0, so I am not going to write it down. So by default, if I am closing it, that means after that everything is 0, and here also it is closed, that means before this everything is 0. Now if this thing is given to you, then you wouldn't know which magnitude is there at n equals to 0, which magnitude is there at n equals to 1. So that's why we need to show an arrow. I will show an arrow here. Now this arrow shows that this is n equals to 0. If this is n equals to 0, this will be n equals to 1. This will be n equals to 2. So if I ask you what is the value of sample at n equals to 2, so the value is 0. Okay, and if this is n equals to 0, what does that mean? This would be n equals to minus 1, this would be n equals to minus 2, this would be n equals to minus 3. So wherever the arrow is shown, they will only show like this. This function will be given, they will only show like this. So wherever the arrow is given, you will understand that okay, this is the n equals to 0 point. So next will be n equals to 1 point, n equals to 2, n equals to 3, n equals to 4. This would be n equals to minus 1, n equals to minus 2, n equals to minus 3. So this is how it should be shown. So there are two ways of representing. This is the waveform, and this is how I will be writing it down. Okay. Let's just let me know these value. What is the value of x equals to 1? At x equals to 1, the value is minus 2. Now just let me know these values, 3 by 2, minus 1 by 2. These values will be 0 because this n has to be an integer. If it is non-integer, let's just say if it is here 1 by 2, it would be 0. 3 by 2, it would be 0. 5 by 2, it would be 0. 7 by 2, it would be 0. So all these values which are not integer, they have to be 0. They have to be 0. Will this also be 0? No, this is x equals to minus 2 only, no? Minus 6 by 3, this is n equals to minus 2. So x equals to minus 2, what is the value? Oh, luckily it is 0 only. X equals to minus 2, luckily it is 0. X equals to minus 6, it is 0 only. X equals to 7 by 2, it would be 0 only. X equals to 4, the value is 3. X equals to 6, x equals to 6, x equals to 6, the value is 0. So if I say any non-integer here, then blindly I can put the value to be 0. Otherwise, I need to check in the waveform. So till now, what we have seen in discrete time signal, that how you can come from continuous to discrete by sampling. N has to be always integer. This is the one way of representing that this is the waveform is given. How will you represent in this form? So for that, what you need to do, you need to make a set. N equals to 0 should be the center. That means I will put the arrow here. So this is the n equals to 0 at 3. After that, n equals to 1, 2, 3, 4, 5. Before that, n equals to minus 1, minus 2, minus 3. In that manner, it will go. All clear? Okay. Draw n equals to n minus 1. What do we do in time domain? X equals to t minus 1. If I say x equals to t minus 1, that means I will shift the waveform towards the right hand side. Opposite sign is there. Minus 1. That means I will shift the waveform towards the positive hand side. If minus sign is there, that means I will be shifting it towards the positive hand side. If plus sign is there, that means I will be shifting towards the negative hand side. So now I need to shift my waveform. I need to shift this waveform backward. Okay. Sorry, not backward. X equals to n minus 1 is there, no? So I need to shift it towards the positive hand side. So I need to shift this waveform ahead. So what I'm gonna do, I will just copy this, paste it here. So what will happen? Whatever that is there at n equals to 0, that will come at n equals to 1. Are you getting this point? This waveform will shift n equals to n minus 1. So waveform will shift ahead. So whatever that is there at n equals to 0, that will come at n equals to 1. Whatever that is there at n equals to 1, that will come at n equals to 2. These points will shift ahead. So basically what I need to do is that yeah, so waveform is being shifted ahead. So I'm just shifting the waveform. So this waveform is being shifted. So this n equals to -1 will come at 0. So 2, 3 and then -2. So 2, 3 and then -2. This would be n equals to 0 now. Then it would become 1, 2, 3, 4, 5, 6 and so on. Similarly here, this would become -1, this would become -2 and in that manner. Let's call it y of n. Okay. So if I find the value of, let's just say I find the value of y of 3. So y of 3 will be equals to x of 2. So what was the value of x of 2? X of 2 was 0. So y of 3 is 0? Yes, y of 3 is 0 only. So you understood that I just need to shift towards the positive hand side, right? Since there is a negative sign, so I will shift towards the positive hand side. This magnitude was 2, this magnitude was 3. This was -2 only, -3 only, 4, 3. Well and good. Now, how will you represent x of n minus 1? And here I am representing my x of n in this set form. When I represented in the set form, how did I represented x of n? So this is how I represented it. -3, 0, 2, 3. So started with -3, then 0, then 2, then 3, then 2, sorry, then -2, then 0 was there, 4 was there and 3 was there. This is how I represented it. I am simply copying from here and this was your n equals to 0. Arrow was here. How are you going to represent n x of n minus 1? So look from here. You are starting from -2. So -3, after that there is 0, after that there is 2, after that there is 3, then -2, then 0, then 4 and 3. But where will be the arrow? Arrow will be here. Arrow will be at 2. So arrow actually got shifted here, right? If n minus 1 is there, so if I only shift the arrow, so arrow actually shifted here. Or you can say this sequence has been shifted towards this side. Or you can say arrow has been shifted towards this side. One thing you can say, either you can say that sequence has been shifted towards this side. So if sequence is shifted, that means 2 will come on this arrow. 2 will come on this arrow. Or you can say arrow is shifted by 1. So arrow will always shift in the opposite side. If n minus 1 is there, that means arrow will shift on the negative hand side only. But you only need to remember one thing. Better remembering the waveform. That all these sequence, you should better remember the waveform. That sequence will be shifting towards the positive hand side. And this is the same thing that used to happen with the time domain as well. X of t plus 1 or x of t minus 1. So how will you make x of t minus 1? X of t minus 1 means it will be shifted by 1 towards the positive hand side. So this sequence have been shifted by 1 towards the positive hand side. That means on the arrow, the number 2 would come. So now on n equals to 0, 2 would be there. So this is how I will be shifting it. Okay. Now one more important thing. Let's just say I write down x of n shifting I am doing. I will shift by n naught towards the positive hand side or towards the negative hand side. So I am doing the shifting. Now this n naught has to be integer. This n naught has to be integer. Now what if it is not an integer? Let's just say it is n plus 2 by 3. Will that make any sense? If I say it is x of n plus 2 by 3. So your waveform will be shifted by 2 by 3. That means whatever the point that is at 0, that will come at -2 by 3. Because it is n plus 2 by 3, that means you need to shift your waveform towards the negative hand side by 2 by 3. So 0 will come at -2 by 3. 1 will come at 1 by 3. Because 1 minus 1 by 3 would be, 1 minus 2 by 3 would be 1 by 3. 2 will come at 2 minus 1 by 3. And all these values will be non-integer. -2 by 3, 1 by 3, all these values will be non-integer. Basically, you are saying that at n equals to -2 by 3, your value is 2. At n equals to 1 by 3, your value is 3. At this particular value, your value is -2. But it is not possible, no. N has to be integer. If I say x of n plus 2 by 3 is equals to y of n, it will not make any sense. Because n has to be an integer. So if I put y of 0, what will be my y of 0? Y of 0 will be equals to x of 2 by 3. And I told you, if here there is no integer, if this particular thing is not integer, that means the value has to be 0. So y of 0 is actually 0. If I put y of 1, that would be equals to x of 1 plus 2 by 3, that would be 5 by 3. Again it is not integer, again it is 0. So y of 0 would be 0, y of 1 would be 0, y of 2 would be 0, everything would be 0. That means the sequence would be 0. So it doesn't make any sense. That's why n naught has to be an integer. Because if it is an integer, then we will be shifting from integer to integer only. Here n of 0 went to n of plus 1, n of 1 went to n of plus 2, 2 went to 3, 3 went to 4, 4 went to 5. This is what happened here, and minus 1 went to 0, right? So that's why this n naught has to be integer. So in the examination you will never find that it is a some rational or like it is a non-integer value. This will never be a non-integer value. In the examination this will never be a non-integer value, because if it is a non-integer value, then your sequence wouldn't make any sense. Your sequence will simply be 0 only. Okay, if it was non-integer, then sequence would become 0. Well and good. Yeah, so we have seen x of n minus 1. Let's make x of minus n. What do you think what will be x of minus n? Simply the mirror image. What you need to do, you need to take the mirror image of this one. This is your x of n, which I have already copied, I guess. Let's copy it again. We just need to take the mirror image of this one. How will I take the mirror image? So when we are taking the mirror image at whatever that is at 0, that will remain there only. I need to take the mirror image. So whatever that is at 1, that will come at minus 1. So at 1 you are having minus 2. So at minus 1 you will have minus 2 now. Whatever that was at 2, that will come at minus 2. Whatever that was at 3, that will come at minus 3. So at minus 3 you will have plus 4 now. And at minus 4 you will have plus 3 now. Right? 4 and 3. Now these guys will also change, you know. These will also change. So whatever that was at minus 1, that will become at plus 1. So what was there at minus 1? At minus 1 there was plus 2. At minus 1 there was plus 2. So at plus 1 you will have the plus 2 now. At plus 1 you will have the plus 2 now. What was there at minus 2? At minus 2 it was 0. So at plus 2 as well you will be having the 0. At minus 3 it was minus 3. So at plus 3 you will have minus 3 now. At plus 3 you will have minus 3 now. So just I am taking the mirror image, nothing else. So this will be your minus 3. This was actually your 2. Well and good. And after that at minus 4 it was 0. At minus 4 it was 0. At minus 5 it was 0. So at here also minus 4 it would be 0. Minus 5 it would be 0. And what was your x of n? What was your x of n? So this was your x of n. So I am just copying it here. This was your x of n. What would be your x of minus n? What do you think? So x of minus n came out to be 3, 4, 0, minus 2, 3, 2, 0, minus 3. And whatever that was at 0, this remains as it is. Whatever that was at 0, so this remains as it is. So what you are doing actually, about this you are taking the mirror image. This minus 2, this comes here, this goes here. About this 3, this minus 2 comes here, this goes here. This 0, both zeros are interchanged, so you are actually not seeing any difference. This 0 and this 0 is interchanged. Now what about this? Minus 3 and 4. So this minus 3 and 4. So 4 comes here and minus 3 goes here. Minus 3 goes ahead. So you can see this 2, 0, minus 3. 2, 0, minus 3. From here, minus 2, 0, 4, 3. Minus 2, 0, 4, 3. So you just need to take the mirror image about this n equals to 0. So we are just taking the mirror image about this n equals to 0. Nothing else. Well and good. So x of minus 1 minus n also we have drawn. Now x of n by 2. What we need to draw? X of n by 2. So again let's copy x of n. Let's copy x of n. If I need to make x of n by 2, what does that mean? That I need to divide, if I was making from x of t, if I was going from to x of t by 2. So what I was saying, my time domain is being divided by 2. That means I need to multiply my time axis by 2. So here also I will do the same thing. Here it is being divided by 2, so I will multiply my time axis by 2. So this point will become 2, 2, 2, 2 and 2. Multiply by 2, multiply by 2, multiply by 2. All these will be multiplied by 2. So now hear me out. This will be x of n by 2. So x of n by 2. x of n by 2. So what will be your x of n by 2? Let's check that out. So what is the first value where it is 0? 3 into minus 3 into 2, this will be minus 6, this will be minus 4, this will be minus 2, this is 0, this will be plus 2, this will be 4, this is 6, this is 8. So getting started with minus 6, at minus 6 you are having minus 3, at minus 5 what you are having, you don't know, at minus 5 what I am having, I don't know, at minus 4 what I am having, 0, at minus 3 what I am having, I don't know, at minus 2 what I am having, 2, at 0 what I am having, 3, at 1 what I am having, I don't know, I directly know 2, so at 1 what I am having, I don't know. Wait a second, did I do something? At minus 2 you are having 2, what I am having at minus 1? At minus 1, look, minus 3, then at minus 5 what I am having, I don't know, at minus 4 I am having 0, at minus 3 what I am having, I don't know, at minus 2 what I am having, 2, at minus 1 what I am having, I don't know, at 0 what I am having, 3, at 1 what I am having, I don't know, at 2 what I am having, minus 2, at 3 what I am having, I don't know because I directly know 4, at 4 what I am having, 0, at 5 what I am having, I don't know, at 6 what I am having, 4. At 7 what I am having, I don't know, at 8 what I am having, 3. After that everything is 0 only, after that everything is 0, so I don't need to show it, so I will just close it here. So this was your n equals to 0. What was your x of n? What was your x of n? So it was minus 3, 0, 2, 3, minus 2, 0, 4, 3, right? And here was the arrow n equals to 0. So just as you did x of n by 2, let's copy it there, let's copy it there, copy, okay, I need to add a page. So just as I did x of n by 2, what really happened? This was your n equals to 1, but it got multiplied with 2. This was your n equals to 2, but it got multiplied with 2. This was your n equals to 3, but it got multiplied with 3. And this was your n equals to 4. Wait a second, what I am doing? N equals to 1, n equals to 1 multiply with n equals to 1 multiply with 2, n equals to 2 multiply with 2, n equals to 3 multiply with 2, and n equals to 4 multiply with 2. Same goes to this one as well, n equals to minus 1 multiply with 2, n equals to minus 2 multiply with 2, n equals to minus 3 multiply with 2. So this point became minus 6. At minus 6 you are having 0. Then directly you know at minus 4. So what value I will have here? Some alpha. It could be any random value. Usually people show it by 0. What I mean to say is that this is your n equals to minus 6. Now I don't know what I am having at n equals to minus 5. So usually say that people say that it would be 0. But it could be any random value because you don't know the sample at n equals to minus 5. If I am having only the information of x of n, I don't know if I calculate x of n by 2, so what will be the sample at n equals to minus 5? I don't know that. Are you getting this point? Usually people show it by 0, but we cannot comment. The point is we cannot comment actually. Are you getting this point? Well and good. So you can show it by 0 or you can say I cannot comment. So any random value it could be any random value, let's just say it is alpha. Then after that we are having 0. Then after that it is any random value beta. After that we are having 2. This would be n equals to minus 4. This would be n equals to minus 3. This would be n equals to minus 2. Then n equals to minus 1. What I am having I don't know. Then at n equals to 0. Then n equals to minus 1. What I will be having I don't know. So I am putting at a. N equals to 2 minus 2. N equals to 3 I don't know. N equals to 4 0. N equals to 5 I don't know. N equals to 6. N equals to 7 I don't know. N equals to 8 3. Okay, and this is your n equals to 0 point. So it is being expanded. Just as I did n by 2, it will be expanded. 3 then dash minus 2 dash 0 dash 4 dash 3. 3 dash minus 2 dash 0 dash 4 dash 3, and same goes to this side as well. So it got expanded, and if I do x of 2n, then it will be shrinked. So what was your x of n? This was your x of n. This was your x of n, right? This was actually of n equals to 1. This was n equals to 2. This was n equals to 3. And this was n equals to 4. Now what I need to do? X of 2n. That means I need to divide by 2. If I was doing n by 2, that means I need to multiply. So if I am doing 2n, that means I need to divide by 2. My time domain is being multiplied by 2, that means my time axis will be divided by 2. N equals to minus 1 by 2, n equals to minus 2 by 2, and n equals to minus 3 by 2. Just tell me one thing, n equals to 1 by 2, does this make any sense? N equals to 1 by 2, you know that n equals to 1 by 2 has to be 0, n has to be integer. So this does not make any sense. In the previous example, everything was making sense, 2, 4, 6, 8, because these were integer already. But this is not making any sense. N equals to 1 by 2. If this is not making any sense, this will be cancelled out. N equals to 3 by 2 doesn't make any sense. N equals to 4 by 2 makes sense. N equals to minus 1 by 2 doesn't make any sense. At n equals to minus 3 by 2 doesn't make any sense. So what you are getting from here? That at n equals to minus 2 by 2, that means this is your n equals to minus 1. This is your n equals to 0. This is your n equals to 1. And this is your n equals to 2. Right? So x of 2n. You will start from minus 1. At minus 1 you are having 0. At 0 you are having 3. At 1 you are having 0. And at 2 you are having 3. I can reduce it like this as well. 3, 0, 3. And here. Because for n less than 0, everything is already 0. Basically, this was your x of n waveform. This was your x of n waveform. When I calculated x of 2n, then I got to know that whatever that I was having at 1, this will also get cancelled out, 3 will also get cancelled out, and 5 will also get cancelled out, minus 2 will also get cancelled out. Sorry, not minus 2, minus 1 will also get cancelled out, and minus 3 will get also cancelled out. Why is that so? Because when I divide them by 2, they will not be an integer. Minus 1 by 2 not an integer. Sorry, 1 by 2 not an integer, 3 by 2 not integer, 5 by 2 not integer, minus 1 by 2 not integer, minus 3 by 2 not an integer. So only minus 2 will be left, which is already 0. So for n less than 0, there is no sample. At n equals to 0, this will remain as it is, and at n equals to 2, this will remain as it is, n equals to 4, this will remain as it is. But this will become 1 and this will become 2. Are you getting this point? Although I am not going to ruin this diagram, but you are understanding the concept now. Okay? We will see more example, don't worry. We will see more example. Let's see more example based on this. So this we have seen, that is x of 2n, and now you can draw the diagram as well. On your own you can draw the diagram. This would be your x of 2n. Let's see more example. Let's add a page. Question x of n. Let's not call it x of n, let's call it y of n. So let me frame a question. I will frame a question and then we will see it. Yeah, solve this one. Y of n is given, you need to find y of 3n. So I know that this is n equals to 0. This sequence is given. This would be n equals to 1. Rest n equals to 2. Then this would be n equals to 3. Same goes this side as well. N equals to minus 1 in that manner. What I need to calculate? Y of 3n. That means everything I need to divide by 3. What do you think? 1 by 3, this will make any sense? No. This will make any sense? 2 by 3? No. This will make any sense? Yes, this will become n equals to 1 actually. This will make any sense? No. This will make any sense? No. But yeah, this will make any sense. Why is that so? Because this is n equals to minus 3. This is your n equals to minus 3. So minus 3 divided by minus 3, this will become actually minus 1. This will be minus 4 by 3, not an integer. Minus 5 by 3, not an integer. 4 by 3, not an integer. 5 by 3, not an integer. 6 by 3, integer. 7 by 3, not an integer. 8 by 3, not an integer. So what you are left with? Y of 3n. Y of 3n would be equals to, you have started with here, 1 is left, then minus 1 is left, after that 4 is there, and after that minus 3 by 2 is there, and this was your n equals to 0. This would be n equals to 1, this would be n equals to 2, and this would be n equals to 3. This would be your n equals to -1, n equals to 1, and n equals to 2. Not 3, it would be n equals to -1. So -1, 0, 1, and 2. This is how it will go. Okay. So whatever the number that is written here, just divide by that. So if I am doing y of 3n, that means 2 samples are getting cancelled, 0 and 3, -2 and -1, whatever it was, 1 and 3. So 2 samples are getting cancelled. 2 samples got cancelled, 1 is there. 2 samples got cancelled, 1 is there. 2 samples got cancelled, 1 is there. If I had to calculate y of 4n, then 3 samples would be getting cancelled. So whatever that is as 0, that will remain there as it is. Then y of 4n I need to calculate. So 1 by 4 doesn't make any sense. 2 by 4, not an integer, doesn't make any sense. 3 by 4, not an integer, doesn't make any sense. -2 will be coming now. After that, 5 by 4, no. 6 by 4, no. 7 by 4, no. 8 by 4, yes. Coming towards this side. So this would be -1 by 4, no. -2 by 4, no. -3 by 4, not an integer, doesn't make any sense. -4 by 4, yes. After that, 5 by 4, no. So this would have been the answer. Are you getting this point? So here I am cancelling 3 samples. Started with here 1, 2, 3 sample got cancelled, -2. 1, 2, 3 sample got cancelled, 3. So -1, -2, 3. From here 1, 2, 3 got sample cancelled, 2. Then only one sample is there which got cancelled. So are you understanding the point? Whatever that is there at n equals to 0, nothing is happening with that. But after that, samples are getting cancelled. And if I was doing n by 2, then samples were getting more. Samples were getting expanded. The time domain was being expanded, right? And what if I do 3n by 2? Previous x of n I need to take. This x of n I need to take. This x of n I need to take. Now people will have multiple approach that I will start with x of n. Next I will do x of 3n, and then I will go to x of 3n by 2, right? So if someone goes by this approach, so x of n you are already having, let's make x of 3n. That means 2 samples I need to cancel. So I am at 3, then this sample I will get cancelled. 4 I will be left with, here this and this I get cancelled, this will be -3. This is your n equals to 0. What if, next what I need to do, 3n by 2. 3n by 2. By 2, that means I need to expand now. So this is at 3. Now by 2 I need to expand. So whatever that will come here I don't know. Next would be 4. And here whatever that comes here I don't know. But next would be -3. N equals to 0 remains there as it is. After that I need to expand. That means this is n equals to 1. That will become n equals to 2. Whatever that will come in between I don't know. N equals to -1, that will become n equals to -2. Whatever that comes there I don't know. Okay. Now the other guy could be doing this thing. What he would be doing? That I will start with x of n. Then I will do x of n by 2. And then I will do x of 3n by 2. So first what he is doing? X of n by 2. That means he needs to expand it. So starting with n equals to 0, or he can start from here as well. -3, then I will put something that I don't know. Then 0, I will put something that I don't know. 2, I will put something that I don't know. 3, I will put something that I don't know. After that, this is your n equals to 0. After that, -2, I will put something that I don't know. Then 0, I will put something that I don't know. Then 4, I will put something that I don't know. And then 3. Right? Just I expanded it. Now what next I need to do? 3n by 2. Right? That means 2 samples I need to cancel. This and this will get cancelled. Say yes or no? So getting started with the 3. After that dash is coming. Here also there is dash only, no? This a I can replace with dash. This is a random sample that I don't know. This is a random sample that I don't know. So it is actually dash only. So started with t equals to n equals to 0. And I need to cancel 2 samples since it is 3n. So 2 samples I need to cancel. Then I need to pick this one. Then 2 sample I will cancel. Then I will pick this one, 4. After that 2 sample I will cancel. And nothing I need to pick. And here as well 2 sample I will cancel. Then I will pick the dash. 2 sample I will cancel. And then I will pick -3. So I am getting the same thing. X of 3n by 2 and x of 3n by 2. -3 dash 3 dash 4. Are you understanding what I am doing? What is the meaning of dash? Any random sample could come here. Alpha, beta, gamma, whatever the sample value could be. 1, 2, 3, 4, 100, 1000. I don't know the value. That's why I am putting the dash. So x of n by 2. That means expanding it. N equals to 0. Expanded. minus 2 expanded, 0 expanded, 4 expanded and 3. Same goes here as well. Minus 1 expanded, sorry, this is expanded, then 0 expanded, minus 3. Then I am putting x of 3n by 2. That means now I need to cancel your samples. 3n means I will cancel 2 samples now. So I will cancel 2 samples. That means I am here. So dash and minus 2 got cancelled, next dash is coming. 0 and dash got cancelled, next 4 is coming. Dash and 3 got cancelled. After that there is nothing. Here dash and 2 got cancelled, then dash is coming. 0 and dash got cancelled, minus 3 is coming. So both are giving you the same results. So you can do any step. You can go from x of n to 3n by 2, or you can go from n by 2 to 3n by 2. Now one guy could have done directly from x of n to x of 3n by 2. What I am saying, he would have directly gone from x of n to x of 3n by 2. Here what is happening? Your time domain is being multiplied with 3 by 2. Your time domain is being multiplied with 3 by 2. That means you need to divide it by 3 by 2 now. And if I am dividing by 3 by 2, that means multiplication by 2 by 3. Right? So now he will be multiplying the samples with 2 by 3. He will be multiplying all these samples with 2 by 3. So let's see what he will get. So this was your n equals to 0. This would have been your n equals to 1, which will be multiplied with 2 by 3. This would have been your n equals to 2, which will be multiplied with 2 by 3. Why I am multiplying with 2 by 3? Are you understanding the point? Because n is being multiplied with 3 by 2. So here your time axis should be multiplied with 2 by 3. This 3 will be multiplied with 2 by 3, and this 4 will be multiplied with 2 by 3. So this will be a non-integer. So this will get cancelled out. This will also be a non-integer. This will also get cancelled out. This will be an integer. So n equals to 2 I am getting. This will also be a non-integer. This will also get cancelled out. Same goes here as well. This would be n equals to minus 1. This would be n equals to minus 1. So minus 1 is being multiplied with 2 by 3. Here n equals to minus 2. So minus 2 is being multiplied with 2 by 3. And n equals to minus 3. So minus 3 is being multiplied with 2 by 3. So this will become minus 1. This will become minus 4 by 3. This will become minus 2 by 3. So this is also not accepted. So only you are getting n equals to minus 2. So n equals to minus 2 you are getting. Here this is your n equals to minus 2. So at n equals to minus 2 you are getting minus 3. At n equals to minus 1 what you are getting you don't know. Because directly after that you know at n equals to 0 I am having 3. At n equals to 0 I am having 3. So at n equals to minus 1 what I am getting that I don't know. At n equals to 1 what you are getting you don't know, because after that directly you know that at n equals to 2 I am having 4. So at n equals to 2 I am having 4. So minus 3 dash 3 dash 4. Minus 3 dash 3 dash 4. So all three methods are there. From x of n you go to x of 3n, then you go to x of 3n by 2. X of n you go to x of n by 2, then you go to x of 3n by 2. Directly from x of n you go to x of 3n by 2. And now you need to know the meaning of dash. The meaning of dash is there. Whatever the value of sample is there, that I don't know. It could be anything. In the examination, random number could be put here. Mostly they will put 0, but any random number can come. Okay, a very important concept. It is not necessary that it would be 0 only. It could be any random number. Okay. Draw this diagram x of n e to the power minus n. Here we are just understanding the basics of unit sequence, right? Basics. Only the basics are going on. So you need to draw this diagram. X of n is equals to e to the power minus n. So start putting the values. What will be the value of x of 0? E to the power minus 0. That would be 1. What will be the value of x of 1? E to the power minus 1. What will be the value of x of 2? E to the power minus 2. So, and what will be the value of x of minus 1? E to the power 1. E to the power 1. What will be the value of x of minus 2? E to the power 2. So basically if I draw the diagram of e to the power minus t, how the diagrams look like? E to the power minus t. This is how the diagrams look like. This is the diagram of e to the power minus t versus t. So this is your t equals to 0, then t equals to 1. So after every 1 second you are collecting the sample. Basically my x of t is e to the power minus t. If I need to calculate x of n ts, that would be e to the power minus n ts, where ts value is 1 second. So e to the power minus n it would be. So after every 1 second I am collecting the sample. So next sample I will be collecting here. And what will be the value here? E to the power minus 1. What will be the value here? E to the power minus 2. Here what will be the value? E to the power 1. Here what will be the value? E to the power 2. So this is 1, sorry, this is minus 1, this is minus 2. So in that manner I am collecting the samples. So these will be my samples. In between whatever the value that is coming, I don't care. Here e to the power 0, this would be 1. So if I draw the waveform of x of n, then how it will look like? E to the power 2, e to the power 1, e to the power 0, then slowly the samples are getting lower and lower. So in that manner it will keep on getting lower and lower. And here if I go this side, it will keep on getting larger, and if I go this side, it will keep on getting lower. These samples are getting lower and lower. So n equals to 0, 1, 2, minus 1, minus 2. Here it is increased, here it is increased. So this value would be 1, this value would be e to the power minus 1, this value would be e to the power minus 2, this value is e to the power 1, this value is e to the power 2. So this is how I will draw the waveform of e to the power minus n, right? You do this process. What you need to do, y of n is equals to 3 into x of minus 2n plus 3 divided by 3. What is the meaning of this 3? Basically all these will be multiplied with 3. At n equals to 0, the sample is having the value of 0. So 0 into 3, minus 1 into 3, 3 into 3. What used to happen in x of t? X of t diagram, if I give you, this is the x of t diagram. If I need to draw 3x of t, that means this would be 15, 5 into 3. Same thing will happen here as well. 0 into 3, minus 1 into 3, 3 into 3. Whatever the samples these values are having, if I multiply it with 3, then all these will be multiplied with 3. So all the samples will be multiplied with 3. Magnitude of all the samples will be multiplied with 3. So 3x of n you know how to draw. So what you need to do? What I need to draw? Y of n is 3 into x of minus 2n by 3 plus 1. Say yes or no. So how I will go? X of n is given. Next I can draw x of n plus 1. Next I can draw x of 2n. Always you need to start from here. That we have already seen in our continuous time. So 2n by 3 plus 1. Then what I can do? I can do the inversion. And after that I can multiply with 3. Right? So let's start. X of n is given. Now I need to do x of n plus 1. What does that mean? That my sequence will be shifted towards this side. X of n plus 1. N plus 1. That means sequence will be shifted towards the negative hand side. Sequence will be shifted towards the negative hand side. So all these sequence will be shifted towards negative hand side by the amount of 1. By the amount of 1. That means this minus 1 would come in place of 0. This minus 1 would come in place of 0, or you can say the arrow is shifted here. So what I will do, I will just copy this sequence. I will just copy this sequence here, and I will just say that my arrow has been shifted here, or you can say the sequence has been shifted here. So this would become n equals to 0 now. So this is your x of n plus 1. This is your x of n plus 1. Next I need to do 2 by 3. So everything will be multiplied with 3 by 2. Doesn't make any sense. N equals to 2. So this is your n equals to 2, which will be multiplied with 3 by 2. And this is n equals to 3, which will be multiplied with 3 by 2. So this will not make any sense. This will also not make any sense. 3 by 2 it would be, 9 by 2 it would be, but this would be n equals to 3. This will make any sense. So similarly here as well, minus 1 into 3 by 2, this will not make any sense. Minus 2 into 3 by 2, this will make any sense. Minus 3 into 3 by 2, this will not make any sense. Minus 4 into 3 by 2, yeah, this will make sense. Minus 5 into 3 by 2, doesn't make any sense. Minus 6 into 3 by 2, minus 6 into 3 by 2. So it would be minus 9. And now minus 4 into 3 by 2. Sorry, this was your n equals to 0, 1, 2, 3, 4, 5, 6, 7. So minus 7 into 3 by 2. Again doesn't make any sense. So what all samples we are getting? This was your n equals to 0, starting with here. Now just let me know, this was your n equals to 0, this is your n equals to 2. This became your n equals to 2. N equals to 2. Eventually this became your, not n equals to 2, sorry. This was already n equals to 2. So this became 2 into 3 by 2. This became n equals to 3. This became n equals to 3. What about this one? This also became n equals to minus 3, because minus 2 is being multiplied with 3 by 2. So this became n equals to minus 3. This became n equals to minus 3. What about this one? This was your minus 1, minus 2, minus 3, minus 4. So minus 4 into 3 by 2. So this became n equals to minus 6. So this became n equals to minus 6. What about this one? This was your minus 4, minus 5, minus 6. So minus 6 into 3 by 2. So this became your minus 9. This became minus 9. So you are having the sample at minus 9. You don't know the sample at minus 8 or minus 7. Then you are having the sample at minus 6. You don't know the sample at minus 5 and minus 4. Then you are having the sample at minus 3. Then you don't know the sample at minus 2 and minus 1. Then you are having a sample at n equals to 0. Then you don't know the sample at n equals to 0. Then you don't know the sample at 1 and 2. Then you are having the sample at n equals to 3. After that, there is nothing. Are you getting this point? So this would be the sequence: 0 dash dash 4 dash dash 7. Or you can go by the process as well, that n by 3 first I do, then I do 2n plus 2n by 3 plus 1. But I can do it in one step only. 2 by 3 means I need to multiply with 3 by 2. So what all makes sense, what all doesn't make sense, that I need to see. So wherever you are not getting the integer, that will not make any sense. Whenever I am getting the integer, that will come out. And that will come out, the new value will come out. So this will be n equals to 3. Or if I go by first n by 3, that means it will be expanded, then n by 2, then it would be cut down. Expanded and then cut down, or first you can cut down, or after that you can expand it. So it's your choice. Next, I need to take the mirror image. So x of minus 2n by 3 plus 1, I need to take the mirror image. X of minus 2n by 3 plus 1. X of, yeah, this was your x of 2n by 3 plus 1. Now I need to take the mirror image. So in the mirror image, whatever that is at 0, that will be as it is. Minus 1 will be as it is. But this part will come here, this part will come here, and minus 2 will come here. So dash, 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 and minus 2. What about this one? Dash, dash 7, dash, dash 7, then dash, dash 4, dash, dash 4, then dash, dash 0. Dash, dash. Although this 0 has no meaning, you can avoid it as well. But let's keep it. Dash, dash 0. So this was there as it is. This was your n equals to 0. Now this became n equals to minus 1, minus 2. This became n equals to minus 3 actually. Right? This became n equals to 3. This became n equals to 6. This became n equals to 9. So whatever that was there at n equals to minus 9, that became at n equals to plus 9. Whatever that was there at n equals to minus 6, that became at n equals to plus 6. N equals to minus 3 became n equals to plus 3. N equals to 0 is n equals to 0. N equals to plus 3 became n equals to minus 3. Right? Now next what I need to do, I just need to multiply by 3. I just need to multiply here by 3. So every sequence I will multiply by 3. So minus 2 into 3, minus 6. Minus 1 into 3, minus 3. Minus 3. 7 into 3, it was 7 only, yeah. 7 into 3, 21, and that would be 12. 7 into 3, 21, this would be 12. 0 into 3 would be 0 only. So this is the final sequence. Minus 6 dash dash minus 3 dash dash 21 dash dash 12 dash dash 0. Any random value could be put in place of dash. Well and good. Okay. So this we have seen 3x minus 2n plus 3 divided by 3. Draw the diagram. X of n is equals to 1 to the power n. it would be always 1, right? X of 0, 1 to the power 0 would be 1. X of 1, 1 to the power 1 would be 1. X of 2, 1 to the power 2 would be 1. X of minus 1 or minus 2, 1 to the power minus 2, that would also be 1. So always it will be 1. This is your X of n. So you put n equals to 0 or everywhere it will always be equals to 1, 1, 1. So n equals to 0, 1, 1, 1. It is always 1. It's always 1. Here as well it is 1, 1, 1. In that manner it will always be 1. Here also 1. This is your n equals to 0, 1, 2, 3. Minus 1, minus 2, minus 3. In that manner it will always be 1. You try doing this on your own. You need to draw. Look, let me explain the waveform. From minus 2 to infinity, it is always 1. 1, 1, 1, and then I have made dash dash. That means it is always 1. Before that it is all 0. Minus 3 it is 0, minus 4 it is 0, minus 5 it is 0. You need to draw x of n minus of x of minus n minus 1. So you already know this thing. You try drawing this thing and then you subtract them. So I already know my x of n, that is 1, 1, 1, 1, 1, 1. It will keep on going like that, but here I will put the arrow because this is n equals to 0, n equals to minus 1, n equals to minus 2. Okay. Now x equals to minus n, x minus n minus 1. So x n minus 1 first I can draw and then I can go here minus n minus 1. But do you remember one thing? If you already know x of t, can you draw x of minus t plus 2, or can you draw x of minus t minus 1? Two mistakes I need to do. I will start from here. So two mistakes I will do. First inversion and then shift in the opposite side. So minus n minus 1. So first inversion and then shift minus 1, that means you shift towards the left hand side or towards the negative hand side. So first you do the inversion. That means this was going from 0 to infinity, now it will go from 0 to minus infinity, and this minus 2 will come at plus 2, and this minus 1 will come at plus 1, this minus 3 will come at 0. Are you understanding this point? Basically it will always be 1, 1, 1 here, 1, 1, 1 here. Here as well it will be 1, but here it would be n equals to minus 1 would become plus 1, n equals to minus 2 would become plus 2, and after that it is all 0. Is that okay for you? I just did the inversion. I did the inversion, then minus 1. What we are doing? We are doing the opposite process. We are not going by this process, that x of n, then go to x of n minus 1, then go to x of minus n minus 1. Ideally we should go like this only. From here we need to start. But I am going from here. And if you have studied continuous time signal, I told you there is a trick. We can do two mistakes. So one mistake we did. Now second mistake, if there is minus 1, then I am supposed to shift towards positive hand side. But now I will shift towards negative hand side. Right? So now I will shift this waveform towards my negative hand side. Towards here I will shift. So what will happen? This arrow will go here actually. Did you understand this whole process? You can go by this as well. But how did I write it down? Did you understand this point? X of minus n minus 1. X of n I am already having. Now let's explain it with this process. Which process? X of n is there, then I will go to x of n minus 1, then I will go to x of minus n minus 1. So x of n minus 1, x of n minus 1. That means n minus 1. What does that mean? That I need to shift my waveform towards positive hand side. That means 1, 1, 1. It is 1, 1, 1 only. This is shifted towards positive hand side. That means the arrow would come here. Right? Next I need to do inversion, or you can say next I need to take the mirror image. So this will come here and this one goes here. So dot 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 1, then 1, here there is arrow, and next one. So are we getting the same thing? Yes. Are you getting the point? Anywhere, anyhow you can go. Now you need to subtract. So in the subtraction, x of n minus x of n minus 1, sorry, x of minus n minus 1. So in the subtraction, sample to sample will be subtracted. That means whatever the sample that you are having at minus 2, that will be subtracted from the sample at minus 2 only. This is your n equals to minus 1, this is your n equals to minus 2, this is your n equals to minus 3, this is your n equals to 0, this is your n equals to minus 1, n equals to minus 2. So x of n minus of x minus 1. So what sample you are having at in place of x of n, what is the sample at x equals to minus 3? That is 0. But in this case, let's call it y of n. So what you need to do, I cannot call it y of n, let's call it z of n. So what you need to do, x of n minus z of n. So z of minus 3, what is z of minus 3? That is 0. Sorry, z of minus 3 is actually 1. So 0 minus 1, that would be minus 1. So for rest of these samples, if I draw the diagram of z of n here, if I draw the diagram of z of n, so z of n is 1 till n equals to 1. Till n equals to 1, it is 1. Till n equals to 1, it is 1. One, 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 one. After that, it is all 0. After that, it is all 0. So this is your x of minus n minus 1. Now you need to subtract both of these waveforms. So minus 2, minus 1 and 0 and 1. All these are same here. So all these will be subtracted from each other. 1 minus 1, this is 1 only, 1 only, 1 only, 1 only, 1 only. So 1 minus 1, 0, 0, 0, 0. But at minus 3, 0 minus 1, it would be minus 1. Here also 0 minus 1, it would be minus 1. So minus 1, in that manner it will keep on going. Minus 1, in that manner it will keep on going. Okay. And at minus 3, you will be getting, sorry, at minus 2, you will be getting 0 because 1 minus 1 would be 0. At minus 1, you will be getting 0 because 1 minus 1 would be 0. At 0, you will be getting 0 because 1 minus 1 would be 0. At 1, you will be getting 0 because 1 minus 1 would be 0. And this is your n equals to 0. After that, what will happen? At n equals to 2. At n equals to 2, here you are having nothing. So 1 minus 0 would be 1. 1 minus 0 would be 1. Again 1 minus 0 would be 1. So after that, you are having 1, 1, 1, 1. So this is the waveform. Okay. So getting started with minus 1, minus 1, minus 1, then 0, 0, 0, 0, then 1, 1, 1, 1, 1. So this is how you draw x of n minus of x of minus n minus 1. I hope you are understanding this point. This is not difficult. From sample to sample, we need to subtract. If I need to find the value of y of 3, then I will subtract x of 3 minus z of 3. So 3 sample, here 3 sample is 1, here 3 sample is 0. So 1 minus 0 would be 1. If I need to find the value of y of 0, so x of 0 minus z of 0. X of 0 is 1, z of 0, x of 0 is 1, z of 0 is also 1. 1 minus 1, 0. So sample to sample is being subtracted. Now 0 minus 1 would be minus 1. Before that, 0 minus 1 would be minus 1. But from minus 2 onwards, from minus 2, minus 1, 0, 1 and 2, in all these sequence, sorry, from minus 2 to plus 1. So in all these sequence, this is also 1, this is also 1. So all will be 0. After that, 1, 1, 1, 1. After that, 1, 1, 1. Okay. So this is the final answer. Now we need to study about, okay, this question we need to see, and after that we will study about unit impulse sequence. So this is also one of the question in basics only. So I need to take a pause now. You try doing it. You try finding the value. Summation k equals to minus infinity to minus 1. If you don't know the meaning of this, then you can pause. But if you already know the meaning, then you try finding these values, and later on we will start with unit impulse sequence. Okay. Yeah. Hi guys, welcome back. So did you try this question? What you need to do, you need to take the summation from minus infinity to minus 1. What you need to do, take the summation. This is the meaning of this shows summation. So you need to add. How will you add? You will put this minus 1 here, x of minus 1. Then you need to go from minus 1 to infinity. So x of minus 1 plus x of minus 2 plus x of minus 3. In that manner you will go till infinity. What is the value of x of minus 1? That is 2. What is the value of x of minus 2? That is 1. What will be the value of x of minus 3? That would be 0. Minus 4, 0. 0, 0, 0. Everything would be 0, 0, 0. So what will be the answer? 2 plus 1, 3. So minus infinity to minus 1. So minus infinity to minus 1. Till this point, 1 plus 2, 3 would be the answer. 1 to infinity. 1 to infinity. From 1 to infinity. So till this point, minus 1 plus 1.5. Minus 1 plus 1.5. What will be the answer? 0.5. Or what you can do? 1 to infinity I need to go. So x of 1 plus x of 2 plus x of 3. In that manner you keep on going till x of infinity. So x of 1 is minus 1, 0, then 1.5, then all are 0, 0, 0 only. So what you are getting? 0.5. So minus 1 plus 1.5. What about from minus infinity to infinity? Minus infinity. What is this? This is your minus infinity. So minus infinity to infinity. So everything will be added up. So 1 will be plus minus 1 plus 1.5. So what you are getting? 3.5. So this is the meaning of summation. You would already know what is the integration, but it might happen that you don't know summation. So this is the meaning of summation. So that's it. That's it about the basics that we wanted to study about our discrete time signals. So quickly we can revise. We started with two kind of representation. This is how we can represent. This arrow shows the 0. This is your n equals to 0, right? Then we got to know that if it is a non-integer value, then it would always be 0. Then we saw how to do the shift. So n minus 1, that means you need to shift towards the right hand side. Towards the positive hand side you need to shift. That means arrow will be shifted towards the left hand side, right? Then mirror image. After that, n by 2, time domain is being divided by 2. So time axis will be divided by, multiplied with 2. So in that manner it will be expanded. So there will be some unknown terms would be coming in between. Okay. Here it will be compressed. So in between the terms would be going. So this is how it can be done. And if you are asking y of 3n, then again it is compressed. And if you are asking 3n by 2, so one process you can do by this, another process you can do by this, and another process you can do directly as well. Directly would be a bit tougher, but if you have the habit, if you have the practice, you would be able to do it. Okay. Otherwise you can go step by step as well. Then we draw this diagram. Then we did all the process in this one particular problem. Then again we draw the diagram 1 to the power n, that means it will always be 1 only. And here we x of n we draw, then we draw x of minus n minus 1, and then we perform the subtraction, right? And here we saw the summation. That's it. So very easily within 5 minutes or less than 5 minutes as well, you will be able to revise everything regarding your basics of discrete time signal, right? Now we need to study about impulse sequence, unit impulse sequence. We studied about unit impulse signal. It was giving you infinite amplitude and 0 amplitude. Infinite amplitude at t equals to 0 and 0 amplitude otherwise. What about unit impulse sequence? It will give you an amplitude of 1 at n equals to 0. Otherwise it will give you 0. That's it. Very, very simple it is. It was very complex, right? Here you perform these kind of things as well. Minus infinity to infinity, delta t dot dt 1. So this was the complete definition of our impulse signal. Say yes or no. This was the complete definition of impulse signal. But impulse sequence is very simple. Impulse sequence says that at n equals to 0, you just make one sample of amplitude 1. At n equals to 0, you just make a sample of amplitude 1. That's it. This is your impulse sequence. Just 1 minute, guys. Yeah, so this is your impulse sequence. How will you show it? It is already there only for n equals to 0 only. So here only I will show the arrow. Rest of the time it is 0. This is your 0. Here also it will be 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 0. And it will be 0, 0, 0. It will be 0, 0, 0. Only the unit impulse is there, that is at n equals to 0. So arrow sign is there. Okay. So this is known as unit impulse sequence. What do you think? What will be the value of delta of 0? That would be 1. Otherwise, it will always be 0. Delta of 2, that would be 0. Delta of 0.5, that would be 0. This would be 0. This would be 0. This would be 0. Draw x of n, delta of 2n. So this was your delta of n. 1. N equals to 0. Time domain is multiplied by 2. Time axis should be divided by 2. So if you draw delta of 2n, it should be divided by 2. 0 divided by 2 would be 0 only. So delta of 2n is equals to delta of 2n will be this only, right? So delta of 2n is equals to delta of n. But what about delta of t, delta of 2t? So I will write down two conclusion here. What I got to know, delta of 2n is equals to delta of n. That means this delta has the ability of eating up 2. But this was not the case with your delta of 2t. Delta of 2t was equals to 1 by 2 delta of t. Although amplitude will be infinity only, but the area would become half, right? 2 would come out, but in the reciprocal. What about x delta of minus n? So what is your delta of n? Delta of n simply exists at n equals to 0 only. Now if you take the mirror image, you take the mirror image of this one, it would be at p equals to 0 only, no? This would be 0, this would be 0, this would be 0, this would be 0. If you take the mirror image, nothing would change. So if I take the mirror image, delta of minus n, that would be same, right? So delta of n is equals to delta of minus n. Delta has the ability of eating up the negative sign. So delta of minus n is equals to delta of n. Same was there for delta of minus t as well, right? That also had the ability of eating up the negative sign. All good? How will you solve this thing, x of n? What you can do? You can take minus 2 common, n plus 3. Delta has the ability of eating up minus sign as well. Delta has the ability of eating up 2 as well, right? It will eat up the 2 as well. It will eat up the negative sign as well. So what it will give you? Delta of n plus 3. What do you understand by that? That you will have a sequence 1. You will have a sequence 1 at n equals to minus 3. Delta of n plus 3. N plus 3. Plus 3 means it should be, sorry, n plus 3. It should be shifted here. This is the graph of delta n. What will be the graph of delta of n plus 3? N plus 3. Plus 3 means you should be shifted towards the negative hand side. So here you will be shifting. X of t is equals to delta of minus 2 t plus 3. In case of t, it was different. Minus 2 would come out as 1 by 2 delta of t plus 3. So here also you will be having the impulse, but the area of that impulse would be half. And in the unit impulse sequence, there is no concept of area or anything like that. It is simply a simple definition. The simple definition is delta of n means at n equals to 0, I will be having a impulse. Sorry, I will be having a sequence of amplitude 1. That's it. But here the definition was complex. This definition was something different. Here you need to define the area as well. Along with that, you need to define the impulse as well. Impulse will be at minus 3 and the area was half, right? And in place of, instead of writing delta of n plus 3, I should write down here x of n. So this is how I will make it, right? And what will be the amplitude? Amplitude will be 1. What do you think? What will be the value of this thing? N equals to minus infinity to infinity. Minus infinity to infinity, you need to go delta of n. What do you think? What is the graph of delta of n? This is the graph of delta of n. N should go from minus infinity to infinity. Here it is only having one sample, having a sample of amplitude 1. Minus infinity to plus infinity you need to go. So whatever the samples you are getting, you just need to add the amplitude. So only one sample I am getting, that is 1 only. So n equals to minus infinity to infinity delta of n. So this is equals to 1 only. Say yes or no. Was it the same like this? Minus infinity to infinity delta of t dt. That was also 1 only. This also seems like same. What about minus infinity to minus 1? Minus infinity to you reach to minus 1. Minus infinity to minus 1. So there is no sample. So what will be the value of n minus infinity to minus 1 delta of n? You need to reach from minus infinity to minus 1. There is no sample. This is the answer. Okay. Or you can see minus infinity to minus 1 delta of t dt, that is equals to 0 only. Say yes or no. Well and good. Simple things these are. Minus infinity to 0. Minus infinity to 0, delta of n. What do you think? Minus infinity to 0 you need to include. 0 you need to include. If I just open it up, how I will open it up? So delta of 0 plus delta of minus 1 plus delta of minus 2. In that manner, I will go till delta of minus infinity. I know that all these values are 0. Delta of minus 1, all these values are 0. But delta of 0 is 1. So what is the answer? Answer is 1. So n, if it is going from minus infinity to 0, delta of n. So if you have put 0 here, that means you are including it. So answer would be 1. But if I ask you to calculate minus infinity to 0, delta of t dt, what will be the answer? Answer would be undefined. Why is that so? Because your impulse at t equals to 0, your impulse at t equals to 0, your impulse at t equals to 0, your impulse at t equals to 0 is not defined, it is not continuous. So if your function is not continuous at a particular value, you cannot take the integration. That's why we always have seen 0 minus or 0 plus. Whenever we were studying our continuous time signal, I was integrating from minus infinity to 0 minus, minus infinity to 0 plus. I never took at that particular impulse, because at that point it is not even defined. So if I write down this particular thing, what I need to write down? Undefined. Okay. But here there will be no concept of 0 minus, because here 0 minus will become actually minus 1 only. If I write down 0 minus, so before 0 minus, what is the sequence? That is minus 1, right? Or 0 plus, if I write down, that would be n equals to 1. 0 plus means whatever the next sequence is there, whatever the next sample is there, next sample is there at n equals to 1. What about this value from 0 to 1? So what I need to write down? Delta of n from 0 to 1. So what that would be? Delta of 1 plus delta of 0. What is the value of delta of 1? That is 0. What is the value of delta of 0? That is 1. So what is the answer? 1. Or what you can do? 0 to 1 you need to go. 0 to 1 you need to go. From 0 to 1. So 0 to 1 you need to go, that means you are including the 0. So 1 plus 0, that would be 1. So that is the answer. The answer is 1. Okay. And again, if I integrate from 0 to 1 here as well, then it would be undefined, because at 0 the limit is not defined, right? From minus infinity to plus 2, delta of minus 2 n plus 4. So what I can do? First I will reduce it. How I can reduce it? Minus infinity to 2, delta of n minus 2. That means my sample is at n equals to 2. My sample is at n equals to 2. My sample is here at n equals to 2 and amplitude is 1. This is my x of n. If I call this as x of n, so this is my x of n. What they are saying? Go from minus infinity to 2. Minus infinity to 2. That means you need to include these 2. If I need to include these 2, that means this 1 would come. So 0 plus 0, all these will be added, and finally 1 will be added. So answer would be 1. So what is the answer for this one? This answer is 1. Now what about this? What you can do? N equals to minus 4 to infinity. Minus 2 is a common. Minus 2 is common. I can take it outward. Delta of n plus 3, right? Minus 2. This minus 2 I am taking outward. If you see it clearly, what I am doing here, minus 2 I took common, n plus 3. This minus sign, this can eat up. This can eat up the 2 as well. So what we will be getting? Minus 2 into n of minus 4 to infinity, delta of n plus 3. So here you are having the impulse at minus 3 that has the amplitude of, this impulse has the amplitude of minus 2, right? This impulse has the amplitude of minus 2. And now you are integrating from minus 4 to infinity. Minus 4 to infinity. Minus 4 to infinity. So in minus 4 to infinity, this minus 2 is coming. So what would be the answer? Minus 2. Or what you could have done, from minus 4 to infinity, simply you make this one, delta of n plus 3. What will be delta of n plus 3? Delta of n plus 3 would be at n equals to minus 3, you are having an amplitude of 1. So you need to go from minus 4 to infinity, minus 4 to infinity. So minus 3 is also included. So this minus 3 is also included, that means it would be 1. So minus 2 into 1, answer would be minus 2. Well and good. You need to denote x of n in terms of impulse sequence. Important. Okay, important. It will be used in further lectures. There is very rare chance, let me tell you guys, there is very rare chance that any question will be coming in the examination hall from these particular chapters, like from unit impulse sequence or from unit step sequence or from unit ramp sequence. But these will be used in our further lectures. So that's why we are studying it. How will you represent x of n in terms of impulse sequence? What do you think? First, let's denote x of n in this manner. Starting with 3 by 2. Then at minus 3 it is 0. Then at minus 2 it is minus 1. Then again at minus 1 it is 0. Then at 0 it is 1. Then at 1 it is, at 0 it is 1. At 0 it is 1. At 1 it is 2. At 2 it is minus 1. At 3 it is 0. At 4 it is 1 by 2. How I can represent it? If you forget all these things, only if you look at this, I am assuming that all these are 0. So can I write it down this as in this manner, that it is 3 by 2 delta of n plus 4. That means you are having a impulse at minus 4, that is having, you are having a sample of 3 by 2 amplitude at n equals to minus 4. You are having a sample of 3 by 2 amplitude at n equals to minus 4. So 3 by 2 delta of n plus 4. Then 0 into something, that would be 0 only. The next sample you are having at n equals to minus 2. The next sample you are having at n equals to minus 2. And the amplitude of that sample is minus 1. Amplitude of that sample is minus 1. So minus 1 into delta of n plus 2, or you can write down minus delta of n plus 2. Then here 0, here. You are having a amplitude of 1 at n equals to 0. You are having a sample of amplitude 1 at n equals to 0. So delta of n plus amplitude 2 at n equals to 1, amplitude minus 1 at n equals to 2, then 0, then amplitude half at n equals to 4. So this is how I will represent it. 3 by 2 delta of n plus 4, minus 1 delta of n plus 2, plus delta of n, plus 2 delta of n minus 1, minus 1 delta of n minus 2, plus 1 by 2 delta of n minus 4. Say yes or no, right? So in that manner only we can represent other function as well. Or if directly this was written, then also I could have represent. This would be delta of n plus 2 delta of n minus 1 plus minus delta of n minus 2 plus 1 by 2 delta of n minus 4. Here goes minus delta of n plus 2 plus 3 by 2 delta of n plus 4. So this would be your x of n, right? Now you need to multiply your x of n with the unit impulse sequence or with impulse sequence. If I am multiplying x of n, this is my random x of n. If I multiply both of them, so what is my x of n? X of n, some random values are there. Let's call it a, b, c, d. So dash dash dash, a value is there. Let's write it down on a bit bottom. Some dash dash dash, a value is there, b value is there, then alpha value is there, then c value is there, then d value is there, then dash dash dash. So this is your n equals to 0. And what about delta of n? So delta of n is 1 here. And if I multiply two functions, then n equals to 0 will be multiplied with n equals to 0, n equals to 1 will be multiplied with n equals to 1, n equals to 2 will be multiplied with n equals to 2, n equals to minus 1 will be multiplied with n equals to minus 1. So this 0 will be multiplied with b, that would be 0. A will be multiplied with 0. Any random value will be multiplied with 0. C will be multiplied with 0. D will be multiplied with 0. All will be 0. But your alpha will be multiplied with 1. What you will be getting? Alpha. So if you do this thing, x of n into delta of n, so you are getting alpha but at n equals to 0. So this is how you will show it. If I multiply both of them, if I do the multiplication, what we are getting? So alpha into 1, that would be alpha only. Alpha into 1, that would be alpha only. Okay, so this is your x of n versus n. So how you can represent it? X of n into delta of n. Can I represent it in this manner? X of 0, or can I represent in this manner? If you see this diagram, how will you represent it? Alpha delta of n. That means at n equals to 0, you are having a amplitude of alpha. At n equals to 0, you are having amplitude of alpha. Here we represented, no? This was the sequence. So at n equals to minus 4, I was having amplitude of 3 by 2. So 3 by 2 delta of n plus 4. Similarly, at n equals to 0, you are having amplitude of 1. So 1 delta into n. So similarly here as well, at n equals to 0, you are having an amplitude of alpha. So alpha delta n. And what is your alpha? Alpha is actually x of 0. X of 0 is alpha. So this is what we got to know. And this was the same for, this was D2 same for continuous time signal as well. That your x of t was multiplied with delta of t. So 0 got shifted here, it was equals to x of 0 delta t. Say yes or no? Right. See the same question. Here this n naught will be shifted here, x of n naught delta n minus n naught. And if you remember this thing for your continuous time, then it was the same, x of t into delta of t minus t naught. That would be equals to x of t naught into delta of t minus t naught. Right. So let's check that out, how you can reduce it. N equals to 1 to infinity x of n. This will be your minus 2 will come common. So minus 2 will be eaten up. This will be n minus 2. Now this 2 can go here. So x of 2 n equals to 1 to infinity x of 2 delta of n minus 2. So this x of 2, this will be a constant value, right? X of 2 is not a function of n. So this is a constant value that can come outward. So x of 2 n equals to 1 to infinity delta of n minus 2. So the impulse will be at n equals to 2. Impulse will be, or you can say the unit sequence will be at n equals to 2. Your sample will be at n equals to 2. But you are integrating, you are adding up from 1 to infinity. At n equals to 2, you are having the sequence, but you are adding up from 1 to infinity. That means this will come into action. And if this is coming into action, what is the summation? That is 1 only. So what is the answer? X of 2. So answer would be x of 2. Where do I write down the answer? Here I write down the answer. Answer would be x of 2. Right. So let's do this one. Integration from minus infinity to 2 cos of n pi delta of minus 3 can come common. So n minus 3. You get to know that the impulse will be at n equals to 3. But you are integrating from minus infinity to 2 only. The impulse will be at n equals to 3. This is your n equals to 3. But you are adding up from minus infinity to 2 only. So here everything will be 0. So answer would be 0. This is the answer. Okay. The same question is there. But this time what we are doing? Minus infinity to 4 cos of n pi delta of n minus 3. But now the impulse will be coming into action because you are summing up from minus infinity to 4. You are taking the summation from minus infinity to 4. So this will come into action, right? So n equals to 3 you can put here. So cos of 3 pi, and then 3 pi goes outward, then summation goes inward. N equals to minus infinity to 4 delta of n minus 3. What will be the value of this thing? That would be 1 only. And what is the cos 3 pi value? So cos 3 pi, what is cos 3 pi? Cos 3 pi is minus 1, right? Cos 3 pi is minus 1. So what is the answer? Answer is minus 1. So any kind of question you will be able to answer in the examination hall, right? draw this particular signal. Just draw this particular signal. How will you draw this particular signal? What you can see? Impulses I can see. I can see the impulses. At n equals to 0, I can see the impulse of amplitude 2. At n equals to 1, I can see this is your, this impulse will be at n equals to 1. This will be at n equals to 0. This will be at n equals to minus 2, and this will be at n equals to minus 3. So this was your n equals to 0. This would be your n equals to 1. This would be your n equals to minus 2, and this would be your n equals to minus 3. So what is the magnitude at n equals to minus 3? That is plus 2. That is plus 2. What is the amplitude at n equals to minus 1? Sorry, n equals to minus 2. So amplitude at n equals to minus 2 is minus 1. Right? Minus 1. At n equals to 1, the amplitude is plus 1. So this is the scene. In between, there is no impulse at n equals to minus 1. So this was 2, this was 2, this was minus 1, this was minus 1. So this is how I can draw my x of n. And can I write down the x of n in this manner? I will start with minus 3. So amplitude is 2, then amplitude is minus 1, then I have to include a 0, because at minus 1 I am not having anything. So then I have to include 0, then 2, and then minus, okay, no, it is not minus 1, it is plus 1. At n equals to 1, the amplitude is plus 1, then plus 1. Or directly from here also I would have written down n equals to 0. At n equals to 0, you are having a amplitude of 2. N equals to minus 2, this is your minus 1, minus 2, you are having amplitude of minus 1. At n equals to minus 3, you are having amplitude of 2. At n equals to minus 1, you are not having anything, and at n equals to 1, you are having amplitude of 1. So very simple, very straightforward, right? Draw this waveform. Here it should be written as 1 to the power n. Okay. So what is written? X of n is equals to 1 to the power n plus delta n. What do you think what will happen? What is 1 to the power n? Always 1, 1, 1, 1. What is delta n? Only 1 at center. Are you getting this point? What is 1 to the power n? We have drawn the waveform of 1 to the power n. Always 1, 1, 1, 1, 1. What is delta n? Delta n is 1 only at n equals to 0. So if I add both of them, what will happen? If I write down my x, if I write down 1 to the power n, that is always 1, 1, 1, 1. At n equals to 0. And what is delta n? Delta n is only 1 here. And if I add both of them, so 1 plus 0, 1 plus 0, everything will be 1, 1, 1, 1 only. Everything will be 1, 1, 1. But 1 plus 1 will be 2. Rest again 1 plus 0, 1 plus 0, everything will be 1, 1, 1, 1. So what kind of waveform you will get? That this will be 2, rest all will be 1. Rest all will be 1. Well and good. So this will be the waveform. Okay. Unit step sequence we will study now. Only these much things are basic things we are going to see. From these only, if they want to frame a question, they will frame questions from these concepts only. So in within, I guess, the 25 minutes we have completed our unit impulse sequence. Now we are going to study about unit step sequence. So what was our UT? UT was defined as, it would be 1 for t greater than 0, and for less than 0 it would be 0. Here as well, it would be 1 for n greater than equals to 0, and 0 for otherwise. 0 otherwise. So for n greater than or equals to 0, it is 1. That means here also it is 1 only. It is 1, 1, 1, 1, 1. In that manner, it will always be 1, 1, 1, 1, 1. It will always be 1, 1, 1, 1, 1. This will always be 1, 1, 1, 1. If you start from here, 1, 1, 1, 1, and this is your n equals to 0. This is your u of n. right? This was your n equals to 0, 1, 2, 3, and in that manner it will keep on going. So u of n diagram should be there in your mind. What will be the value of u of 0? That would be 1. If I ask you what is the value of here u of 0, you will say I don't know. It is not defined, because at t equals to 0, continuous time ut, that means at t equals to 0, unit step signal is not defined, because there is a jump. At 0 plus you are having the value 1, at 0 minus you are having the value 0, so you cannot define it. But here you can define it, the value is 1 only. What is the value at 3 by 2? If non-integer is there, it would be 0 only. What is the value at 1? That would be 1. What will be the value at minus 1? That would be 0. And what will be the value at 1000? That would also be 1. So it is always 1 for n greater than 0. Otherwise it is 0 only. Draw u of minus n. So what was your u of n? 1, 1, 1, 1 in that manner, right? And this was your n equals to 0. Now u of minus n. So whatever that was here, that will come to this side, right? You just need to take the mirror image of this one, right? Mirror image of this one. But whatever that was there at 0, that will remain there as it is. So everything will come here like this, 1, 1, 1, 1. But whatever that was at 0, that will remain there as it is. So if I draw u of minus 1, so u of minus n, so that will simply be the mirror image. U of minus n is there. Draw u of 3n. This was your u of n, right? 1, 1, 1, and always in that manner. 1, let's take more 1, let's take more 1, more 1 in that manner, right? This was your n equals to 0. This was n equals to 1, 2, 3, 4, 5. If my n domain is being multiplied with 3, that means n axis should be divided by 3. Should be divided by 3. Does this make any sense? 1 by 3 non-integer doesn't make any sense. 2 by 3 doesn't make any sense. 3 by 3 that would be 1. 3 by 3 that would be 1. So yeah, this makes any sense. Doesn't make any sense. After that it will make sense, right? So 2 samples it is cutting. So n equals to 0. What will be your u of 3n? U of 3n will be at n equals to 0 it is defined. Then directly again it is 1. U of 3n, what you are drawing, this is your u of n. Then you will divide by 3. Divide by 3 in this manner. So in u of 3n, if I say my u of 3n is x of n, what I am saying, this u of 3n is equals to x of n. So this is my x of n. So if I ask you what is the value of x of 0, that would be equals to u of 0. And what is the value of u of 0? That is 1. What is the value of x of 1? That would be equals to u of 3. That is also 1. What is the value of x of 2? That would be equals to u of 6. That is also equals to 1. So x of 0, x of 1, x of 2, that is again becoming 1. Although you are cutting 2 samples, but they are not making any impact, because it is always 1. So u of 3n is coming out to be equals to u of n only. Are you understanding this point? I am cutting out these samples, but next sample is also 1. Then again I cut out these samples, then again the sample is 1. In that manner your u of 3n came out to be 1, 1, 1, 1 again. And this was your n equals to 0. So u of 3n came out to be u of n only. And this was similar in our u of 3t is equals to u of t as well, right? But the interesting point will come at u of n by 3. So for that I will add a page, u of n by 3. So this will be the interesting point, that my x of n is actually u of n by 3. n by 3 means it will be expanded now. It will be expanded. So what is my u of n? U of n is actually 1 1 1 1 only. 1 1 1 1 1 1, right? This is your n equals to 0. This is your n equals to 1. N equals to 2, 3, 4 and 5. What you need to do? Time domain is being divided by 3, so that means time axis will be multiplied with 3. So what this will become? 0. This will become 3, 6, 9, 12, 15. So what is your u of n by 3? In u of n by 3, sir, I know that n equals to 0, I know the value. But n equals to 3, I directly know. I don't know the value of n equals to 1 or 2. Directly I know the value of 3. Then 5, 6 I don't know. Directly I know. Sorry. 0, 1, 2, 3, 4, 5 I don't know. Then directly I know 6. 7, 8 I don't know. 9, 10, 11 I don't know. 12. In that manner I will keep on going. So is it equals to? Because here I told you it could be any random value. Alpha, beta, gamma, A, B, C, D, E. It could be any random value. So is it coming out to be equal? U of n by 3 is not equals to u of n. But your u of t by 3 was equals to u of t. So there is a difference here. Okay. So you cannot say that u of an would be equals to u of n. You cannot say it. Because here your a was 1 by 3 and here your a was 3. So scenes got different now. Right. So scenes are different. And certainly it cannot eat up the negative sign, because here directly you can see that nowhere u of minus n is equals to minus of un, or it is equals to u of n. So certainly it cannot eat up the negative sign, neither it can take out the negative sign. So with the negative sign it cannot do anything. Now the point is, even with this 1 by 3 or even with the factor as well, it cannot do anything. Even with the factor as well, it cannot do anything. So this has to be there as it is. Well and good. Draw u of minus n minus 1. U of minus n minus 1, can I start from here? Or what I would have done? I draw u of n, then I draw the graph of u of n minus 1, and then I take the mirror image. Or I can do two mistakes. Do you remember two mistakes? U of n, u of minus n, minus 1. So what will be the graph? Now you should be able to visualize it. U of n, u of minus n, minus 1. That means it should be shifted towards the negative hand side. So this would be the graph. This would be the graph. Here it would be 0. And after that it would be 0 0 only. At 1, 2, 3, all these will be 0 0 0 only. So this I am calling as x of n. One, 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 and it will keep on going like this. I hope you are able to visualize it. U of n was there, u of minus n minus 1. So this is what you will be getting, and how you can represent it. So your always it is like 1 1, then it will keep on going to 1 1 1, then at 0 you are having it 0, right? So this is your u of minus n minus 1. Have I written anything here? Yeah, so let's check one point here. Can I write down this thing, that your u of n plus u of minus n is equals to 1 to the power n? Is this true? No. Why is that so? Because if you add up u of n and u of minus n, where I have added up u of n, u of minus n. Okay, so you know the graph of u of minus n. This is the graph of u of minus n. You know the graph of u of n. Yeah, this is the graph of u of n. Here we did this thing, right? 1 to the power n plus delta n. 1 to the power n plus delta n. It was all 1 to the power n, but at the 0 there was extra delta n was also there. If you add up u to the power n, if you add up un with the u of minus n, what will happen? Minus 1 has a sample of 1, minus 2 has a sample of 1, minus 3 has a sample of 1. All these are having a sample of 1 1 1 1 1. And here the samples are 0 0 0 0. So 1 plus 0 1, 1 plus 0 1, 1 plus 0 1. All these will be 1 1 1 1 1, right? At n equals to 0, this sample is 1, at n equals to 0, this sample is also 1. So 1 plus 1 at n equals to 0, the sample will become 2. Now for n greater than 0, all these sample will become 1, 1, 1, 1 only. Can you add both of them? What I am saying, what I am asking you, we need to add u of n plus u of minus n. So everywhere you will get 1, but at the 0 you will get 2. If I add these two signals, this signal is added with this signal. So these are single 1, and here there is 0, and here there is 0. So 1 plus 0 would be 1 only. Here there is 0, and here there is single 1. So 1 plus 0, again it would be 1 only. So for n equals to minus infinity to n equals to minus 1, you are having 1, 1, 1, 1. For n equals to 1 to infinity, you are having 1, 1, 1, 1. But n equals to 0, what you are having? 1 plus 1. So at n equals to 0, you are having 2. And this is the same like this. So it would be equals to 1 to the power n, 1 to the power n plus delta n, plus delta n. Say yes or no. But if you add un plus u of minus n minus 1, what that would be? 1 to the power n. Say yes or no. Why it is 1 to the power n? Because u of minus n minus 1, u of minus n minus 1. So here, what will be the graph of u of n? This will be the graph of u of n. So if you add all of them, what you are getting? Always 1 to the power n. Because in u of n minus n minus 1, there is no sample at n equals to 0. That means it would be equals to 1 to the power n only. Is that okay for you? Try solving this question. U of n minus 3 plus u of minus n plus alpha is equals to 1. So find the value of alpha. So 1 to the power n should be written here. So u of n minus 3. What will be the graph of u of n minus 3? U of n minus 3. That means samples will be starting from n equals to 3. 3, 4, 5. Of amplitude 1, 1, 1, 1. Right? Now what you are saying? Minus n plus alpha. Minus n. This was the graph of u of n minus 3. U of minus n plus alpha. Do you know the graph of u of n? Yes. The graph of u of n. This is the graph of u of n. Now what do you need? You need it to be equals to 1 to the power n. So till this point, from 3 to infinity, everything is 1, 1, 1, 1. From 3 to infinity, everything is 1, 1, 1, 1. But till 2, you need everything to be 1. Say yes or no. This is the required. This is required. At 2, 1. At 1, 1. At 2, 1. At 1, 1. At 0, 1. At minus 1, 1. At minus 2, 1. At minus 3, 1. This is what you require, right? So what will be the graph of this? U of minus n plus 2. Say yes or no. U of minus n. This is your u of n. U of minus n plus 2. U of minus n plus 2. So from here what you see? U of n minus 3 plus u of minus n plus 2. If I add all of them, so this is your 2, this is your 1, this is your 0. All these are 0, 0 only. Minus 1. All these are 0, 0, 0 only. So 0 plus 1, 0, 1 plus here 1, 1, 1, 1 is there. So 1 plus 0, 1 plus 0, 1 plus 0, 1 plus 0, all will be 1. Here 1 plus 0, 1 plus 0, 1 plus 0, all will be 1. So u of n minus 3 plus u of minus n plus 2 is equals to 1 to the power n. Or what you could have done, you know one thing, that u of n plus u of minus n minus 1 is equals to 1 to the power n. Now what you need? U of n minus 3. That means you need to replace n with n minus 3. So what you can do? U of n minus 3 plus u of minus n minus 3 minus 1 would be equals to 1 to the power n. In place of n, I am putting n minus 3. So what I am getting? Yeah, so what I am getting? U of n minus 3 plus u of minus n plus 3 minus 1 minus n plus 3 minus 1, so that would be 2, would be equals to 1 to the power n. So yeah, from here as well I am getting the same thing. So this is also you could have done, or this is also you could have done, right? So value of alpha is 2, value of alpha is equals to 2. So this is the answer. Express un in terms of impulse sequence. Do it on your own. And let me take a pause. Okay, do it on your own. You can do it certainly. So make the graph of u of n and then show it in terms of impulse function. N equals to 0, 1, 2, 3. This is the graph of u of n. So what you can say, delta of n you are having, then at n equals to 1 you are having the other sequence, at n equals to 2 you are having the other sequence. In that manner it will keep on going. Can you represent delta of n in terms of un? This was whatever that was asked. What you need to represent now, delta of n in terms of un. Is this asked here? No. So what you need to represent, delta of n in terms of un. So what do you think, what will be the answer? Delta of n would be equals to u of n plus u of n minus 1. Sorry, not plus. Minus u of n minus 1. Do you agree to this point? Because from here if I find u of n minus 1, this is your u of n. What will be u of n minus 1? That would be delta of n minus 1. In place of n I am putting n minus 1 plus delta of n minus 2 plus delta of n minus 3 plus delta of n minus 4. In that manner it will keep on going. If you subtract both of them, so delta of n will be subtracted from nothing, but delta of n minus 1, this delta of n minus 1, both will be getting cancelled out. Then these will be getting cancelled out. 3 getting cancelled out. In that manner 4 will be getting cancelled out. So only delta of n will be left. Or you can think by the waveform as well. This is your u of n. What will be your u of n minus 1? U of n minus 1, that means your waveform will be shifted towards the positive hand side by 1. So it will be shifted like this. So if it is shifted like this, that means if you subtract both of them, so this all samples will get cancelled out, only this will remain there. And if it is only this is remaining there, that means it is delta of n. So both tasks we can do. Well and good. Okay. Now we will study about running summation and running integration. We have already studied. We need to study about what is the meaning of running summation. It is same as running integration only. So we will study about it. But let me take a pause. I need to drink some water and then we will restart. Yeah, welcome back guys. So how did we do the running integration in case of continuous time signal? You need the function to be a function of t. So minus infinity to t, right? And if I integrate any function that is of the function tau, so x of tau d tau I need to integrate, and I am taking the limit from minus infinity to t, right? Similarly in the running summation as well, I need y of n. So what I will do, I will take the limit k from minus infinity to n and I will integrate x of k, or you should not say integrate, I will say I will add x of k. Let's understand by the waveform. Let's just say this is my x of k waveform. X of k waveform. Any random waveform I am making, a random sequence I am making, a very random sequence. From where to where I will take the summation? From minus infinity to n. Now the value of n will depend. If the value, let's just say this is minus 1, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. So minus infinity to n I am taking. So if your n is less than 0, sorry, if your n is less than minus 1, if your n is less than minus 1, if your n is less than minus 1, then what will be the value of y of n? That would be summation k equals to minus infinity and n is less than minus 1. Let's just say n is minus 2. So from minus infinity to minus 2, everything is 0 only. So y of n will be equals to 0. What you need to do? You need to summation, you need to take the summation, right? Minus infinity to n, and n is less than minus 1. Let's just say n is minus 2. So minus infinity to minus 2. So everything you add up, it will come out to be 0 only, right? So if n is less than minus 1, y of n would be 0. So this is just an example. Are you getting this point? Let's just say n is equals to minus 1, n equals to minus 1. So minus infinity to minus 1 you need to take, and let's just say this magnitude is 1. So what will be the value of y of minus 1? N is equals to minus 1. That means you are here. So minus infinity to minus 1. Only one sequence would be coming. So if you add them up, what will be the answer? 1. So n equals to minus 1 is 1. Right? In that manner, you can find out the value of n equals to minus 2 as well. But yeah, that you can do, not n equals to minus 2. You can find out the value of n equals to 3 as well. Let's just say n equals to 3. So 1, let's call it minus 1, let's call it minus 2, and let's call it plus 2, and let's call this one as 0.5. So in that manner, if you talk about n equals to 3, so what will be the value of y of 3? So minus infinity to 3, you need to add them up. Minus infinity to 3. So 1 minus 1 0, minus 2 plus 2 0, then only 0.5 will be left. So this will confuse you actually. People will be getting confused that y of 3 will be equal to 0.5. So better I should make this as minus 1.5. So 1 minus 1 0, 2 minus 1.5, that would be 0.5, 0.5 plus 0.5, that would be 1. So y of 3 would be 1. So in that manner we are proceeding. Are you understanding this point? So this is the meaning of running integration. We are integrating with, not integration, sorry, running summation. So we are taking the summation with respect to n on k axis. We are taking summation with respect to n on k axis. Say yes or no? Right? So what do you think? What will be the answer of this one? How did we used to do these kind of questions? That delta of tau d tau. The limit of tau was minus infinity to t. How do we used to do these kind of problems? There I told you, always make the waveform. Always make the waveform. So I used to make the waveform of delta of tau. What I used to do? I used to make the waveform of delta of tau. And at delta of tau, I will be having the impulse of area 1 at tau equals to 0. Then I need to integrate from minus infinity to t. If your t is less than 0, if my t is less than 0, if my t is here, if my t is less than 0, then I would say that I would call this as x of t. So if my t is less than 0, my x of t would be equals to 0. And if my t is greater than 0, if t is greater than 0, that means impulse will be in action. So x of t would be equals to 1. That means my x of t was ut. So similarly, I am calling this as x of k. X of k. Same thing, did to same thing. Draw the diagram of delta of k. Delta of k will be drawn with respect to k. So delta of k with respect to k. You are having an impulse of magnitude 1 at k equals to 0. You are going from minus infinity to n. If your n is less than 0, if your n is less than 0, that means you will be integrating from minus infinity to somewhat less than 0. Less than 0 means minus 1. So if your n is minus 1, that means you are integrating from minus infinity, not integrating, sorry, you are taking the summation from minus infinity to minus 1. What that summation would be? X of k would be equals to 0. Because from minus infinity to minus 1, there is no sequence, there is no sample. So that would be equals to 0. And if your n is greater than 0, if your n is greater than 0 or equals to 0 as well, so what will be the value of x of k? Let us just say n is 1. So from minus infinity to 1, only one sample is there, answer will be 1. Let us just say n is 2. Minus infinity to 2, only one sample is there, so that will only be added. So answer is again 1. N equals to 0. From minus infinity to 0, again this sample is coming into action, answer will be 1. So for n less than 0 you are getting 0, for n greater than 0 you are getting 1. What does that mean? N less than 0 you are getting 0, for n greater than 0 you are getting 1 1 1 1. What does that mean? Can I draw the diagram? Yes. For less than 0 it was 0, then after that 1 1 1 1 1. This is your x of k. So what is this? This is your u of k, right? So from here what did you understand? That delta of k with limit being not u of k, sorry. Here it will be the function of x of n. Really sorry, blunder from my side. This is the function of n, no? x of n I should put, x of n I should put here, x of n I should put here, right? I hope you are getting the point. Here I put x of t because this will be a function of t finally. So this will be a function of n. That's why I had to put n here. So x of n, and it should come in the larger bracket actually. It should come in the larger bracket. So x of n, this would be x of n. This is also your x of n graph. That is coming out to be equals to u of n. So minus infinity to n, that is equals to u of n. Yes or no? I hope you are understanding the meaning of running integration. How will you solve this problem in the examination? Always make the diagram. How I can reduce it? K equals to minus infinity to 2n plus 4. Can I take 2 common? Yes. This has the ability of eating up 2. So k minus 2. I know that my impulse is at 2. Delta of k minus 2. So I am having a sample at 2 of magnitude 1. Now limit is going from minus infinity to 2n plus 4. So if your 2n plus 4 is less than 2, if your 2n plus 4 is less than 2, or you can say if your n is less than minus 1, if your n is less than minus 1, then what will be the value of summation? If n is less than minus 1, then your x of k would be equals to 0. And if your 2n plus 4 is greater than 2, 2n plus 4 is greater than 2, that means you are somewhere here or equals to 2 as well, because at 2 as well you will be taking this sample. So if 2n plus 4 is greater than 2, or you can say n is greater than or equals to minus 1, then your x of k would be equals to 1. So for n less than minus 1 it is 0, for n greater than minus 1 it is 1. So what kind of diagram we are getting? Just I will reduce it a bit because I need to draw the diagram here. And greater than minus 1 we are getting 1 1 1 1. Okay, 0 1 2 3. So this is your, again I am doing the same error. It would be a function of the same ditto error. It's been 4 AM at night. That's the reason these errors are happening. But really sorry, these should not happen. This should be x of n, right? This will be a function of n, right? This will be a function of n. Why I am doing this blunder? This is simply a function of n. If your n is less than minus 1, it is 0. If your n is greater than minus 1, it is 1. So what do you think? What is that? This is your x of n. So from here we are getting to know that my x of n is u of n plus 1. U of n is shifted here, u of n plus 1, right? N plus 1. Will you apply any short trick here? No, no short trick, nothing. No trick. Simply solve by your complete method. Well and good. Try solving this one. Infinity to 2n plus 4. You are going from infinity to 2n plus 4. So try doing it on your own. Okay. I will pause a bit. You can try doing it on your own. Yeah. So did you try this question? So before starting the solution of this question, let's see an interesting point. So when we were doing the integration and when we were going from higher limit to, let's just say, lower limit, I was going from higher limit to lower limit, x of t dt. So I told you one thing, whatever the area that you get, then you put the negative sign, right? Basically in the integration, if I interchange the limit, then there would be a negative sign outward. Because here the nature of dt is changing, no? Let's just say you are going from a to b and you are saying that dt is positive. Now you are going from b to a, that means dt would be negative. And let's just say xt was already positive and this is already positive. So positive into negative will give you negative. Now negative into negative will make it positive. So that's why both are equal. Positive into positive is positive only. This negative sign, this is positive sign and this is negative sign. all will be positive only. So this is what we were doing. I modified an error. First we studied that particular analysis, then I said that there was an error from my side. If I am going from the lower limit to the, if I am going from the higher limit to the lower limit, then there would be some extra negative sign in the outward. Here also you are going from higher to lower. Will there be any extra sign outward? Let's check that out. Okay. So let's just make a random function x of k I am making. A random x of k I am making. So plus 2 plus 1 0 minus 1 plus 2 and minus 1. Okay, let's keep it till this point. Minus 2, minus 1, 0 and 1. This is 2, 1, minus 1 and 2. If I ask you to calculate summation x of k, this is your x of k, or x of n also you can take. K is going from minus 2 to 1. So what you will do? X of minus 2 plus x of minus 1 plus x of 0 plus x of 1. What that would be? 1 get cancelled, 4. Answer is 4. Now if I ask you, k is going from 1 to minus 2, from higher limit to lower limit, what you are going to do? You put x of 1, then x of 0, then x of minus 1, then x of minus 2. In that manner you will add. What will be the answer? Again 4. So in the summation, if you interchange the limit, there is no impact. There is no impact of negative sign. So extra negative sign will not be added in case of summation. Minus 2 to 1 x of k, that would be equals to 1 to minus 2 x of k. No need of extra negative sign here. Are you understanding this point? Because here there is directly summation, no? Why it is coming like this? Let's make it better. X of 0 plus x of minus 1 plus x of minus 2. So here what is happening? Simply they are being added. But here there was dt. This dt was making an impact. If you are going from a to b and I am assuming that dt is positive, then if I go from b to a, then dt would be negative. But here there is nothing like that. Here there is no decay. So that is not making any impact here. You are simply adding it up and you are getting the same answer. So I will solve this particular problem. But do I have to add extra negative sign there? No. Extra negative sign is not required there. And why is that so? Because in the summation, from anywhere to anywhere you take the limit, from lower limit, from higher to lower you go, still there is no need of extra negative signs because it is simply a summation. So the same diagram I will get here. From where to where I will be going? I will be going from infinity to 2n plus 4. So if your 2n plus 4 is greater than 2, if your 2n plus 4 is greater than 2, here 2 will come outward, but it will be eaten up by delta, right? This will be eaten up by delta. Yeah. So if 2n plus 4 is greater than 2, what does that mean? If n is greater than minus 1, that means this particular, let's call it y of n. So if n is greater than minus 1, if n is greater than minus 1, that means you would be somewhere here, you would be somewhere here. And if you are somewhere here, then all your summation would be equals to 0. And if your n is less than or equals to minus 1, then all your summation would be equals to 1, right? So how will you make the diagram? This is your minus 1, this is your 0, 1, 2, in that manner, and n is equals to minus 1. So 1, 1, 1. That's it. Minus 2, minus 3. This is your y of n versus n. So what you are getting? What is your y of n? It is looking towards minus infinity. Y of n is looking towards minus infinity. That means it has to be u of minus n. If it is looking towards minus infinity, that means it has to be u of minus n. And where will be your step starting? From where step sequence is starting? That is starting from minus 1. That's it. So this is your u of minus n minus 1. This is the answer. Okay. This is the answer for this one. So in the examination, you need to think in this manner. Here, extra negative sign will not be added. Well and good. Let's solve this one. You need to find the value of alpha and beta. Again, the same thing. This I have already solved actually. This is your 1 minus u of minus n minus 1, right? This 2k minus 4. This we have already solved. 2k minus 4, infinity to 2n plus 4, infinity to 2n plus 4. So 1 minus u of minus n minus 1. That would be equals to alpha n plus beta. This is what they are saying. What do I know? U of n plus u of minus n minus 1 is equals to 1. Here 1 to the power n could be written. 1 to the power n could be written. 1 to the power n could be written. That means 1 to the power n minus u of minus n minus 1 is equals to u of n. That means this is equals to 1 to the power n minus u of minus n minus 1. This I was getting, and this I already know. So from here, what did I do? 1 to the power n minus u of minus n is equals to u to the power n, and that is equals to u of alpha n plus beta. That means alpha value is 1 and beta value is 0. Alpha is 1, beta is 0. Very simple. Draw u of n plus u of n plus 2 minus u of n minus 3 minus u of n minus 7. Everywhere there is plus n, right? Everywhere there is plus n. What is the meaning of plus n? That it will be looking towards plus infinity. And if it is looking towards plus infinity, that means whatever the minimum breakpoint I am having, that is my matter of concern. All these things we have seen in continuous time. Based on that I am telling it. Okay. So breakpoint here 0, breakpoint here minus 2, breakpoint here 3, breakpoint here 7. So whatever the minimum breakpoint you are having, that will be your concern, because the signal is looking towards plus infinity. So you will make it somewhat like this: plus u of n minus u of n minus 3 minus u of n minus 7. So let's write down u of n plus 2. So it is starting from n equals to minus 2, although it will be 1 1 1 1 only. 1 1 1 1 2 1 0 1 2 3 4 5 6 7 8. In that manner, this is your n equals to minus 2. This is your n equals to 0. 1 2 3 4 5 6 7. This is your n equals to 7. Let's write down u of n. So u of n will be starting from here: 1 1 1 1 1. In that manner it will keep on going. Okay, let's write down 0 1 2 3 0 1 2 3 4 5 6 7. In that manner, this is your n equals to 7. U of n minus 3, that means it will start from n equals to 3, but there is a negative sign. So n equals to 3 it will start from. So 0 1 2 3. From here it is starting, but there is a negative sign. So minus 1 minus 1 minus 1 minus 1 minus 1 minus 1, and in that manner. So this is n equals to, this was n equals to 0, this is n equals to minus 3, n equals to minus 3 minus 4 minus 5 minus 3 minus 4 minus 5 minus 6 minus 7, n equals to minus 7. And then here is also there is a negative sign, so this will be n equals to minus 7, n equals to minus 7. What you need to do? You need to add all of them. If I add all of them, what will be my x of n? वो कहाँ चला गया भाई? Wait a second. Yeah guys, so keep it as it is. We need to add a page. So here I will write down x of n, right? So here what you can see, it was 0 0 here, right? All these were 0 0 0 0 0 0 0 0. Everything was 0 0 0. Here also everything was 0 0 0. Everything was 0 0 0 only. So everything was 0 0 0. So from minus 2 to n equals to 0, it would be 1 1 only, no? You started from minus 2, 1 1. Everything was 0 0 0 only. So 1 1. So starting with minus 2, starting with n equals to minus 2. 1 and 1. At n equals to 0, there is another breakpoint. At n equals to 0, there is another breakpoint. So 1 plus 1, 2, and then everything is 0, 0. So 1 plus 1 is 2, everything is 0, 0. Till what? Till the next breakpoint, that is 3. So 0, 1, 2, and now at 3, because this was your n equals to 0. Now at n equals to 3. Now at n equals to 3, there would be something happening. At n equals to 3. So at n equals to 3, 1, 1, minus 1 and 0. So what will be the resultant? 1 plus 1, 2, 2 minus 1, 1. So at n equals to minus 3, there is 1. And it will go on till n equals to 7. 1, 1, 1. 3, 4, 5, 6. Now at n equals to 7, there will be something different. And whatever that is happening at n equals to 7, the same is going ahead. So 1, 1, minus 1, minus 1. 2 minus 2 would be equals to 0. So after that, everything would be equals to 0. So this is how it is going. Or how I could have shown it? I could have shown it in this manner. 1, 1, 2, 2, 2, 1, 1, 1, 1, and there you go. And here should be n equals to 2. So this would be the answer. But how would you do it in the examination hall? In the examination hall, you are going to write down x of n that was given. Now from here to x of n, try writing x of n from here. So what you will see, that's that this is your n equals to 0. That means we are starting from n equals to minus 2. We are starting from n equals to minus 2. Okay. So my sequence is starting from n equals to minus 2. So that has to be u of n plus 2, because here the amplitude is 1. Now the amplitude is increased by 1 at n equals to 0. It is increased by 1 at n equals to 0. Then it is decreased by 1 at n equals to 3. It is decreased by 1. So 1 plus 1 amplitude has become 2 now. Now it is decreased by 1 at n equals to 3. Then after this 4, 5, 6 at n equals to 7. At n equals to 7, it is again decreased by 1. Again it is decreased by 1. So this is how from here to here you could have written down x of n as well. The same kind of thing we used to do in ut. U of t increased by 1, decreased by 2, decreased by 1, increased by 1. The same thing is happening here. Started with u of n plus 2, amplitude 1, increased by 1, decreased by 1, decreased by another 1. So this is how you can write down. And from here, if I need to write down x of n again, how will I write down? Directly. So I'll be starting from n equals to minus 2. So till the next breakpoint, we are having 1, 1 only. But here the breakpoint is saying that you need to increase. Here the breakpoint is saying that you need to decrease. And here the breakpoint is saying that you need to decrease more. So this is how you need to decrease. So this will be the answer. Okay. If this is given, how will you write down? U of plus n is given. Everywhere u of plus n is given. What does that mean? That means they are looking towards plus infinity. And if they are looking towards plus infinity, then the breakpoint having the minimum value is my matter of concern. So breakpoint having minus 2, 1, 0, and 2. So how will I place it? U of n plus 2, then minus 3 u of n, then plus u of n minus 1, then plus 2 u of n minus 2. So what will be your x of n? Starting with n equals to minus 2. So where will be the breakpoints? N equals to minus 2. So this is saying that amplitude should be 1. N equals to minus 1, there is no issue. At n equals to 0, there will be breakpoint. 0, 1, 2. At n equals to 1 as well, there is a breakpoint. At n equals to 2 as well, there is a breakpoint. So continuous breakpoints are there. So 1, 1. Then this is saying that amplitude should decrease by 3. That means amplitude should be minus 2. Now this is saying that amplitude should increase by 3. Amplitude should increase by 1. Amplitude should increase by 1. That means from minus 2 to it will go to minus 1. Minus 2 plus 1, it will go to minus 1. Now this is saying at n equals to 2, amplitude should amplitude should increase by 2. So from minus 1 to it will go to plus 1. And after that it will be 1, 1, 1 only. Because after that there is no breakpoint. So this will be the answer. Starting with n equals to minus 2, you are saying that amplitude is 1. At n equals to 0, it should decrease by 3. That means it should decrease. It should go to minus 2. Then at n equals to 1, it should increase by 1. That means it should go to minus 1. Then at n equals to 2, it should increase by 2. That means it should go to plus 1. And in that manner, it will proceed. What about this one? all these are looking towards minus infinity, right? U of minus n is there. So u of minus n plus 3, u of minus n minus 1, u of minus n and u of minus n minus 3. So all these are looking towards minus infinity. What does that mean? That the breakpoint having the larger value will be my matter of concern. So largest value, the breakpoint will be my matter of concern. So here breakpoint is at 3, breakpoint is at minus 1, breakpoint is at 0 and breakpoint is at minus 3. So breakpoint is at 3, that is the matter of concern. So how will I replace it? U of this and then 0 to u of minus n, then plus u of minus n minus 1 minus 3 u of minus n minus 3. So x of n. Now from where I will start? I will start from n equals to 3. So at n equals to 3, this is saying that this is, let's just say this is your n equals to 3. This is your n equals to 3. The next breakpoint will be at n equals to 0. So 3, 2, 2, 1 and 0, n equals to 0. Next breakpoint will be at n equals to 0. Next breakpoint will be at n equals to minus 1 again here. And next breakpoint will be at n equals to minus 3. So this is how I need to proceed. So at n equals to 3, they are saying that everything should be 1, 1, 1, 1. But at n equals to 0, this is saying that amplitude should increase by 2. Amplitude should increase by 2. At n equals to minus 1, it is saying that amplitude should increase by 1 again. So 3, 3. At n equals to minus 3, it is saying that amplitude should decrease by 3. That means it will be 0. And after that, it will be same. So there is no meaning of writing down this thing. That means this will be your x of n. 3, 3, 2, 1, 1, 1. I will only show the center. Center is this. So this is your x of n. Is that clear to you? Although there is very rare chance that these kind of questions will be asked in the examination, but if it is asked, then you are very comfortable with all these kind of analysis. Say yes or no, right? Very, very simple. So write it down. Write down your x1 of n, x2 of n and x3 of n. So this is your n equals to 0. Signal is looking towards plus infinity. So I will write down in terms of u of n. So x1 of n. First breakpoint is at n equals to minus 2. It is saying that it should increase by 1. Then the next breakpoint is at n equals to 0. 0, 1, 2. Breakpoint is at 3, 4. Breakpoint is at 5. So breakpoint at minus 2, u of n plus 2. Then breakpoint at n equals to 0. So 1 plus 1, 2. Then breakpoint at n equals to 2. They are saying that it should increase by 2. Now they are saying that it should decrease by 3. It should decrease by 3 at n equals to 3. Then at n equals to 5, it is saying, they are saying that it should increase by 5. Say yes or no. And after that, it remains as it is. So 1, then increase by 1, then increase by 2, then decrease by 3, then increase by 2. What about x2 of n? Where x2 of n is looking? It is looking towards minus infinity. So how I will be writing it down? In terms of u of minus n. Starting from here. This is your n, this is your n equals to 0. This is your 1, this is n equals to 2. So here also there is a breakpoint, right? 4 to 0, 2, values are changing. Then 6, again there is a breakpoint, value is again changing. Then 4, value is again changing. Again there is a breakpoint. After that there is no breakpoint, n equals to minus 3. Look, breakpoints are there 4, 0, 2, 6, 4. Value are continuously changing. So all these are the breakpoints. You started with the amplitude should be 4. You said that I will be looking towards plus in I will be looking towards minus infinity starting with 2. Then at n equals to 1, you got that the amplitude should decrease by 4. The amplitude should decrease by 4. Then amplitude should increase by 2. Amplitude should increase by 2. Then amplitude should increase by 4. Amplitude should increase by 4. Then amplitude should decrease by 2. Amplitude should decrease by 2. Then amplitude should decrease by 1. Amplitude should decrease by 1. Again amplitude should decrease by 1. Is that clear to you? How did we write it down? 4u of minus n plus 2. So it started from here. Then again there is a breakpoint saying that amplitude should go to 0. So 4 minus 4. Then amplitude should increase by 2. Then amplitude should increase by 4. Then amplitude should decrease by 2. Then amplitude should decrease by 1. And then it remains. Okay. Wait a second. From 6 to 4, then amplitude should decrease by. That's it. Here only it should be done, no? After this. So 4. Here at n equals to minus 1, the amplitude is increased by 4, then it is decreased by 2, then it will be decreased by 1 only at n equals to minus 3. What about x3 of n? So x3 of n is bounded, so you can write down from anywhere. Let's start looking at plus infinity. So if I look at plus infinity, this is n equals to 0, so this would be n equals to minus 2. Then there is a breakpoint at n equals to minus 1 as well. Again there is a breakpoint, and here also there is a breakpoint. So everywhere there is a breakpoint. There is a breakpoint at n equals to 3 as well. Are you able to understand this point? There is a breakpoint at n equals to 3 as well. Why is that so? Let's get started. So what I will write down, first jump is 3, then the jump is 1, then the decay is 1, then the increase is 1, and then the decay is, increase is 2, then the decay is 2. If I leave it here only, that means this 2 will remain there as it is. Are you getting this point? If I leave it here only, that means started with 3, then it became 4, then 3, then it became 5, then it became 2, and it will remain there as 2 only. But you need to make it 0. After that everything is 0. So then there is a decay of 3. There is a decay of 2 because final amplitude is 2. So there is a decay of 2. At n equals to 3. So now the final amplitude became 0. You can check 3 plus 1, 4, 4 minus 1, 3, 3 plus 2, 5, 5 minus 3, 2, 2 minus 2, 0. So now the final amplitude will be 0. So this is how you will represent. You can start from here as well, n equals to 2. So first jump you will say at n equals to 2. That would be the jump of 2. Say yes or no. Then there is a jump of 3. Then there is a decay of 2. Then there is a decay of 2. Then there is a jump of 1. Then there is a decay of 1. There is a decay of 1. Is that the correct answer? No. Started from here, jump of 2, jump of 3, jump of decay of 2, jump of 1, and decay of 1. After that everything is 0. What does that mean? There would be a decay of 3 as well. So minus 3 u of minus n minus 3. Say yes or no. Is that clear to you? So this is how you are going to write down x1n, n, x2n, x3n. Are you understanding all these points? If you are working in the rough notebook and if you have studied continuous time signals in a good manner, then only you will be able to understand. Because all these things we have seen in continuous time. The ditto same thing is happening. Exactly the same thing is happening. That's why we are moving a bit faster here as well. But I hope it is clear, crystal clear it is. Although it is not that important for your examination purpose. In the examination, there is very rare chance that they will ask these kind of questions. Till now, in any examination, these kind of questions have not been asked. Okay, so it depends on the question paper setter. I cannot 100% say that they will ask these kind of questions, but it is very rare. Okay, very rare. So I hope you are able to understand what we are doing. U of n, u of minus n, and then bounded signal. Next, I guess we need to study about unit ramp sequence. What we need to study? We need to study about unit ramp sequence. So what was your RT? RT was t into ut, right? It was equals to t for t greater than or equals to 0, otherwise it was 0. Here it would be equals to n for n greater than or equals to 0, otherwise it would be 0. Can I write it down as n of un? Because if I take n outward, it would be the, if I take this n outward, so what I will be getting if I take this n outward? So here I will have to put 1. N into 1 is n, n into 0 is 0. So what is this? U of n. So n into U of n. So can I write down as n into U of n? Yes. So this is your n into U of n. Okay. This is going in this direction. ये टेढ़ा क्यों लिखा जा रहा है भाई सब? Why it is going in this direction? N U n, right? So let's try making it. N equals to 0, what will be the value? 0 only. At n equals to 0, the value will be 0. At n equals to 1, what will be the value? At n equals to 1, the value will be 1. At n equals to 1, value will be 1. At n equals to 2, what will be the value? At r of 2 will be 2 only. R of 3 will be 3. R of 4 will be 4. Here there is no concept of slope or anything like that. R of 4 will be 4. R of 5 will be 5. Right? So in that manner it will keep on going. 3, 4, 5, and in that manner it will keep on going. Right? So R of n, how will you implement? That here at 0 you are having 0. After that 1, 2, 3, 4, 5. In that manner it will keep on going. This is your R of n. Right? So R of n is equal to n u n. Now you need to express R of n in terms of impulse sequence. So what is my R of n? R of n is 0, 1, 2, 3, 4, 5 in that manner, right? And this is your n equals to 0. So there is no impulse at n equals to 0. So if I write down R of n, how will I write down? There is an impulse at n equals to 1. Then there is an impulse of amplitude 2 at n equals to 2. Then amplitude 3 at n equals to 3. Then amplitude 4 at n equals to 4. In that manner. Say yes or no. So can I write it down in this manner? Delta of k going from 1 to infinity, k into delta of n minus k is equals to R of let's call it till n only, from 1 to n. K is going from 1 to n. Doesn't make any sense. No. Nah, 1 to infinity only. 1 to infinity. So what I will put 1 into delta of n minus 1 plus 2 into delta of, if I put k equals to 1, what I am getting? 1 into delta of n minus 1. If I put k equals to 2, 2 into delta of n minus 2. If I put k equals to 3, so 3 into delta of n minus 3. In that manner I will keep on adding up. So what I will be getting? R of n only. So this is your R of n only. Here you are putting the limit of k. So only n will be remaining though. So it has to be a function of n only. So yeah, we are getting the function of n only. Right? What about u of n? How will you write down in terms of u of n? What do you think? So the first jump is at n equals to plus 1, right? This is your n equals to 1. So first jump is at n equals to 1. Then there should be a jump of 1. Then again there should be a jump of 1. Everywhere the breakpoint is there. Again there should be a jump of 1. Again there should be a jump of 1. In that manner it will keep on going. So can I write it down in this manner? That k equals to 1 to infinity u of n minus k would be equals to R of n. Say yes or no. Are you understanding this point? Again there is jump of 1 1, no? Started with here, then jump of 1, then jump of 1, jump of 1, jump of 1. So 1 1 1 1 is being added like that. Say yes or no, right? So draw these diagrams. R of n minus 1. N minus 1, you need to shift towards the negative hand side. R of n plus 1, you need to shift towards positive hand side. Then R of minus 2n plus 4. How will you draw this one? R of minus 2n plus 4. R of n, then R of n plus 4, then R of 2n plus 4, and then R of minus 2n plus 4, right? Or what you can do, how you can define it? R of n minus 1. So it would be equals to n minus 1 when n minus 1 is greater than 0. This would be the better definition, or greater than equals to 0. So n is greater than equals to 1. Otherwise it would be 0. So how I can draw it? At n equals to 1, what will be the value? 0. At n equals to 1, what will be the value? 0. At n equals to 2, what will be the value? 2 minus 1, that would be 1. So in that manner we will see. 1, 2, 3, 4, 1, 2, and 3. R of n plus 1. So whatever the waveform you are having, it will be shifted like this, shifted backward. R of n plus 1. So can I define R of n plus 1? Do I have another page? Okay, I have another page as well. So R of n plus 1. So it will be n plus 1 when n plus 1 is greater than equals to 0 or n is greater than equals to minus 1. Otherwise it would be 0. So let's see what will be the diagram we will be getting. R of n plus 1 versus n. So n is greater than or equals to minus 1. So at n equals to minus 1, what is the value you will be getting? Minus 1 plus 1, value will be 0. At n equals to 0, 0 plus 1, the value will be 1. So here the value will be 1. Then at n equals to 1, the value will be 2. Then 3 in that manner. Here at n equals to 0, the value is 1. 1, 2. This is the graph of R of n. This is the graph of R of n. It is starting from 0, then it is increasing. At 0, you are having 0, 1 in that manner. Okay. So here it is just shifted backward. So in that manner, it will keep on increasing. Okay. Now you need to draw R of minus 2n plus 4. R of minus 2n plus 4. What I am going to do? I am going to just define it. That it would be equals to R of minus 2n plus 4 if minus 2n plus 4 is greater than 0. Otherwise, it would be equals to 0. That means n should be. Can you solve this inequality? Minus 2n should be greater than minus 4. If I take the negative sign, if I cut out the negative sign, then it would interchange. 4 by 2. So n should be less than 2. So from here, what we are getting? Minus 2n plus 4, that it would be equals to minus 2n plus 4 if n is less than or equals to 2. Otherwise, it would be 0. This is 2, this is 1, this is 0, this is minus 1, this is minus 2, this is minus 3, this is minus 4, and in that manner. So at n equals to 2, you put, the value will be 0. At n equals to 1, you put, the value will be, at n equals to 1, at n equals to 1, the value will be 2. At n equals to 0, the value will be 4. At n equals to minus 1, the value will be 6. At n equals to minus 2, the value will be 8. Right? This is 0. At n equals to 1, the value is 2. At n equals to 2, at n equals to 1, the value is 2. At n equals to 0, the value is 4. At n equals to minus 1, the value is 6. This, and after that, the value is 8. Here 0 otherwise. So this is how it is going. Okay. So this kind of graph we will get. Then 10, then 12. In that manner, the graph will be there. Very simple. Can you let me know the answer of this one? This we have already seen, I guess. Right? But how will you solve in this examination if this is coming? So what you need to do? I will draw the diagram of u of k. So what will be the diagram of u of k? This is the running integration only, right? This is the diagram of u of k. So u of k will be like this. It will be 1, 1, 1, 1 everywhere. 1, 1, 1, 1. In that manner, it will be 1, 1, 1, 1. Right? So 0, 1, 2, 3 in that manner. Now you are going from minus infinity to n. You are going from minus infinity to n. This is 1, 1, 1, 1. So if your n is less than 0, if your n is less than 0, so what will be your x of n? If n is less than 0, so summation would be 0 only. Now if n is equals to 0, let's just say n is equals to 0, so what will be the value of x of 0? If n is equals to 0, so only this much would be added, only one impulse would be added. If n is equals to 1, then what will be the value? X of 1. Then you need to add from minus infinity to 1. You need to add from minus infinity to 1, minus infinity to 1. So these impulses will be added, no? That would be 2. What about n equals to 2? What will be the value? Minus infinity to n. That means minus infinity to 2. These are 3. In that manner, what are you understanding? That what is your x of n? X of n is equals to, for n greater than or equals to 0, it is equals to n plus 1. Say yes or no, right? Otherwise it is 0. Are you getting this point? And what do you think, what is this graph? Have we drawn it somewhere? So n greater than minus 1, n greater than minus 1, or you would have put n greater than 0 as well. Actually, basically, let's draw this diagram. How will you draw this diagram? At n equals to 0, what is the value? 1. At n equals to 1, what is the value? 2. This is 0, 1. At n equals to 2, what is the value? 3. This was 1, 2 and 3. And then it will keep on going like this. So what is your x of n? So this is r of n shifted backward, right? So r of n shifted backward. But sir, here you saw that, here you told that, here it was n greater than minus 1, greater than or equals to minus 1. But at n equals to, n greater than equals to minus 1, the value is 0 only, no? Are you getting this point? So can I replace this as n greater than or equals to 0 as well? Are you getting this point? At minus 1, the value is 0 only. Minus 1 value is 0 only. So that doesn't matter. So even at n equals to 0, it will start following. That would be 1. At n equals to 1, it would be 2. Similarly, here as well, I can replace this as n should be greater than or equals to 2. Because at n equals to 2, it should give you 1. At n equals to 3, it should give you 2. But at n equals to 1, actually it is 0 only. At n equals to 1, it is actually 0. So if I define this r of n plus 1, r of n plus 1, how I can define it? I can define in this manner, that it would be n plus 1 for n greater than or equals to 0. At n equals to minus 1, it would be 0 only, because if you put n equals to minus 1, that would be 0 only. And otherwise as well, for n less than minus 1, it would be 0 only. So this can be the definition as well. Are you understanding this? Are you understanding the point? So at the break point, here we were having our break point, no? So at the break point, our ramp function is 0 only. At the break point, our ramp function is 0. Okay. Here also, where is the break point? Here the break point is at 1. So ramp function is 0. Here the break point is at minus 1. Ramp function is 0. Okay. Here the break point is at 2. Ramp function is 0. Are you getting this point? Right? Solve this question, find the value of alpha plus beta. Do it on your own. Draw the graph 2k minus 4. You can draw it on your own. Then take the integration from minus infinity to 2n plus 4. Then find the value of alpha and beta and then add them up. So you can do it on your own. I will post the video. You try it on your own. Okay, so let's start. No trick, nothing like that. Simply by the concept. Okay, so u of 2k minus 4. How will you define u of 2k minus 4? U of 2k minus 4 can be defined in this manner, that it will be equals to 1 when 2k minus 4 is greater than or equals to 0, right? That means if k is greater than or equals to 2, otherwise it would be 0. So what will be your u of 2k minus 4? This is your 2, 3, 4 in that manner. At greater than or equals to 2, it is 1. It is 1, 1, 1 and 1. U of 2k minus 4, right? 2k minus 4 is greater than 0, or you can say k is greater than or equals to 2. Now you need to integrate, you need to take the summation from minus infinity to 2n plus 4. If your 2n plus 4 is less than 0, sorry, if your 2n plus 4 is less than 2, if your 2n plus 4 is less than 2, then your x of n will be equals to 0. Why is that so? Because if it is less than 2, that means all the summation would be equals to 0 only. So you can say if n is less than minus 1, your x of n is coming out to be 0. And if your n is, and let's take the values now. If I take n equals to minus 1. So what will be the value? X of minus 1. That means I need to integrate from, if I put minus 1 here, so k equals to minus infinity to minus 1 if I put here, so minus infinity to 2, u of 2k minus 4. So minus infinity to 2, that would be 1. So x of minus 1 is coming out to be 1. If n is equals to 0, so what will be the value of x of 0? That would be k integration from minus infinity to, you put here, you put what you need to put, n equals to 0. So that would be 4. Are you getting this point? First I put minus 1, then I got the value to be 4 minus 2, that would be 2. If I put n equals to 0, that would be 4. So u of 2k minus 4. So from minus infinity to 4, minus infinity to 4, so 3, right? Then you put n equals to 1. So x of 1, what that would be? K equals to minus infinity to 6, u of 2k minus 4, minus infinity to 6, minus infinity to 6, 5 and 6. In that manner, how many impulses would be there? 5. So 1, 3, 5, in that manner it is going, right? 1, 3, 5. So in this manner it is going. Now this will be interesting. 1, 3, 5, 7, then it will go to 7 only, no? Because if I put n equals to 2 here, so that would be 6, minus infinity to 6, and minus infinity to, if I put n equals to 2 here, minus infinity to 8. So 2, 3, 4, 5, 6, 7, 8. So that would be 7. Yeah, in that manner it is increasing. Basically, your x of n is coming out to be what it is coming out to be. At minus 1 it is 1, then it is 3, then it is 5, then will be 7, then it will be 9. In that manner it will go. And this is your n equals to 0. Can I write it down in terms of r of n? Alpha n plus beta. How did I frame this question? What did I thought at that time? Yeah, it can be framed, I guess. The breakpoint should be at minus 1. No, the breakpoint should be at minus 2 actually. Because at the breakpoint, this is your n equals to minus 1. Where will be your n equal, where will be your breakpoint? Breakpoint will be at n equals to minus 2 actually. Why is that so? Because at breakpoint, ramp will give you 0. Unit ramp sequence at breakpoint always gives you 0. At breakpoint, it always gives you 0. Breakpoint, it gives you 0. So breakpoint will be at minus 2. That's for sure. This was your n equals to minus 1. Breakpoint will be at minus 2. Now, how would I find the value of alpha? So breakpoint I need to be at minus 2. So hit and trial I can go, right? Hit and trial if I go. So if I put the value of, in this one, if I put x of 0, what that would be? R of beta. And if I put x of 1 here, that would be R of alpha plus beta. Say yes or no. What is the value of x of 0? X of 0 is 3. And R of beta is equals to 3. One thing I know, that R of 3 is equals to 3. Say yes or no. So I have to go by hit and trial. But first let me see if I have the page or not. Because the page has crossed all the limits. Yeah, one page I am having. That I can take here. So what I am doing, what is given? Let's remove it from here. X of n is equals to R of alpha n plus beta is given. Alpha n plus beta is given. So if I put x of 0, what I am getting? R of alpha into 0 will be 0, R of beta. And what is the value of x of 0? X of 0 is equals to 3. And one thing I know, that R of n is equals to n. That means beta has to be equals to 3. R of n is equals to n for n greater than 0, greater than or equals to 0. Now what I can do? X of 1 I can put R of alpha plus beta. What that would be equals to? That would be equals to alpha plus beta. Considering that alpha plus beta is greater than or equals to 0. And what is the value of x of 1? X of 1 is equals to, x of 1 is equals to 5. this value is equals to 5. So alpha plus beta is coming out to be 5. So from here alpha is coming out to be 2. So here the answer x of n is coming out to be x of n is coming out to be r of 2 alpha, sorry, r of 2n plus 3, r of 2n plus 3. But let's define it. Let's check if our answer is correct or not. So r of 2n plus 3, if your n is, if your 2n plus 3 is greater than or equals to 0, that means if your n is greater than or equals to minus 3 by 2. But you know that n cannot be non-integer, right? N has to be integer. So what they are saying, that n should be greater than minus 3 by 2. N should be greater than minus 3 by 2. Here what will come? Minus 1, minus 1 will come, right? What they are saying, n should be greater than or equals to minus 3 by 2. But you know that n cannot be integer. N cannot be, sorry, n has to be integer. N cannot be non-integer. So if n has to be greater than minus 3 by 2, what does that mean? That actually n has to be greater than or equals to minus 1, right? And otherwise it would be equals to 0. Otherwise it would be equals to 0. So from here if I check x of n, what is coming? If I put n equals to minus 1 here, what we are getting? N equals to minus 1, what we are getting? 1. If I put n equals to 0, what we are getting? 3. If I put n equals to 1, what we are getting? 5. If I put n equals to 2, what we are getting? 7. In that manner we are going. Yeah, correct. So yeah, this is how I can solve it. Okay. So intelligently, I just thought that I can put n equals to 0 here. If I put n equals to 0, I will get r of beta, that should be equals to 3. That means beta should be equals to 3. Then I put n equals to 1. Then I put n equals to 1 here. So r of alpha plus beta. So I put n equals to 1 here, r of alpha plus beta, that should be equals to alpha plus beta. Considering that alpha plus beta is greater than 0, yeah, that is equals to 5 only. So alpha is value is 5. Alpha value is 2. So from here we checked as well, whatever the expression that we are getting, is that correct or not? Yes, it is correct. So what they asked? Alpha plus beta. Alpha plus beta is equals to 5 only. So from here, alpha plus beta is equals to 5. And that's it. That's it about our unit. Sorry, that's it about our discrete sequence. Now we need to study about the classification, like periodicity, energy, power, average, even signal, odd signal, conjugate symmetric, conjugate anti-symmetric. So that whatever that we have studied for continuous time signal, the same we are going to study about discrete time signal. And whatever that I am teaching, that is more than enough, okay, for any examination, right? Like discrete time signal is not asked at all. If you see the previous year questions, there would be very rare questions from discrete time signal, but still you need to study it because it will be used in jet transform. Well and good. So let's meet in the next video where we study about periodicity first. Okay, so we will get started with periodicity. Thank you. Hi everyone, so welcome back. Now we are going to start the classification of discrete time signal. So we will study about periodicity, energy, orthogonality, power, average, all these kind of things. Even signal, odd signal, conjugate symmetry, conjugate anti-symmetry, right? So we will start with periodicity. So what do you mean by a periodic signal? It should be repeating itself after a certain window, right? So you have seen one thing, that if your x of n is repeating itself after n naught window, right? In continuous time, what we have seen, t plus t naught is equals to xt, and then generalized way we wrote down x plus n t naught can be equals to xt, right? So after here, if you see this waveform, 2 minus 2 1, 2 minus 2 1. So after this much window, it is repeating itself. And how much is this window? 0 to 3. So this window is 3. So here, if I say my fundamental time period, n naught is my fundamental time period. Fundamental time period. N naught is my fundamental time period. So what is the value of fundamental time period? That is 3. So my fundamental time period is 3. Or I can write down in a generalized way, I can write down n plus k n naught x of n, right? Here this t naught could be anything. This t naught could be any value, any real value it could be, right? This t naught could be real and positive. It couldn't be 0. Real and positive excluding 0, I would say, excluding 0. 0, infinity and function of t, it couldn't be, right? So I could have written here real and positive excluding 0. Now this n naught will be only positive integers. Why is that so? N naught can be only positive integers. Why is that so? Because you can see that this n is itself is integer, no? This n itself is integer. So if the waveform will be repeated, then it would be after repeating after a certain integer window only, no? Are you getting this point? This n naught has to be integer only, because the waveform may repeat after one sample, or it may repeat after two sample, or it may repeat after three samples. So number of sample would be integer only. So n naught has to be integer. Okay. So here we have written positive integer. Now people will be having the doubt that, sir, can n naught be equals to 0? Can n naught be equals to 0? So just let me know, guys, can you make n naught equals to 0? Think about of any waveform. Think about of any waveform in the world. Can you make n naught to be 0? You cannot make it. Think about DC. Think about this DC. 1 1 1 1 1 1 to the power n, I can write down. Everything is 1 1 1 1. If we talk about DC xt equals to 5 in continuous time, so what did I say? It will be non-periodic, because it can have any time period from 0 to infinity. But if I talk about DC in discrete time, so 1 1 1 1 1 1, so this window is 1. It is being repeated after window of 1. So it is periodic with having a time period of 1. So yes, certainly it is periodic, because it is repeating itself after every one sample. One sample, one sample, one sample. So after every one sample it is being repeated. So certainly this is periodic. So there is no way that you can ever make n naught equals to 0. You cannot even make n naught equals to 0. So I don't need to write down here that n naught cannot be equals to 0 or infinity. So that thing I don't need to write down here, right? So that's why I'm not writing it down. What about this k? This k will also be integer only, right? X of t naught plus x of t plus 2 t naught, x of t plus 3 t naught, x of t plus 4 t naught. This is how we checked in continuous time. So similarly here as well, x of n plus n naught, x of n plus 2 n naught, x of n plus 3 n naught. So k is also integer and n naught is also integer. So this whole quantity is integer itself, and this n is also integer. So everything inside the x has to be integer, and that property we are satisfying as well, right? This n has to be integer, this k has to be integer, and this n naught has to be integer. K into n naught integer, integer plus integer, integer. So inside the x we need to have integer only, and that property we are satisfying as well. Say yes or no, right? So everything is correct here. Just keep this in box. And here you saw that n naught can be 1 as well, because it is a periodic signal only. 1 to the power n is a periodic signal only. It is repeating itself after every one sample. But DC was non-periodic in case of continuous time. Well and good. Find the time period of this particular signal. So we will start by calculating the samples. What I mean to say is that I will calculate the sample at n equals to 0. What that value will be? Because here I can put the values very easily, no? In continuous time, if I go from 0 to 1, there will be infinite values in between. So I cannot put t equals to 0, then t equals to 0.1, t equals to 0.2. I cannot do like that. But here, n equals to 0, the next value will be n equals to 1, then 3, then 4, then 5, then 6. So in that manner, I can put the values. So this is what I am doing. Sin 0 is 0. Just a second. That's what I was thinking. Charger was not on. Now x of 1. So what would be x of 1? Sin pi by 2 into 1. So sin pi by 2 is 1. Then what would be x of 2? Sin pi by 2 into 2. That would be sin pi would be 0. What would be x of 3? After you feel like that 0, 1, again 0, sir, it is being repeated. No. Let's check another sample as well. So what you are getting? Minus 1. Right? So after this it will repeat. What would be x of 4? X of 4 will be 4 pi by 2 or sin 2 pi, that would be 0. What would be x of 5? X of 5 will be sin 5 pi by 2, that would be again 1. So you can see 0, 1, 0, minus 1, again 0, 1, again 0 would come. X of 6. So what you will get here? Sin 6 pi by 2, that would be equals to 0. X of 7, 7 pi by 2, that would be minus 1. So 1, 0, 1, 0, minus 1, 0, 1, 0, minus 1. In that manner it is being repeated, right? 0, 1, 0, minus 1, 0, 1, 0, minus 1. Same thing will be happening in the negative side as well. So what do you think? What is the period? It is being repeated after every 4 samples. So n naught is 4. It is being repeated for n equals to 0 to 3. From n equals to 0 to 3. Whatever the samples we are getting. In n equals to 0 to 3, how many samples you are getting? 4 samples. N equals to 0, n equals to 1, n equals to 2, n equals to 3. So 4 samples you are getting, and after every 4 samples it is being repeated. You see here, what is this value? Omega, right? Here usually we show the omega value like this. This is your pi by 2. So what will be the time period? 2 pi by omega. That is equals to 4. But this is not the complete definition. Just hold on to a bit. Okay. Try finding the same thing here. Here we find out 2 pi by omega. 2 pi divided by pi by 2. Since this is discrete time, that's why we show it something like this. Since it is discrete time. In continuous time we were showing like this. So here in discrete time we are showing like this. Okay. This is omega only. We will call it omega. Yeah. So n naught is equals to 4 we are getting. So don't apply any formula here. Calculate the sample and then let me know what is the time period. Okay. Don't apply any formula. That's 2 pi by divided by 3 pi by 2. Don't apply that formula. Just calculate the sample. X equals to 0, 1, 2, 3, 4, 5, 6. In that manner you calculate the sample and then let me know what will be the time period. So let's start by calculating the sample. So x of 0 sin 0, that would be 0. X of 1 sin 3 pi by 2, that is minus 1. X of 2 sin 3 pi, that is 0. X of 3 sin 9 pi by 2, that is 1. X of 4 sin 6 pi, 0. X of 5 15 pi by 2, 15 pi by 2. 15 means 7 pi plus pi by 2, yeah, minus 1. X of 6, that would be 9 pi, 0. And x of 7 21 pi by 2, that means 10 pi plus pi by 2, that would be 1. So what do you think? 0 minus 1 0 1, 0 minus 1 0 1. So what is the number of samples which are being repeated? 4 samples are being repeated. So what is the value of n naught? 4. If it was a continuous time signal, if it was x of t sin 3 pi by 2t, so what I would have said, omega naught is 3 pi by 2, t naught will be 2 pi divided 3 pi by 2. So pi would get cancelled. My answer would have been 4 by 3 seconds. And there is nothing wrong in this one, right? Answer is 4 by 3 seconds only. But if it is a discrete time signal, what I will do? 3 pi by 2, omega naught is 3 pi by 2. This is what was the unit of this one? Radian per second. Say yes or no? This would be radian per sample. Here the unit will be radian per sample. Because here n is not second, right? N is not second. This is the number of sample. 0th sample, 1 sample, 2 second sample, 3rd sample. So this is known as radian per sample. Okay, no one will ask you the unit, just I am telling. Now n naught, that would be 2 pi by omega. What you are getting? 4 by 3. So this is not the answer, right? Answer is 4. So you will solve in this manner only. 2 pi divided by 3 pi by 2, 4 by 3. You will solve in this manner only. But if you are getting a non-integer, I know that n naught has to be an integer. N naught has to be an integer. So if you are getting a non-integer, so your first task would be that these two numbers should be co-prime. This is the first task, that these two numbers should be co-prime. Co-prime means they should not cancel out each other. It should not happen that it is 6 by 4. So first you will cancel out each other, you will make it 3 by 2. So this is the first task, that both these numbers should be co-prime. The first task is both numbers should be co-prime. Both these numbers should be co-prime. This is the first task. And then you will multiply by an integer. You will multiply this number by an integer such that the whole number becomes an integer. Is there any integer possible whom I multiply with 4 by 3 and the complete number becomes an integer? Yes, 3, right? So what I can do? 4 by 3 into 3. So yes, 3 and 3 get cancelled out. Answer is 4. So this is the answer. Slowly you will build the habit. This was the first example only. We will solve a lot of examples and you will get to know what we need to do. Are you getting this point? I started with this one. I got till 4 by 3. I will see, are they cancelling out? No. Then I will multiply it with an integer such that the whole number becomes an integer. So I'm multiplying with 3. What is the answer? 4. So yes, 4 n naught equals to 4 is my time period. This is very important that this has to be integer. You will multiply the number with an integer such that the number becomes integer. So very important point that this has to be integer. Okay. So this one sin n. If it was x of t sin t, what would have been your answer? X of t sin t. You would say that omega naught is 1 and then t naught would be 2 pi. No issue with this, right? There is no issue with this. Let's start by calculating the samples. What will be the value of x of 0? That would be sin 0, that would be 0. What will be the value of x of 1? Here 1 is the angle and this is not in degree. So this will be sin 1. 1 is roughly around 57 degree. It is roughly 57 degree. Okay. Here what do I mean? Pi is equals to 180 degree. That means 3.14 is equals to 180 degree. So 1 would be equals to 180 degree upon 3.14. So I don't know the value. Whatever the value is there, I don't know the value. What will be x of 2? Sin 2. Sin 2 would be just double of this. So that would be 114, roughly 114. I don't know the value. But what you can see here, we can see that it will never be repeated, right? What will be the value of 3 degree? 321, 171. Again, I don't know the value. But you know that sin 57, sin 114, 171, then something else would come. There is no repetition. Signal is non-periodic. Signal is non-periodic. Now, how I would have done in the examination hall? I would find the value of omega. What is the value of omega? 1. What will be the value of n naught? 2 pi by omega. That means 2 pi by 1. So is there, now 2 pi I am getting, I know that it is not an integer. So I will try to multiply it with an integer. So is there any integer possible? Is there any integer possible which you multiply with 2 pi and the complete number becomes an integer? No. What I am saying, is there any integer possible which being multiplied with 2 pi makes the whole number integer? You will not say that sir, I will multiply by 1 by pi. Basically I am getting 2 by 2 pi, then I will multiply by 1 by pi. So pi get cancelled. Answer is 2. No. R has to be an integer. 1 by pi is not an integer. It is not even a rational number. It is an irrational number. So you need to multiply with an integer such that the number becomes an integer. So this R is not important. R is not important. Whatever the result you get finally, after multiplying whatever the result you get finally, that 4, this is important. This 3 is not important. But first you need to think that if there is any R possible which can make this number integer. Absolutely no. So there is no R possible. No such R possible. No such R possible. What does that mean? That means it is your non-periodic. So this is how you will be solving in the examination hall. Let's take more example. Xn equals to sin 0.6. This you can take. Okay, 0.6 pi n. So you can calculate by samples, but in the examination hall, what you are going to do? Omega naught 0.6 pi. Omega naught is 0.6 pi. So n naught 2 pi by 0.6 pi. What you are getting from here? 20 by 6. Now you will think that sir, if there is any integer which will make this complete number integer. So you will say, sir, yes, there is 6. 20 by 6 I am getting. Is there an integer which will make this complete number integer? So if I multiply by 6, 6 and 6 will get cancelled. Your answer will be 20. But this is wrong. Why is that so? Because I told you, for finding the fundamental time period, first you need to cancel them out, no? If I cancel them out, these are being cancelled out, right? They have to be co-prime. So you need to cancel them out. 10 by 3. Then into R. Now if there is any R possible, yes. The integer value, that is 3, if R value is 3, then 3 to 3 will get cancelled out and then the number will become 10. That is an integer. So this is your n naught. Although 20 is also a time period, but it is not fundamental time period. So in the examination hall, if they have just mentioned that find the time period, they are talking about fundamental time period only. They don't want this answer to be 20. they want a fundamental time period. So yes, your fundamental time period would be 10. After 20 samples also it will be repeated, but fundamental minimum number of samples would be 10. So after minimum 10 samples it would be repeated. Okay. So first thing, you need to cancel them out if they are cancelling out. So 10 and 3. Now they are further not cancelling out. Now you need to think of an integer. Yes, 3 can cancel out this one. Answer is 10. Okay. So here I don't need to write down the conclusion. What I would do, n naught 2 pi divided by pi by 2. So this is getting cancelled out. Answer is 4. No need to do any calculation here. 2 naught 2 pi divided by 3 by 2. What I am getting? 4 by 3. Then I need to multiply by 3 because there should be some integer which will make this as integer. Answer would be again 4. And this here n naught would be 2 pi by 1. There is no integer possible which will make it periodic. So it would be non-periodic. This is how you do it. Okay. And there could be any shift as well, like pi by 2n plus pi by 3 or 3 pi by 2n plus pi by 3, pi by 6, pi by 7, that doesn't matter, right? So try solving this one. If this was the question, xt equals to sine under root pi, sine under root 2 pi t. So what would have been the answer? Omega naught would be under root 2 pi, then t naught would be 2 pi divided by under root 2 pi. And you are absolutely fine with that. Answer would have been under root 2. No issue. If I do the same process here, omega naught is under root 2 pi. What will be my not t naught, sorry. What will be my time period? 2 pi divided by under root 2 pi. What we are getting? Under root 2 into r. I need to multiply it with an integer such that the whole number becomes integer. Is there any integer possible? If you multiply it with under root 2 and the whole number becomes an integer, you can say, sir, r I can take to be under root 2. But under root 2 is not an integer. This r has to be an integer. So there is no integer such possible. This has to be an integer. So such kind of value is not possible. That means it is non-periodic, right? But if it was in discrete time, sorry, if it was in continuous time, it was periodic. What about this one? Same goes for e to the power omega naught n as well, right? E to the power omega naught n as well will have the same thing. Say yes or no. So here also, what is the value of omega naught? 1.2 pi. What will be the value of n naught? 2 pi by omega naught. That would be 20 by 12. So from here I should start the calculation. No, I need to cancel it out because I can see that it is being cancelled out. So it is being cancelled out with 4. So 4 5s are 20, 4 3s are 12 into r. So yeah, there is some r possible. The value of r could be 3. This and this get cancelled out. Answer is 5. So this is the value of your n naught. So n naught is 5. Okay, you don't need to check again and again. What we did, 2 pi divided by 1.2 pi, 20 by 12, then it is being cancelled out, 5 by 3, and I need to multiply with an integer such that the whole number becomes an integer. So 3 I will multiply, so answer is 5. Okay. Minus 1 to the power n. So here I can just put the samples. What will be the, if nothing clicks in the examination hall, if nothing is clicking, just try putting up the sample. In discrete time problem, no matter whether it is from periodicity or power, energy, even odd, nothing, if nothing clicks, put the values. X of 0, what will be the value of x of 0? Minus 1 to the power 0. What that would be? Minus 1 to the power 0, that would be 1. What would be x of 1? Minus 1 to the power 1, minus 1. What would be x of 2? Minus 1 to the power 2, that would be 1. What would be x of 3? Minus 1 to the power 3, minus 1. What would be x of 4? Minus 1 to the power 4. X of 5, minus 1 to the power 5. So 1 minus 1, 1 minus 1, 1 minus 1. So here number of samples are 2. So n naught is 2. Or what could be the other way? Other way could have been this x of n. Do you remember the value of e to the power j pi? Yes, it was minus 1. Cos pi plus j sin pi. Cos pi value is minus 1, sin pi is 0. So e to the power j pi is minus 1. So I can write down this as in this manner. Okay. Omega naught is pi. What will be the value of n naught? 2. right? 2 pi by omega n naught value is 2. So this is how you could have done it, or you could have checked the sample as well, right? If there is any shift as well, there is no issue. Even if there is a shift, there is no issue, right? So only you need to pick this omega naught, that is pi by 4. So n naught would be 2 pi divided by 5 pi by 4. What you are getting? 8 by 5, right? By 8 by 5. Then you need to multiply with an integer. So what is that integer? That integer is 5. So 5 will get cancelled out. Answer is 8. So always remember, there has to be integer, not any random number. Okay, so this is your n naught. So I will always multiply with an integer. What about this one? If there is any shift, or if there is sinusoid or cosinusoid, that also doesn't matter. Only you need to see omega naught, right? 3 pi by 4 n naught 2 pi 8 by 3, right? Read the calculation correct. 8 by 3 need to multiply with 3. Answer is 8. This is your n naught, right? Cos pi n square. If it was cos pi t square, I told you it was non-periodic, right? We put t plus t naught. Here in place of t plus t naught we put then cos pi t plus t naught square, and then we put equals to cos pi t square, right? And from here we compared. Then I got to know that my t was coming out to be a function of t. Sorry, my t naught was coming out to be a function of t. T naught was coming out to be a function of t. That means it was non-periodic, right? But we are not going to do this thing with the discrete time signals. Why is that so? Because here n naught value is 0, 1, 2, 3. So who knows, something may happen, right? N value is 0, 1, 2, 3. So I will check the samples. In discrete time problem, if there is a random, if there is a random waveform, or if there is a random signal, so without even checking the samples, I will not make any conclusion. I will check the samples. So what I am putting? Pi into 0 square. So sin cos 0 would be 1. X of 1, that would be cos pi. Cos pi would be minus 1. X of 2, that would be cos 4 pi. Cos 4 pi would be 1. X of 3, that would be cos 9 pi. Cos 9 pi would be minus 1. X of 4, that would be cos 16 pi, that would be 1. X of 5, that would be 25 pi, that would be minus 1. So 1 minus 1, 1 minus 1. In that manner you will realize that something is being repeated. So 1 minus 1, 1 minus 1. So in discrete time signal, if there is some unconventional signal, okay, here it was not following cos omega naught n plus pi by 4. Here n square is there. So if there is anything unconventional, I will put down the values and I will check if it is being repeated or not. So yes, it is being repeated, and here n naught value is 2. So this is how I should have my brain open in the examination hall. Directly I will not mug up any formula or any concept. Okay, try this question. Tell me the answer. Answer is 2. What do you think? Answer is 2, right? So try this question first. I will take a pause, drink some water, and you try this question. Yeah, so what was your answer? You said omega was 3 pi. N naught would have been 2 pi divided by 3 pi. Then 2 by 3. Then I can multiply it by 3. Answer is coming out to be 2, which is wrong. Why is that so? Let's check the samples. Sin 0, 1. Sin 3 pi, sorry, not sin 0, 1. क्या कह रहा हूँ यार मैं? Sin 0, 0. Sin 3 pi, that is also 0, right? 2. Sin 6 pi, that is also 0. 3. Sin 9 pi, that is also 0. Signal is actually always 0, because if in the sine you are having a multiple of pi, in the sine, in the angle, if you are having a multiple of pi, that will always be 0, right? In the sine, if you are having a multiple of pi, that will always be 0. So this will always come out to be 0. So signal is always 0. X of n is always 0. And if it is always 0, 0, 0, 0, 0, that means what is the periodicity now? That is 1. It is a DC with 0, right? Basically, if you make the waveform, this is how the waveform would look like, that every sample is 0. That means there is nothing basically. 0, then 0, then 0, then 0, then 0, then 0. So what is this periodicity? N naught is 1. So sir, the formula will not work here. Yes, only in some exceptional cases the formula may not work like this. So what I will say, in exponential the formula will always work. In exponential formula will always work. In cosinusoid and in sinusoid, it might happen that in some cases it doesn't work. If your n naught value is coming out to be very low, let's just say n naught came out to be here, n naught came out to be, by the formula n naught came out to be 2. So in the examination hall, I will recheck by putting these values. So I should not say recheck, I will say cross check. If n naught value, I am saying if n naught value is coming out to be low, I will cross check. Let's just say it came out to be 2, 3 or 4. So I will put the value, right? 0, 1, 2, 3, and then I will check if it is being repeated or not. Because in the examination hall, they can frame some question in a manner that this kind of cases come. So it just clicked to me. That's it. I thought of taking this example, and then I just saw that if I calculate the sample, it is always coming 0. So whatever that has clicked to me, the same thing can click to the IIT professor as well, right? So if n naught is low, like 2, 3, in that manner, if it is coming out, I will cross check. But if n naught is coming high, let's just say it is coming like 20 or 30. So now I cannot cross check, right? I cannot write down 20 samples, then I will write down 20 another sample, and then I will see if they are being repeated or not. So that will be a very hectic process. So by the formula, if it is coming out to be very larger, then you have to go with the formula only. Believe on the formula and go with that. Are you understanding the point, what I am saying? If your periodicity is very low, I will cross check. If periodicity is very high, then I will believe on the formula and proceed with that. I will just believe that there will be no kind of exceptional cases. Exceptional cases, if they want to frame the question on exceptional cases, then they will frame easy only. That means they will keep the n naught value, they will keep the periodicity lower. If they are keeping the periodicity higher, that means certainly the formula is working there. Okay. So if n naught value by the formula is coming higher, then you need to believe on the formula and proceed with that. Okay. But n naught is low, then we will cross check. So this is what you can write down in your notebook, that if n naught is low, I will cross check. If n naught, like here, first thing is that it will always work in exponential. Here n naught is coming out to be 8. So no need to cross check. Here also no need to cross check. N naught is coming out to be 8, larger value. In this case, n naught was coming out to be 5. This is not larger, but exponential will always work. Exponential, there is no exceptional cases in an exponential. Okay, exponential will always be fine. Exponential will always work with respect to formula. Only the problem is with sinusoid and cosinusoids. So problem is with the sinusoids and cosinusoid. Are you getting this point? Let's take one more example. Let's try making n naught to be 20 or 40. So cos 3 pi by 20 n plus pi by 3. Okay. So from here what I am seeing, that my omega value is coming out to be 3 pi by 20. So what will be the value of n naught? 2 pi divided by 3 pi by 20. So that would be 40 by 3. And then I need to multiply. What is the answer I am getting? 40. So n naught is 40. So do you really think you will cross check here? No. You don't need to cross check here. Why is that so? Because n naught is very large. So believe on the formula, answer is 40 only. So are you getting the point here? What is the point? The point is you will only cross check if n naught is very low. And these kind of exceptional cases can also come. This is just an exception where formula is not working. So for that I just checked it. Well and good. Linear combination of periodic sequence, the same thing is there. You will calculate n naught, then you will see the ratio. If ratio is coming rational, then it is fine. If it is coming irrational, then you will say that it is not periodic. And after that you will calculate HCF and LCM. That thing we have already studied. So for n naught, what do we do? We calculate LCM. And for omega naught, what do we do? We calculate HCF. If you remember this thing, for omega naught we were calculating HCF, for T naught we were calculating LCM. So let's start here. 1 to the power n, what is the value of n naught? 1. Because it was continuously repeated, right? So value of n naught is 1. Here, what is the value of n naught? N naught will be 2 pi divided 3 pi by 2. So that would be 4 by 3. Can be multiplied with 3. So n naught is coming out to be 4. Right? And what about this? N naught will be 2 pi divided by pi by 3. So n naught is 6. So here should not call it n naught. Let's call it n naught 1, n naught 2 and n naught 3. So what will be your final n naught? That would be the LCM of 1, 4, 6. The smallest number which can be divided by 1, 4 and 6, that would be 12. So this is your n naught. What will be your omega naught? That would be 2 pi by 12. That would be pi by 6. Yeah, one more thing I needed to check if they are rational or not. Their ratio should be rational. So 1 by 4, 4 by 6 and 1 by 6. So their ratio is rational, so no issue there. Are you getting this point? So if ratio is rational, then these answers are correct. So here the answer will be 12. If they are asking omega naught, answer would be pi by 6. A very random example, mod is also there, n square is also there, very random, right? First thing you know that if mod is there, you need to be aware because you will check by options. But let's just say in this question options are not there. So what I will do? And very random it is, n square is also there. So if it is very random, I will put the samples, nothing else. Because here no formula, no concept, nothing will work. Only put the value of n. N equals to 0, n equals to 1. In that manner you put. If it is being repeated, you will see it. If it is not being repeated, then also you will see it. So everything is very random here. So I will not apply any formula. I will just get started. X of 0. Sin 0 would be 0. Cos 0 would be 1. X of 1. Sin pi by 4 is 1 by under root 2. Sin pi by 2 is 0. X of 2. Sin pi is 0. Cos pi is 1. X of 3. Sin 9 pi by 4 would be 1 by under root 2 and sin 3 pi by 2 would be 0. You see, you can directly see it is being repeated. Let's check for more. X of 4. 4 into 4, 16. 4 pi. Sin 4 pi would be 0 and 4 cos 2 pi would be 1. So yeah, I can directly see it is being repeated with the number of samples of 2. In the examination, it might happen that number of sample would be 4. So in these kind of questions, number of sample would not be greater than 4 or 5. You just need to check, okay, 1, 2, 3, 4, 5, 6. If you check for some samples, you will get to know it is being repeated or not. So yeah, it is being repeated with n naught of being 2. If it was a continuous time signal, let's just say here t square was written, here t was written, then you would get to know that certainly this is not a periodic function. If it was continuous time, what I am saying, if it was xt equals to sin pi by 4 t square plus cos pi by 2t. So I know that this is periodic, but this is non-periodic, right? This function is non-periodic, and if you take the mode, then how you are supposed to make it periodic? So certainly it is non-periodic. So this is non-periodic, and non-periodic plus periodic would be non-periodic only. So for continuous time, it would be non-periodic. But in discrete time, I will always prefer putting the values 0, 1, 2, 3 in that manner. Okay. What about this one? Here let's make it somewhat like this. 3 into 1 to the power n. So again, it has the, I just multiply with 3. That will not change the periodicity, right? Again, it has the periodicity of 1. This has the periodicity of n naught equals to 2 pi by under root 2 pi is equals to under root 2. This is non-periodic because there is no integer possible whom I multiply with under root 2 and it will make it integer. So this is your non-periodic. The question ends here because if it is non-periodic, there is no meaning of proceeding, right? Or you can check here what would be the n naught. You would say n naught will be 2 pi by 2. But this guy is becoming non-periodic. Although this is also periodic, this is also periodic, but this guy is becoming non-periodic. That means whole function becomes non-periodic. Right? Well and good. Okay. So xt was having a time period of t naught, then x of at was having a time period of t naught by mod of a, right? And both were periodic. But this does not happen in discrete time signal. So we will solve it by an example. A very good question. I would say best question of complete discrete time signal. In the whole chapter I am saying this is the best question. And very high chances that this kind of question would be coming in your examination in future. Because this is from OpenM. A very standard question it is. In a lot of places, even in NPTEL lecture, everywhere you will find this particular question. Everyone deals with this particular question if you are studying from a good resource. And the thing is, everyone deals with this particular question. That's why I think it is not asked in the examination hall. Okay, because teachers also know that students have studied it. This might be the reason they are not asking it, right? So what they are saying, x of n is a random discrete time signal, and let they are defining two functions y of n and y2 of n. Okay, whatever they are defining, you can see it. So if x of n is periodic, then y1 n is also periodic. This is what they are saying. What is x of n? That we don't know, but they are saying that if x of n is periodic, then y1 of n, that is x of 2n, that is also periodic. y1 of n, what is y1 of n? That is x of 2n only, so that is also periodic. Is that statement correct? So what we are going to do, we will take the example. We will always solve these kind of questions with respect to example, and in the examples, first we will take the number of samples to be odd, and then we will take number of samples to be even. What I mean to say is that I will take my x of n somewhat like this. Number of samples can be odd. That means I will take 5 samples. 1, 2, 1, 3, minus 1. Number of samples are 5, and I will keep this as n equals to 0. So this is a random x of n I am taking, but what they are saying, x of n is periodic, so I need to make it periodic. Really sorry. Yeah. So these 5 samples are there. Now these 5 samples will be repeated. 1, 3, minus 1. And these 5 samples will keep on repeating. I am starting with n equals to 0. But since it is periodic signal, what is the property of periodic signal? That it should be extended from minus infinity to infinity. Right? So this would be your x of n. Because it cannot happen that from n to infinity it is periodic. No. It has to be periodic from n equals to minus infinity to plus infinity. From minus infinity to plus infinity. Now what I need to calculate? X of 2n. What is the meaning of x of 2n? If this is n equals to 1, this will be divided by 2. This is 2, this will be divided by 2. So in x of 2n, what will happen? 1 sample will keep on cancelling out. So whatever that is there, I don't care. But now 1 samples will keep on cancelling out. This will cancel out, this will cancel out. Then 1, this cancel out, this cancel out. Then this cancels out, this cancels out, this cancels out. In that manner, it will keep on going. So what you are getting? 1, 1, minus 1, 2, 3. So till now I am not able to comment whether it is periodic or not. So I need to take more samples. Because I am not able to comment, right? 1, 1, minus 1, 2, 3. It is being repeated or not? So I am not able to comment. So I need to take more samples. So let's take more samples. 1, 2, 1, 3, minus 1. 1, 2, 1, 3, minus 1. Again 1, 2, 1, 3, minus 1. Again 1, 2, 1, 3, minus 1. In that manner it will keep on repeating. So here 2 will cancel out, 3 will cancel out. 1 sample is being cancelled out. Are you getting this point? This would be 1 by 2, this would be 2 by 2. What this would be? 3 by 2. 3 by 2 doesn't make any sense. This would be 5 by 2. This would be 7 by 2. So all these are getting cancelled. So this is 1, this is 1, this is minus 1. So what you are getting? So till this point 3 we have written. Then after that 1, 1, minus 1, 2, 3. After that the same cycle will keep on repeating. So here what you are able to understand? What you are able to understand? 1, 1, minus 1, 2, 3. 1, 1, minus 1, 2, 3. It is being repeated with the periodicity of 5. So x of n, x of 2n is also periodic. Right? And if they ask you the periodicity, that is 5. So if I say that my x of n was periodic with the periodicity of n naught, my x of n was periodic with the periodicity of n naught, that means my x of 2n will also be periodic with the periodicity of n naught. Is that statement correct? No, not completely correct. Why is that so? Because here we took the example of number of samples to be odd. I will take the example of number of samples to be even as well. That example also I need to take. Are you getting this point? So whenever you need to comment on periodicity, if the question was if x of n is periodic, then x of 2n will be periodic or not? Yes, it will be periodic. This answer is correct. But if they ask you to comment on periodicity, at that time you need to think. What you need to think? That if number of samples are 5 which are being repeated, or if the number of samples are 4 which are being repeated. That means if I take x of n to be somewhat like this, 1 2 1 minus 1 1 2 1 minus 1 1 2 1 minus 1 1 2 1 minus 1. In that manner it is repeated. This is n equals to 0. So which all x of 2n if I calculate, then which all things will be cancelled out? This, 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 this. All these will be cancelling out. So 1, 1, 1, 1, 1, 1, 1, 1, 1, 2, 1 minus 1, 1, 2, 1 minus 1. So here what is being cancelled out? Here periodicity was 4, but now the periodicity is coming out to be 1, 2, 1 minus 1. It is coming out to be n naught by 4. Here the periodicity was 4, right? 1, 2, 1 minus 1, 1, 2, 1 minus 1, 1, 2, 1 minus 1. Yeah. So periodicity was 4 here. But now here what is the, it is certainly periodic. There is no doubt about that it will be periodic. But here what is the periodicity that is coming out to be? Here the periodicity is coming out to be n naught by 4, right? Because here the periodicity is 1. So you cannot actually comment on periodicity here. The thing is, if the number of samples are even or odd, you cannot comment on the periodicity. Here luckily we got the same periodicity. That doesn't mean it will always be having the same periodicity. So the conclusion is we cannot comment. Are you getting this point? The conclusion is you cannot comment on the periodicity. Here n naught, here n naught by 4. But in both of the cases, certainly they are periodic. That's for sure. So what our first statement is saying? Our first statement says that if x of n is periodic, then y1 of n will be periodic. Yes. That's absolutely true. Now let's go to the second statement. If x of 2n is periodic, or you can say if y1 n is periodic, then x of n will be periodic or not. So the second statement, y2n, or you can say x2n is periodic, then what about x of n? So try doing this on your own. Okay, try doing this on your own. Okay, I will take a pause, you try doing this on your own. Okay, so let's start. X of 2n, x of 2n, I can take any random example. Let's first take the examples to be having odd number of signals, odd number of samples which are repeated. So 1 2 0 1 minus 1, 1 2 0 1 minus 1, 1 2 0 1 minus 1. In that manner it is being repeated. Now it is very obvious, if I do x of n, that would be x of 2n by 2. Basically I need to expand it. So x of 2n by 2. What is the meaning? Let's just say this was your n equals to 0. This was your n equals to 1. So this will become n equals to 2. This will become n equals to 4. So n equals to 1 you are not having. So one sample you need to include in between. Let's just say this was 1. So here you will include one sample. Then 2. Then another one sample you will include. Then 0. Then another one sample you will include. Then 1. Another one sample you will include. Then minus 1. Then another one sample you can include. Then again 1. Another one sample. 2. Another one sample. So what I mean to say is that here I introduce alpha sample, beta, gamma, A, B. So 1 alpha 2 beta 0 gamma 1 A minus 1 B. Then again 1 is starting. This cycle is again starting here. But here I can introduce some different sample, that could be C, this could be D. So now this till this point, okay, from here to here. After this it is not being repeated. Although the 1 is repeated, but there could be random sample in between. No, I said that it is not necessary that these samples will always be 0. It could be any random sample. And if it is a random sample, what does that mean? If these are the random sample, that means it will be non-periodic. So if you are expanding your signal, if your signal is being expanded, then it will be non-periodic only, because any random sample would be coming in between. So I don't even need to check with the example of even signals, because in the even signal, I do not need to check with the example of a number of samples to be even. Here we checked for the number of samples to be odd and number of samples to be even. Here we are checking for the number of samples to be odd. I don't need to check for the number of samples to be even. Why is that so? Because there as well the signal will be expanded. And if the signal is expanded, what does that mean? That means you will introduce random samples here. And if you are introducing random samples, that means the signal will be non-periodic only. So answer is non-periodic. Now what does the third one says? In the third one, if xn is periodic, then y2n is periodic. If x of n is periodic, then what is your y2n? Y2n is actually xn by 2. So you will say that, sir, again here this will also be expanded. The same thing we are doing, no, n by 2. So that means it will be also expanded. But they have told one thing, that this will work only when n is even. And if n is odd, the sample should be 0. So what they have made here, if you are expanding it, then at the expansion this random sample has to be 0 only. Let's check it out. Let's check x of n. X of n is 1, 2, 1, minus 1. 1, 2, 1, minus 1. 1, 2, 1, minus 1. In that manner. This is your n equals to 0. This was 1. But if you calculate x of n by 2, for x of n by 2, this will become 2. This will become 2 into 2. This will become 3 into 2. So if you start here, at n equals to 0, at n equals to 0, this is even. At n equals to 0, 1 will come. That means from here you will put. At n equals to 1, a random sample would come. At n equals to 2, 2 would come. At n equals to 3, random sample would come. At n equals to 4, 1 would come. At n equals to 5, random sample. At n equals to 6, minus 1 would come. At n equals to 7, random sample. At n equals to 8, 1. At n equals to 9, random sample. Then 2, then random sample. Then 1, random sample, in that manner. But what they have said, this was your n equals to 0. This was your n equals to 2, 4. At n equals to 1, what should come? Odd should come. At n equals to 1 means n equals to odd. N equals to 3. N equals to 3 means n equals to odd. N equals to 5 means n equals to odd. N equals to 6 means, sorry, n equals to 7 means n is odd. N equals to 9 means n equals to odd. And in the odd places, always 0 would come. So these were the even places. Even places means you will copy from here. Even places. But in odd places, 0 would come. Always 0 would come. So you can see here 1 0 2 0 1 0 minus 1 0. 1 0 2 0 1 0 minus 1 0. Again 1 0 2 0 1 0 minus 1 0. So here the only problem was I was introducing random samples. But now the samples that are being introduced, they are certainly 0 because they have made the signal like this. So this will also be periodic. So when your signal is being shrinked, here signal is being shrinked. Shrink means it is being decreased. Here first the number of samples was more. So it is being decreased now. So if it is being decreased, then certainly it will be periodic. But if it is being expanded, so the problem is if the signal is being expanded, then I can introduce random samples. And that is making it non-periodic. But if I do something like this, that if it is being expanded, then in the expansion, I am not going to put random samples. In the expansion, I am going to put only zeros or a fixed value. Here they could have written 2 as well. If they had written 2, then 2, 2, 2, 2. Still it would be periodic only. So in place of random sample, I need to fix a number. If the number is fixed, that means it will be periodic. Forget about the periodicity. Okay, we don't care about the periodicity. But I guess periodicity will be double only. Always it will be doubled. Here it was doubled. If I take some another case, yeah, periodicity will always be doubled. This will be, if this was periodic with 4, now this is being periodic with 8. So periodicity will be doubled. So n naught dash I am saying that would be double of this. If you take odd samples as well, then also it will be doubled only, right? Because it is being expanded. So it will be doubled only. So n naught dash will be equals to 2 n naught. Next, what they are asking, if y to n is periodic, then xn is periodic. So y to n. y2n is actually x of n by 2. N is odd, n is even. If this is periodic, then xn is also periodic. This is what they are saying. So let's calculate y2 of n. So any random value I'm gonna put, but I cannot make it so random. Here I can put any random value from my own side, but the next value has to be 0, because this is your n equals to 0, this is your n equals to 1, n equals to 2, n equals to 3, n equals to 3 has to be 0, n equals to 4, n equals to 4 I will put as -1, but n equals to 5 has to be 0. This is your n equals to 4. So this n equals to 0 to 4 I can put on my own, but rest these odd number 1, 3, 5, 1, 3, 5, 1, 3 and 5, they have to be 0 only. So now I am saying that only this sequence is being repeated. That means after that 1, 0, 2, 0, minus 1, 0, 1, 0, 2, 0, minus 1, 0, 1, 0, 2, 0, in that manner it is repeated. This is what I am saying. So this is your y2 of n. What I need to find? X of n. So this was y2 of n. From here I need to find x of n. So x of n by 2, basically these numbers are for x of n by 2, right? X of n by 2. Say yes or no. And from here I need to go to x of n. That means I will have to cut the samples, no? Are you getting this point? From x of n to you are going to x of 2n. From x of n to you are going to x of 2n. That means all these will be divided by 2. X of n by 2 to I am going to x of n. X of n by 2 to I am going to x of n. That means I am multiplying my x of n can be written as 2 into n by 2. 2 into n by 2. That means my time domain is being multiplied with 2. That means time axis will be divided by 2. 6 by 2. It will be divided by 2. So what will happen here? 0 will be there as it is. This will get cancelled out. 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 All these will get cancelled out. So 1, 2, minus 1, 1. 1, 2, minus 1, 1. Then again 1, 2, minus 1, 1. 1, 2, minus 1, 1. 1, 2, minus 1, 1. Again 1, 2. Here there is some issue, I guess. 1, 0, 2, 0, minus 1, 0. 1, 0, 2, 0, minus 1, 0. 1, 0, 2, 0. Yeah, so 1, 0, 0, 2, 0, minus 1, 0. 1, 0, 2, 0, minus 1, 0. Yeah, so 1, 2, minus 1. Then again 1, 2, minus 1. Sorry, it was 1, 2, minus 1. Then again 1, 2, minus 1. Then again 1, 2, minus 1. In that manner it is repeated. So here the periodicity was 6. 1, 0, 2, 0, minus 1, 0. 1, 0, 2, 0, minus 1, 0. But now it is 1, 2, minus 1, 1, 2, minus 1, 1, 2, minus 1. Are you able to understand this point? We started with n equals to 0, 1, 2, 3, 4, 5, 6 in that manner, and this is how I defined it. Now I need to go to x of n. So basically I am going from x of n by 2 to x of n. That means I am shrinking my signal. Shrinking my signal means one sample will get cancelled out now, because it is x of n by 2 to x of n. So I am multiplying by 2. If I am multiplying by 2, that means one sample I need to cancel out. And I have cancelled out these samples. So I am getting periodic only. So this is also periodic. Okay, and here also the periodicity will be half only always. Because one sample will get cancelled out, all the zeros will get cancelled out. So here also the periodicity will be half. Here also the periodicity, here periodicity was getting doubled. Here you cannot comment, right? And this was already non-periodic. So this is the complete solution of this particular problem. So which all statements are correct? 1, 3 and 4. So simple conclusion is, if you are shrinking the signal, then certainly it will be periodic. From in this one we were shrinking it. First question, we were shrinking the signal. If you are shrinking the signal, that means if you are cutting the samples, it will be periodic only. But if you are expanding it, if you expand it with the random number, it will be non-periodic. But if you expand it with the certain number 0, 0, 0, it will be periodic. and here you are again shrinking it. So if you are again shrinking it, that means it will be periodic only. So did you understand the conclusion? Expanded, periodic. Sorry, shrinked, periodic, but expanded depends on the sample that you are taking. If the samples you are taking to be a certain number, that means it will be periodic, otherwise it will be non-periodic. Well and good. Okay. So these are some basic mathematics problem. After that, we need to see orthogonality. So let's solve this basic mathematics. So what does this mean? N equals to 0 to 3 summation n. That means you will put n equals to 0 here. First you will put n equals to 0. Then you will put n equals to 1. Then you will put n equals to 2. Then you will put n equals to 3. So n values will come 0, 1, 2, 3. With respect to that, what is the value of this function? If n equals to 0, then what is the value of this function? That is 0. If n equals to 1, then what is the value of this function? That is 1. If n is equals to 2, then what is the value of this function? That is 2. And if n is equals to 3, then what is the value of this function? That is 3. And then you need to add all of them. So whatever the answer you get here, 6. So if it is going from 0 to n, then there is a formula for this, because what will happen? 1, 0 plus 3, in that manner we will keep on going, and the nth term will be n. Basically, 0th term was 0, first term was 1, second term was 2, third term was 3. So nth term will be n, right? So the summation will be n into n plus 1 by 2. So this formula you can remember. Here you can apply the same thing, 3 into 3 plus 1 by 2. So what you are getting? 6. Here the value of capital N was 3. So 3 into 3 plus 1 divided by 2. So answer is 6. For n square, there is also formula. Here what you are going to do? 0 square, then n equals to 1. At n equals to 1, what is the value of n square? 2. At n equals to 2, what is the value of n square? 2 square. At n equals to 3, what is the value of n square? 3 square. Till n square. So that would be n into n plus 1 into 2n plus 1 divided by 6. Okay, so you need to see this value. So n into n plus 1 into 2n plus 1 divided by 6. And for this one, 0 cube plus 1 cube, 2 cube, 3 cube, in that manner it will keep on going. So this formula, then just you take the square, n into n plus 1 divided by 2, and then take the square. Okay, so this is how we need to, if you want to remember this formula in mathematics, you will certainly remember this formula. Okay, and you should remember it. In mathematics, you will certainly remember all these formula. So it is very highly recommended that you remember these formula. Okay, n equals to 0 to 3, 1. So what you are going to do? You will put n equals to 0. At n equals to 0, what is the value here? 1. You will put n equals to 1. At n equals to 1, what is the value here? 1. You will put n equals to 2. At n equals to 2, what is the value here? 1. You will put n equals to 3. At n equals to 3, what is the value here? Again 1. So what is the answer? 4. Are you getting this point? This is what we are doing here, right? N equals to 0, what is the value of n equals to 0, what is the value here? 0. N equals to 1, what is the value here? 1. N equals to 2, what is the value here? 2. Same goes here. N equals to 0, what is the value here? 0. N equals to 1, what is the value here? 1 square. N equals to 2, the value will be 2 square. But here it is fixed, right? Here it is fixed. So n equals to 0, the value is 1 only. N equals to 1, again the value is 1. N equals to 2, again value is 1. N equals to 3, again value is 1. What about this one? N equals to 2, the value is 1. N equals to 3, the value is 1. N equals to 4, the value is 1. N equals to 5, again the value is 1. Answer is again 4. What about this one? N equals to 2, value is 3. N equals to 3, value is again 3. N equals to 4, value is again 3. N equals to 5, the value is again 3. I can write down it in this manner. 1 plus 1. And can it be replaced by like this? This particular thing you can see here, that is 2, 2, 5, 1. So basically you can take this 3 common. If there is a constant number, you can take that common. So what you are getting? 3 into 4, that is 12 only. So there is a random number alpha. What I can do? I can take this common. N equals to A to B 1. Now let me know one thing. For how many samples you are counting it? Here how many samples were there? From 0 to 3, how many samples were there? From 0 to 3, how many samples are there? n equals to 0, n equals to 1, n equals to 2, n equals to 3. So total number of samples are 4. That can be found in 3 minus 0 plus 1. Here how many samples are there? 2, 3, 4, 5. Second sample is there, third sample is there, fourth sample is there, fifth sample is there. So how many samples are there? Again number of samples are 4. That can be found as 5 minus 2 plus 1. So similarly, how many samples are there? So alpha will be there as it is. And how many samples were there? 4 samples were there, so answer was 4. 4 samples were there, answer was 4. So similarly here as well, how many number of samples would be there? B minus A plus 1. B minus A plus 1. 5 minus 2 plus 1. 3 minus 0 plus 1. 5 minus 2 plus 1. So this was 4 only. And the constant value is coming out. So here the answer would have been 3 into 5 minus 2. That would be 3 plus 1. So 3 into 4. That would be 12. So answer was 12 only. Are you getting this point? So this 1 is added for the number of samples time. And the number of samples are B minus A plus 1. So these many number of samples are there. This shows the number of samples. And alpha is added for these many number of samples. So this would be the answer. Are you getting this point? Okay. So this is the answer, alpha into B minus A plus 1. Well and good. Next we will study about orthogonality. In this lecture only I will add up the part, but our periodicity is over. Okay, periodicity is over. I hope you would have understood every single thing about periodicity, and it was a easy lecture only. But the thing is, you can revise it within 5 minutes. We will start from here. Yeah, there are certain formula. The formula is omega will be given, and I will find it like this. But there would be some exception as well. Okay, if linear combination is there, the same ratio thing I need to do, and not values I will find. Ratio will be always rational, and if it is rational, I can find the LCM. And if I need to find omega naught by HCF also I can find out. But first I will find LCM. So in that manner I will go. If there is a very random example, I will put the values of n. Here it was non-periodic only, so there is no meaning. Then this was about the periodicity, how x of n, x of 2n, x of n, x of n by 2, that periodicity we have seen. And then we saw some basic mathematics. Next we need to study about orthogonality. Okay. Yeah, so now we need to start orthogonality. But before starting orthogonality, let's see some more mathematics. So do you know the summation of GP? Although a lot of guys would already be knowing, but what is the summation of this GP? A plus AR square plus 8R to the power n minus 1. How many terms are there? N terms are there, right? This is first term, second, third. So in the third term you are having 2. That means in the nth term you will be having n minus 1. So number of terms are n. So what is the formula of summation? A r to the power n minus 1 upon r minus 1. This is the formula of summation. What about this one? A plus AR square in dash 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 till infinity. The formula will be A upon 1 minus r. Considering that your r is less than 1. Your r is less than 1. Let us say r is 1 by 2 with power n divided by 1 by 2 minus 1. Now if this goes to infinity, so 1 by 2 to the power infinity, what that would be? 0, right? Because 1 by 2 into 1 by 2, in that manner it will keep on increasing. So this value will be very higher. So 1 by very high value, that would be equals to 0. So this value will be 0. So what will be the answer? This value will be 0. A minus 1 divided by 1 by 2 minus 1. So you can interchange it. A upon 1 minus 1 by 2. So you can say A upon 1 minus r. The value of r was 1 by 2 only. So this is the formula we get. A upon 1 minus r. Okay. You can apply this formula here. What is the value of r? Value of r is e to the power minus 1. Value of r is e to the power minus 1. So A upon 1 minus r. So that would be e upon e minus 1. So that's the answer. Well and good. Okay. So this was the mathematics that we wanted to show because it will be used. But I hope you already know it. Let's go to the orthogonality. So in continuous time signal, what did we do? Minus infinity to infinity. x1t was conjugated with x2t. That would be equals to 0 if it was aperiodic, right? Or you can say the otherwise as well, that you take the conjugate of x1t and multiply with x2t. Certainly there will be dot dt. Here what will happen for aperiodic? N goes from minus infinity to infinity. x1n conjugated multiply with conjugate of x to n. That would be equals to 0 minus infinity to infinity x1 conjugate n multiply with x to n, right? What about periodic? In periodic for continuous time, what we used to do? For one time period, you will do the same thing, right? And opposite as well, for one time period, opposite as well. So here what you are going to do? Again for one time period, you will do the same thing. x1 n dot conjugate x to n for one time period x1 conjugate n dot x to n. Okay then, so these are the formula. Now let's check out this question. Now if this question was for continuous time, let's just say here sin pi by 2t was written and sin 3 pi by 2t was written, then you would say that these are the different frequencies, so they are certainly orthogonal. But it doesn't go like that in our discrete time. We need to check. So first we will talk about the time period. What is the time period for this one? 2 pi divided by pi by 2, it would be 4, n naught 1 I am calling it. What about this n naught 2? So here 2 pi divided by 3 pi by 2, that would be 4 by 3, and 3 can cancel out. So here also the time period is 4. So LCM of both of them would be 4 only. So when I check the orthogonality, here I will put n equals to 0 to, what do you think what I will put? 0 to 3 or 0 to 4? I need to take 4 samples, right? If my periodicity is 4, here the LCM of both of them is coming out to be 4. So I need to take 4 samples. If I need to take 4 samples, so I need to go from 0 to 3, no? First sample will be n equals to 0, second sample, third sample, and fourth sample. So here I will put 0 to 3. Are you getting this point? Right? Yeah, one more thing. The time period of x1 n dot x2 n is 4. Is that statement correct? No. Look what I am saying. What is this? What I am saying is that when we study about orthogonality, so here I told you that we need to put n naught. And how do we calculate this n naught? We will take LCM of these two. It doesn't mean that time period of x1 n dot x2 n is n naught. Are you getting this point? If I ask you the time period of, you need to find n naught of sin pi by 2n dot sin 3 pi by 2n. So will you say I will get 4 here, here also I will get 4, then LCM n naught 1, n naught 2, then LCM would be 4. Is that correct? No. The formula is for addition, not for multiplication. So for that you need to multiply and divide by 2. Multiply and divide by 2. This is what you need to do. So from here what you will get? 2 sin A sin B, that is cos A minus B cos A plus B. Cos A minus B minus cos A plus B. So cos pi n, is there any exception? 0 minus 1, 0 minus 1. N equals to 0 you put, cos 0 is 1. N equals to 1 you put, cos pi is minus 1. So there is no exception. The periodicity is 2. Here the periodicity is 1 only. Right? So now you take the LCM. 2, 1. So here actual, if in the examination I asked you the time period of this particular signal, then answer would have been 2. But when you check the orthogonality, at that time if you need to put the value here, you can put n naught equals to 4. Are you getting this point? Just after taking the LCM. Same thing we were doing in continuous time as well. The formula is not for multiplication, the formula is for addition. But when you check the orthogonality, at that time you can put here n equals to 0 to 3. That means you put n naught equals to 4 here. If I tell you the exact method, then exact method is this. First you calculate this particular value and then you put the n naught value here. Actually n naught value should be put 2 here. N naught value should be put 2 here. But even if you put the 4 n naught value, the answer would be correct only. Even if you put the value to be 6, then also the answer would be correct. Even if you put the value to be 8, then also answer would be the same only. Answer will come out to be the same. If it is coming 0, then it will come 0. If it is coming non-zero, then it will come non-zero only. So that's why I never ask first you do x1 n dot x2 n, then you calculate the time period like this, and then you put it here. No. Ideally, we should do this method. First I calculate the time period like this, and then I should put here. But why should we care this much? only calculate this one, and then take the LCM and then put the value here. You will get the same answer, that's for sure. Okay, and we will talk more about this when we study Fourier series. So there I will tell you that the LCM that you are calculating, this LCM, that will be the largest possible value. Here we are calculating LCM, no? So this is the largest possible value actually. And when you calculate HCF, you get the least possible value. Basically 4, let's just say here there was 4 and here by any chance it was 6. N01 value was 4 and N02 value was 6. Then if you calculate the LCM, what will be the LCM? 12. So there is no chance that LCM would be lesser than 4 or 6. Are you getting this point? Right? And if you calculate the HCF would be 2. So there is no chance that your HCF would be greater than 4 or 6. So this will give you the largest possible value, this will give you the smallest possible value. So this comes for the frequency and this comes for the time period. So we will relate all these things when we study Fourier series. Okay, why I am teaching all these things? When we study Fourier series, all these things will be related. Okay. So as of now, the thing is, if they ask you in the examination hall x12.x2n, then this will be the time period. But if you are checking the orthogonality, either you take it from 0 to, either you take it for the window of 2 or you take it for the window of 4. Both are fine, right? Here what we did, we took the LCM of 4 and 4. That would be 4 only. If it was x1t.x2t, then also you could have calculated N01 and N02, sorry, T01 and T02, you would have taken the LCM and that you would put here, if it was continuous time. But in the examination, if I ask you, what is the time period of x1t.x2t? At that time, you are not going to take the LCM. At that time, you will apply the formula 2 sin A sin B, cos A minus B minus cos A plus B. Then one from here, another from the other side, and then you take the LCM. Because the formula that we have developed, that you find out the time period, individual time period, and then you take the LCM, that formula is applicable only for addition or subtraction. The formula is applicable only for the linear combination, not for the multiplication, right? So yeah, let's get back to our concept. So 0 to 3 I need to calculate sin pi by 2n into sin 3 pi by 2n. Look, here I will have to put the values. I can apply the formula, but that doesn't matter much because the sample size is very less, no? I need to put n equals to 0, n equals to 1, n equals to 2, n equals to 3. So better let's put the value. Put the value of n equals to 0 here. Put the value of n equals to 0 here. Then see what you are getting. Sin 0 and sin 0, that would be 0. Plus. Then put n equals to 1 here. What is sin pi by 2? Sin pi by 2 is 1. What is sin 3 pi by 2? That is minus 1. 1 into minus 1 would be minus 1. Plus. Put n equals to 2 here. Put n equals to 2. Sin pi is 0. 0. Put n equals to 3 here. Sin 3 pi by 2. Sin 9 pi by 2. Sin 9 pi by 2 would be 1. And sin 3 pi by 2 would be minus 1. So it would be minus 1. So what do you think? Is it equals to 0? Absolutely not. So it is not coming out to be 0. But if it was orthogonal, it would have come out to be 0. If it was a continuous time, it would have been orthogonal. But now it is not coming out to be equals to 0. That means it is non-orthogonal. So the conclusion is, in discrete time, there is no certain formula. In discrete time, there is no certain formula. You have to check. In continuous time, what we used to say, different frequencies, job is done. No need to check anything. Right? Phase shift between two of them 90 degree, job is done. No need to check anything. But in discrete time, no matter whatever the signal is given, I will always check in the examination hall. First thing, I will find out the time period like this. I will take the samples from 0 to 3. Then I will multiply and now I will put the values. Because here putting the value will not be a tough task, right? You would need to put only 4 values here. 0, 1, 2, 3. So that will not be a tough task. And you can check in this manner. So always we need to check in discrete time. Either you make the waveform or you check. What do I mean by the waveform? In these kind of questions, you will make the waveform. Say yes or no. Un dot u of minus n. Un, just let me know one thing. First thing is that both are non-periodic. So certainly it will result into something non-periodic only. So which formula I will apply? Complete integration I will do. U of n, not integration, sorry, summation. Dot u of minus n. Can you let me know the value of this thing? This is some function. This is some standard sequence. This will result in some standard sequence. What that standard sequence would be? Try thinking about it. u of n. This is the graph of u of n. U of minus n. This is the graph of u of minus n. You multiply both of them. This is going till infinity, this is going to minus infinity. You multiply both of them, all these will be multiplied with 0. Answer would be 0. All these will be multiplied with 0. Answer would be 0. This is 1, this is 1. 1 multiplied with 1. What you are getting? 1 only. And what is this? Delta of n. Right? So u of n dot u of minus n. What is that? Delta of n. And you are integrating from minus infinity to infinity. That means what will be the value? Value will be 1. So is it coming out to be 0? No. If it is not coming out to be 0, that means it is non-orthogonal. Here would I write non-orthogonal. Non-orthogonal. Okay. Well and good. Let's check this one. U of n, u of minus n minus 1. What is the graph of u of n? And what is the graph of u of minus n minus 1? Here there is no impulse, or you can say there is no sample at n equals to 0. So n equals to 0 will be multiplied with 0. This will also 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 be multiplied with 0. So everything will be multiplied with 0, 0, 0, 0 only. And what you will get? 0. Right? N equals to minus infinity to infinity. U of n dot u of minus n minus 1. What you will get? Multiplication of these two is 0 only. So answer would be 0 only. N equals to minus infinity to infinity, 0. You keep on adding 0 from infinity to minus infinity. Anything addition with 0 would be 0 only. 0, 0, 0, 0, 0. If you are adding 0, answer would be 0. So that means yes, they are orthogonal. Although the thing is, we are never going to use the concept of orthogonality for solving the problems. What I am saying? For solving the problems, you are never going to use the concept of orthogonality. Because in discrete time, the best possible way of solving a particular problem is put the values. That's it. Unless your sample size is becoming very larger. If number of samples are coming 20 or 24, then you might need to apply the formula. You need to trust on the formula. Otherwise, if it is coming, if the sample size is coming on the lower side only, like n equals to 2, 4, 5, then you put the values. Okay. Let's start with the energy. So these examples are more than enough. Okay, I guess no one will ask you much questions from this particular topic in the examination. Okay, so these are enough. Okay, so no need to worry about that. Let's get started with energy. So what was the formula of energy in a continuous time? Right. So similarly here, what do you think? How I should write down? First you take mode of xn, then do the square, and the value of n should go from minus infinity to infinity. And this will work for both whether it is continuous time or discrete time, right? So what do you think? What is this? This is a finite duration signal, right? Minus 1 to 1, 0, 4. That means it is going from, this is your n equals to 0, this would be your n equals to minus 1, this would be 1, 2, 3. So it exists from minus 1 to 3 only. After that, it is all 0. So this is a finite duration signal. So what do you think? What will be its energy? What you need to do? Take mode of xn square. Mode of xn square. What that would be? What is the square of minus 1? That is 1. What is the square of 2? 4. What is the square of 1? 1. What is the square of 0? 0. What is the square of 4? 16. And what you need to do now? You need to do the addition. So 1 plus 4 plus 1 plus 0 plus 16, that is equals to 22. Okay, did the square 1, 4, 1, 16. That's it. 22 is the answer. Joule, obviously, Joule, 22 Joule. What about this? This is also finite duration signal only. Although this will go from minus infinity to infinity. But what we have done, we have multiplied with u of n minus u of n plus 3. Or better put here u of n minus 3. So u of n minus u of n minus 3. So what will be the graph of u of n? Let's make it fair. what will be the graph of this particular value that I am asking. So how will you make the graph? Just 1 second guys, charger is on, still your screen is lagging. So u of n, first there is u of n, right? First there is u of n. So u of n is there, but at 3 what will happen? This is n equals to 0, n equals to 1, n equals to 2. But after n equals to 3, everything will be getting cancelled. Even n equals to 3 will also be getting cancelled. Because if you draw the graph of u of n minus 3, u of n minus 3 says that at 3 I am having an sequence, right? At 3 you would be having something. 4, in that manner it will keep on going. And u of n says that it will keep on going till infinity. So this is 3 for u of n, and this is 3 for u of n minus 3. So this and this will get cancelled, all these will be subtracted. So only you will be left with 0, 1, 2 samples. Only you will be left with 2 samples. Sorry, 3 samples. 0, 1 and 2. And this will be multiplied with sinusoid samples. So if I ask you the value of x of 0, what that would be? Sine 0. That value will be 0 only. Because if you put n equals to 0 here, sine 0 multiply with anything. All these are 1 although, but 0 multiply with anything would be 0 only. Next, x of 1. So sine pi by 2. What is sine pi by 2? That is 1. 1 multiply with 1 will be 1. X of 2. Sine pi, that would be 0 only. 0 multiply with anything would be 0 only. So only 3 samples I needed. So this is my x of n. My x of n is actually 0, 1, 0. So if I do mod of xn square, what that would be? 0, 1, 0 only. Because 0 square would be 0, 1 square would be 1, 0 square would be 0. So what we are doing? Energy 0 plus 1 plus 0. So energy would be 1 joule. So this was also your finite duration signal only. This was also a finite duration signal, right? You try this question on your own. Is it a finite duration signal? No. But is it vanishing signal? Yes. N equals to 0 you put, n equals to 1 you put, n equals to 2 you put, n equals to 3 you put. It will be a vanishing signal. So you try it on your own, you get the answer. It will be resulting in some GP. We studied this formula, no? GP formula. Where it go? So these formula will be used here. Okay, it will result in some GP. So you try doing it. I will pause the video because the screen is lagging. Okay. Yeah. So did you try this one? What you need to do? Let's check out x of n now. What is x of n? It will start from n equals to 0 only, right? If you put n equals to 0, it will be 1. If you put n equals to 1, it will be 1 by 2. If you put n equals to 2, it would be 1 by 4. If you put n equals to 3, it would be 1 by 8. And in that manner, it will keep on going. So what will be mode of xn square? That would be 1, 1 by 4, 1 by 16. What I am doing? N equals to 2, n equals to 3, n equals to 4. Here n equals to 3 I put, right? 1 by 64. In that manner, it will keep on going. What you need to do? You need to do this thing. Minus infinity to infinity, mode of xn square. N equals to 0 to infinity, mode of xn square. So it will be 1 plus 1 by 4 plus 1 by 16 plus 1 by 64. So if you multiply with 1 by 4, what is the value of r here? Multiply with 1 by 4, multiply with 1 by 4, multiply with 1 by 4. So the value of r is 1 by 4. So what will be the answer? A upon 1 minus r. So the answer would be 4 by 3. Answer would be 4 by 3. That's the answer. In place of 1 by 2, if it was 2 to the power n un, then what would have been the answer? Then the energy would have been infinity, right? Why is that so? Because you would be doing 2, 4, 8 and in that manner. And when you do the square, what will happen? 4, 16, 64. And if you add all of them, 4 plus 16 plus 64, it will go till infinity. So addition would be infinity. So energy would have been infinity. So here the value is less than 1. That's why it was 4 by 3. Otherwise it would have been infinity. Basic mathematics. We are just doing the mathematics here, nothing else. Let's get started with this one. Now it is multiplied with cos pi by 2n as well. So let's see the nature. So let's start putting the values. N equals to 0 if I put. So cos 0 is 1. 1 by 2 to the power 0, that would also be 1. And here not only n equals to 0, I can put minus values as well, right? Because here there is no un, anything like that. So I can put the value minus as well. So what I am going to do is that I will call this as x1n and this as x2n. Separately I will write down the values and then I will multiply both of them. This could be the way, or you can do in one go as well, but I will do it separately. Okay. And can you notice one thing? If you calculate x of minus n here, if I calculate x of minus n, what that would be? 1 by 2 mod of minus n cos of minus pi by 2n. Here cos has the ability of eating up the negative sign. Mod has the ability of eating up the negative sign. So what you will get? Negative sign will be eaten up. So it is equals to x of n only. X of minus n is equals to x of n. What does that mean? It is an even signal. Although we haven't studied it in discrete time, but it would be same. So it is an even signal. If it is an even signal, so whatever the value you are getting at positive values, the same value you will be getting at negative as well. No? At n equals to 1, whatever the value I get, the same value I will get at n equals to minus 1. At n equals to 2, whatever the value I get, the same I will get at n equals to minus 2. N equals to 3, the same at n equals to minus 3. So I will check only on the positive side. Negative side I will get on my own. So what is my x1n? Getting started with 0. 1 to the power 1 by 2 to the power 0, that would be 1. Then 1 by 2. Then 1 by 4. Then 1 by 8. And the same value I will be getting this side as well. Because if I put minus 1, that would be 1 only. If I put minus 2, that would be 2 only. Same value I will be getting this side as well. What about cos? So this was your n equals to 0. So here cos 0 is 1. What is cos pi by 2? That is 0. What is cos 3 pi by 2? Cos pi. Cos pi is minus 1. And what is cos 3 pi by 2? That is 0. I put n equals to 0, cos 0 is 1. I put n equals to 1, cos pi by 2 is 0. I put n equals to 2, cos pi is minus 1. I put n equals to 3, cos 3 pi by 2 is 0. I put n equals to 4. N equals to 4 I will put, that would be cos 2 pi. Then again I will get 1. So in that manner it will keep on repeating. Because here what is the periodicity? Periodicity is 4 here. So in 4 it will keep on repeating. 1 0 minus 1 0, 1 0 minus 1 0. And same thing will be happening here as well. 0. Here 0 you are getting, then this would be minus 1, this would be 0. So let's write it down. 0, minus 1, and then 0. 0 minus 1 0 1, 0 minus 1 0 1, in that manner. Yeah. So if I multiply both of them, what would be my x of n? So whatever I am getting here, I don't care. 1 by 8 multiply with 0, minus 1 by 4. 1 by 2 multiply with 0, 1 multiply with 1, this is 0. Then minus 1 by 4, then again 0. Next values also I need to check, because here I am not able to comment actually what will be happening. I am not able to comment much. Next values also I need to check. A few more values I will check here. So if I check a few more values, so let's check here. So what I will be getting, 1 2 3 4, 2 to the power 4 16, then 32. And if I check here, that would be 1 0. So next value I am getting, that is 1 by 16 here, 1 by 16. So in that manner it is going. Basically here this was your minus 1 by 4, then 1 by 8 will be multiplied with 0, then 1 by 16 will be multiplied with 1, that would be 1 by 16. So in that manner we are getting. So if I do mod of x n square, what I will be getting? 0 1 by 16 plus 0 1 0 1 by 16, then 1 by 16 square, right? 1 by 4 square is 1 by 16. Here 1 by 16 I will be getting, that would be 1 by 16 square. Here what I will be getting? 1 by 64. And that will be multiplied with 0 minus 1 0 1 0 minus 1. This will be multiplied with minus 1. So here the next number would have been minus 1 by 64, right? So 0, and then this would have been the next number. So here what we would have done, 1 by 64 square. And can it be written as 1 by 16 cube? 1 by 64 square. That means 1 by 64 into 64. 16 into 4, 16 into 4. So 1 by 16 cube. So it can be written as 1 by 16 cube. So now you are able to understand what is actually happening here. So this is your 1 by 16 cube. So a pattern you are getting. Always you will get some pattern. Are you understanding this point? So whatever that is happening for n less than 0, the same thing is happening for n greater than 0 as well. Whatever that is happening for n less than 0, the same thing is happening for n greater than 0 as well. So let's add a page. Here if I need to calculate the energy, that would be n equals to minus infinity to infinity mod of xn square. Can I write it down in this manner? Minus 1 to minus infinity mod of xn square plus 1 to infinity mod of xn square plus mod of x of 0 square. Is that correct? Minus 1 to infinity, 1 to infinity, and then mod of x0 square. This value and this value both will be same. Say yes or no. Whatever the value you get from 1 to infinity, the same value you will get from minus 1 to infinity. Only the 0 value, whatever the value that you are having at 0, this value, that is 1, that will remain there as it is, right? Otherwise, whatever that you are getting here, 0, 1 by 16, 0, 1 by 16 square, 0, 1 by 16 cube, the same you will be getting here as well. 0, 1 by 16, 0, 1 by 16 square, 0, 1 by 16 cube. Okay. So these two will be same. So I can write down in this manner, 1 to infinity mod of x1 square plus x of 0 square. 2 into start 1 by 16 plus 1 by 16 square plus 1 by 16 cube plus mod of x of 0, that is 1 only, so it would be 1. So 2 into a upon 1 minus r plus 1. So what that would be? 16 by 15. 2 into 16 by 15 plus 1. So from here what we are getting? Energy 32 by 15 plus 1. 3.13 joule. So did you understand the process? It will not take much time. Here it is taking much time, but in the examination hall it might not take that much time to you. What you need to do? First you will see that there is symmetric for n greater than 0 and for n less than 0. So now I need to calculate only for n greater than 0. The same will be happening for n less than 0 as well. So only for n greater than 0 I checked. Then I put down the values, n equals to 0, n equals to 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16, 1 by 32. And then I just broke down into two functions because it would be easier for me. So I broke down into two functions, then I got to know that a cos value will be repeating. So 1 0 minus 1 0, 1 0 minus 1 0, same will be happening towards the other side as well. Then I multiplied. So 1 minus 1 by 4, then I will be getting 1 by 16, then I will be getting 1 by 64. So everything is being multiplied with 4 and 4. But when I do the square, everything will be multiplied with 16. So 1 by 16, 1 by 16 cube, 1 by 16, 1 by 16, 1 by 16 square, 1 by 16 cube. So same thing is happening for n less than 0 as well. So double of this we will be getting. So double of this we will be getting, and what was there at n equals to 0? That was 1. So 1 I will be adding up. So this would be the answer. Okay. Now linear combination. If there is linear combination of two signals, so the same thing will be happening. Energy of xn. What do you think? What will be the answer? Energy of xn. That would be energy of x1 n plus energy of x2 n plus summation minus infinity to infinity x1 n dot x2 conjugate n plus summation minus infinity to infinity x1 conjugate n dot x2 n. Say yes or no. And now if x1 n and x2 n are orthogonal, if x1n and x2n are orthogonal, then energy of xn would be equals to energy of x1n plus energy of x2n. So here the main point is I will not put efforts in analyzing whether they are orthogonal or not. What I mean to say, if I can directly see just by looking at the expression, if I can directly see that they are orthogonal, then it is fine. Then I can apply this formula. Otherwise, I will do the same thing. N equals to 0, n equals to 1, n equals to 2, n equals to 3, n equals to minus 1, n equals to minus 2, n equals to minus 3. In that manner, I will get a pattern and calculate the energy the way I was doing here. So, what is the difference? Like in continuous time, we were putting the efforts that if it is orthogonal, it is easy for me. But in discrete time, this is not what I'm gonna do. If I look at this expression, just by looking at this expression, I can get to know that certainly it is orthogonal, 100%. Why is that so? Because this signal will be non-zero for n greater than 0, n greater than or equals to 0. And this will be non-zero for n less than 0. Right? This will be non-zero for n greater than or equals to 0, and this will be non-zero for n less than 0. And if this signal and this signal is multiplied, this and this is multiplied, certainly it will result in 0 only. Because this is existing, this is non-zero only for n less than 0, and this is non-zero for n greater than 0. That means this will be completely 0 for n less than 0. So 0 will be multiplied with anything will be 0 only, and here also 0 will be multiplied with anything would be 0 only. So just by looking at this particular expression, I can get to know that both are orthogonal to each other, that's for sure. So I can separately calculate the energy of this one, then I can separately calculate the energy of this one, and then add them up. Or what I would have done, I would have simply started finding x of n. So you try finding x of n. I just need 1 minute break. You try finding x of n. Yeah, so let's start finding by x of n. Put n equals to 0, e to the power 0 would be 1. Here if I put n equals to 0, this will exist for n less than 0 only. So no need to look at this. If I am finding out the values for n greater than 0, then I don't even need to look here. Right? So if I put n equals to 0, it would be 1. After that, I put n equals to 1, it would be e to the power minus 1. Because at n equals to 1, this will not even exist. This will be 0 only. N equals to 2, this would be e to the power minus 2. This would be 0. E to the power minus 2 plus 0 would be e to the power minus 2 only. Then e to the power minus 3. In that manner, it will go. And for n less than 0, that means at n equals to minus 1. If I put n equals to minus 1, this will be 0. Because u of minus 1 is 0. But here if I put u of minus 1, that would become u of 0. That would be 1 only. So this would become e to the power minus 1. This would become e to the power minus 2. And in that manner, it will keep on going. More values you can write, e to the power minus 2, e to the power minus 3, in that manner. What do you see? Whatever that is happening here, the same is happening here, right? I can do mod of xn square now. So square if I do 1, right? So double of this, whatever that will get me here, the same I will get here as well. So double of this. So what will be the energy? Energy will be 2 times of e to the power minus 2 plus e to the power minus 4 plus e to the power minus 6. In that manner, I will keep on adding plus 1, 1 plus 1. A upon 1 minus r plus 1. So what you are getting? 2 e to the power minus 2 plus 1. So you can solve this whatever the answer you get. So let me check the calculation if I have done everything correct. N equals to 0, then I put n equals to 1, 2, then I will put n equals to minus 1, minus 2, and then I take the square, n equals to minus 2, minus 4, minus 6, and then a upon 1 minus r. For this one it is a upon 1 minus r, a upon 1 minus r. Okay, then 2 upon e to the power 2 minus 1, 2 upon e to the power 2 minus 1, then plus 1. Again solve it further. Upon e to the power 2 minus 1. So what I am getting? E to the power 2 plus 1 divided by e to the power 2 minus 1. So that's the answer. Okay. So no need to put effort just for getting to know that whether they are orthogonal or not. Are you getting this point? Just try finding x of n and then solve. 100% of the problem will be solved in the examination hall from discrete time if you just try finding x of n. That's it. Here also I will not put any effort to get to know whether they are orthogonal or not. Only task I will do is that I will find x of n. So this will exist for n greater than or equals to 0 and this will exist for n less than equals to 0, right? That is the difference here. So what is x of n? I will start with n equals to 0. So if I put n equals to 0, this is also non-zero, this will also be non-zero. So at n equals to 0, this will be e to the power 0, 1. This will also be e to the power 0, 1. So at n equals to 0, I will be getting the value 2. Then at n equals to 1, this will be non-zero, but this will be 0 at n equals to 1. At n equals to 1, this will be 0, but this will be non-zero. So e to the power minus 1, then e to the power minus 2, then e to the power minus 3. In that manner, it will keep on going. And for n less than 0, e to the power minus 1, e to the power minus 2, e to the power minus 3. X of n, e to the power minus 6, e to the power minus 4, e to the power minus 2, 4, e to the power minus 2, e to the power minus 4, e to the power minus 6. This is your 4. So what I will do? The same thing. Have I calculated this particular thing? Yes, I have already calculated. So energy would be 2 into e to the power minus 2 upon 1 minus e to the power minus 2. How did I write it down? Because I know that this summation will give you 2 into e to the power minus 2 divided by 1 minus e to the power minus 2 plus 4. Right? Here it would be 4. Previously it was 1 only. So now I can solve it. What I will be getting? 2 upon e to the power 2 minus 1 plus 4. 2 plus 4 e to the power 2 minus 4 divided by e to the power 2 minus 1. So 4 e to the power 2 minus 2 divided by e to the power 2 minus 1. So this is the answer. Okay, calculation you can do. From here only I can calculate the final answer. Just I will put in calculator, I will get the final answer. Or 4 e to the power 2 minus 4. So 4 e to the power 2 minus 2 divided by e to the power 2 minus 1. Okay, well and good. Calculate the energy of x of n equals to u of n. Is this unbounded signal? No, this is not unbounded, right? At infinity, it is never going towards infinity, it will always be 1. Is this finite duration? No, this is not finite duration. Is this vanishing or non-vanishing? This is non-vanishing. So what do you think, what should be the energy? It will keep on adding up, no? 1 plus 1 plus 1 plus 1, it will be adding up till infinity. What I mean to say, what is my x of n? It will start from n equals to 0 only. 1, 1, 1, 1. It will keep on adding up like that. And if I do mod of xn square, it would be same only. Mod of xn square would be same, right? 1, 1, 1, 1, 1, 1. And if I calculate the energy, that means I just need to add 1 plus 1 plus 1 plus 1. How many times? Infinite times. Infinite times. So 1 is added infinite times. What will be the answer? Infinity only. So what will be the energy? Infinity. Did you expect the same? Yes. Since it was non-vanishing bounded signal, it was a non-vanishing signal and we expected the same thing. It was not finite duration signal. So yeah, we expected the energy to be infinity only. So in that manner, we need to calculate the energy for discrete time. Did you understand the conclusion here? No matter whatever the signal is there, my first target would be that I try finding x of n, I will get something there, I will get some pattern there, and then I just have to apply my GP. And if I get the GP, I will get the final answer as well. Okay. I can write down more things. If I ask x of n is equals to e to the power n un. So what you will do here? This is an unbounded signal because e to the power infinity will be infinity only. So what is happening here? Your x of n, what that would be? Put e to the power 0, that would be 1. Then put 1 e square, e cube. In that manner it will keep on going. So what will be your mode of xn square? So value will keep on rising. E square, e to the power 4, e to the power 6. In that manner till infinity it will keep on rising. And if I add them up, 1 plus e square, e to the power 4. So here what is the value of r? value of r is e square, which is greater than 1. So if I add all of them, so value will keep on adding and final answer would be infinity. Okay. So conclusion is same as continuous time. The conclusion is same as continuous time, but the method of calculating the energy would be different. You just need to find out x of n and then you calculate the energy, right? Even, odd, conjugate symmetry, conjugate anti-symmetry, even signal, what do you think what should happen? Did to same as continuous time. Odd, x of minus n, it should have the ability of taking out the negative sign. Conjugate symmetry, x of minus n, then take the conjugate, it should be equals to x of n. And conjugate anti-symmetry, negative sign should be coming out, right? If x of n is an odd sequence, find out the value of x of 0. So x of n is an odd sequence, should be equals to this. I put n equals to 0. So x of 0 would be equals to minus x of 0. That means 2x of 0, this I am taking here, should be equals to 0. That means x of 0 should be equals to 0. So if you need an odd sequence 100%, n equals to 0 should be 0 only. What I mean to say is that if you see these kind of signals 3, 2, 4, 1 and then minus 2, minus 4, minus 1. If I look at this particular signal, what it feels like, okay, here I need to put n equals to 0. This is your n equals to 0. If I look at this particular signal, what does it feel like? Whatever that is there at n equals to 1, negative of that is there at n equals to minus 1. Whatever that is there at n equals to 2, negative of it at n equals to minus 2. Whatever that is there at n equals to 3, negative of this is at n equals to minus 3. So it feels like that they are negative to each other, right? This is what it feels like. But it will not be an odd sequence because this value is not equals to 0. So for odd sequence, this value has to be equals to 0. Are you getting this point? For odd sequence, this value has to be equals to 0. Then only you will call it odd, because this condition I need to satisfy. Otherwise, you cannot call it odd. So let me know what kind of sequence is that. This is an even sequence. For even sequence, there is no condition, right? Let's check out the same for even sequence. For even sequence, so for even sequence, x of minus n should be equals to x of n. If I put n equals to 0 here, x of minus 0 should be equals to x of 0. So x of 0 should be equals to x of 0. That means any random value. If x of 0 is 3, 3 equals to 3. X of 0 is 2, 2 equals to 2. X of 0 is minus 1, minus 1 equals to minus 1. X of 0 is 0, 0 equals to 0. So any random value will work here, right? So yeah, here you can see that whatever that is happening for n equals to greater than 0, the same is happening for n less than 0 as well. So this is an even sequence. Is that the odd sequence? No, this is not an odd sequence. This is neither even nor odd. A very important thing, right? It may feel like that, sir, 3 minus 3, 2 minus 2, 1 minus 1, but no, here it should be 0. So this is the problem here. This thing is the problem. So it feels like that it is odd, but it is neither even nor odd. Okay, are you getting this point? So this was the important point in our odd sequence. What about this one? 3 minus 3, 2 minus 2, 1 minus 1, and here you are having 0. So yeah, certainly this is an odd sequence. So have you understood the point? The point is, for odd sequence, x of 0 should be equals to 0. Let's answer all these statements. There is one more statement. 4 statements are there. What do you think which old statement would be correct? This is a MSQ. So first I am saying that x of n is a convergent sequence. What is the meaning of convergent sequence? This you will study in mathematics, but here only I am telling that if you do the complete addition, then it should be coming out to be finite. Are you getting this point? If you do the addition of x of n from minus infinity to infinity, it should be finite. This is the meaning of convergent sequence. Okay, so it is a convergent sequence. This is what they have written. Now, which of the following statements are true? N equals to minus infinity to infinity, x of n should be equals to 0 to infinity x of n. Is that statement true? Look, if this was the statement, I am talking about A. Minus infinity to infinity integration x of t dt. And if I am saying that it is even, and then I would have written 0 to infinity x of t dt. Yeah, this statement is absolutely true. But is it same for discrete time as well? If you have written down this statement 0 to infinity 2 times, that means you are including 0 twice. Are you understanding this point? What I mean to say, here if I do this thing from minus infinity to infinity x of n, can I write it down in this manner? N equals to minus infinity to minus 1 x of n plus 1 to infinity x of n plus x of 0. Here if I am doing twice, here in this one if I am doing twice, that means x of 0 is being added twice. But that I don't want. X of 0 will be added once only. 3, it will be added twice. 2, 2, 2 and 2, it will be added twice. Are you getting this point? 1 and 1, it will be added twice. But x of 0 should be added only once. But here it is being added twice. And that I don't want. X of 1 will be added twice, yes. X of 2 will be added twice, yes. X of 3 will be added twice, yes. And I am fine with that. But x of 0 should be added only once. So what should be written? Now this thing and this thing will be equal because it is an even sequence. So what I need to do? 2, 1 to infinity x of n plus x of 0. So yeah, this is correct. So this statement is wrong. Okay. So this is the correct statement. Here it was continuous time. Here it was continuous time. So at x equals to 0, you take x equals to 0 minus, you take, it would be the same only. So continuous time this works, but for discrete time, this works. Minus infinity to infinity, x of n is equals to 0 for odd sequence. Yeah, this is correct. How it is correct? Let's check out. Statement B. If I had written for continuous time, saying that x of t is odd, it would be equals to 0. Yeah, this was correct. But if I write it down for discrete time, what it would be? Can I break it down in this manner? Minus infinity to minus 1, 1 to infinity x of n plus x of 0. I am saying that x of n is odd. If x of n is odd, this will be equals to 0 only. This would be equals to 0 only. Now whatever that is there from 1 to infinity, negative of that will be there from minus 1 to infinity. Check this example. 3 minus 3, 2 minus 2, 1 minus 1. If you add all of them, 3 minus 3, 0, 2 minus 2, 0, 1 minus 1, 0. So here I can, what I can write, this can be replaced with 1 to infinity x of n plus 1 to infinity x of n. So this and this will be cancelling out to 0 only. So yeah, second statement is true. For an even sequence, x of 0 has to be equals to 0? No. Right? We have checked it out, right? X of 0 could be anything. For an even sequence, this is not a necessary condition. Now this one, if x of n is odd, then from 0 to infinity would be equals to from minus infinity to 0. Yeah, that is correct. Why I can include 0 in both of the sequence? Because I know that n equals to 0 would be 0 only. What this means to say is that for option D, 0 to infinity x of n, for odd sequence they are saying, and minus infinity to 0 x of n. For odd sequence they are saying. So x of 0 plus x of n, x of 1 plus x of 2 dot 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 should be equals to x of 0 plus x of minus 1 plus x of minus 2, and in that manner, but there is a negative sign. Negative sign should also come. So here one thing I already know that this is equals to 0. This is equals to 0. And I know that x of n is equals to minus of x of minus n. X of 2 is equals to minus of x of minus 2. So yeah, both are equal only. Here I wrote down this thing, no, from infinity to minus 1. I could have written from minus infinity to 0 as well, because here x of 0 is equal to 0. So same thing I would have written. So yeah, option D is also correct. So option D is also correct. So here B and D are correct. Well and good. Let's go to this question. Is x of n a odd sequence? X of n is defined in this manner. Okay, x of n is defined in this manner. At n equals to 0. So this is your n equals to 0. For n equals to 1, this is the 1, 1 by 2, 1 by 3, 1 by 4. In that manner it will keep on going. So n equals to minus 1, sorry, n equals to minus 1, this would be minus 1 by 2 minus 1 by 3. Is it a odd sequence? Yes. 1 minus 1, 1 by 2 minus 1 by 2, 1 by 3 minus 1 by 3, 0 0. Is it a odd sequence? Yes. But is that statement true? No. Is this true? Okay, wait a second. This is equals to 0. Is this true? Actually, this should have been the question. Is this true? Because for an odd sequence, you have studied that if you do from minus infinity to infinity, it should be equals to 0. Here you wrote down, sir, minus infinity to infinity, it should be 0. So for an odd sequence, this should be true. But if you go back to this question, what was written here? It is a convergent sequence. Is it a convergent sequence? If you add 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 in that manner, will it go to finite number? No, it is not a GP. This is not a GP. You are not multiplying 1 by 2. You are not multiplying 1 by 2. This is not a GP. Are you getting this point? This is not a GP. So this multiplication will, this addition will be infinity. Now no one will say that, sir, here minus 1, 1 and minus 1 will be getting cancelled out. This will be getting cancelled out. Sorry, minus 1 by 2 and plus 1 by 2, this will be getting cancelled out. Minus 1 by 3 plus 1 by 3, this will be getting cancelled out. No. Here also the addition will go to minus infinity and here addition will go to plus infinity. You cannot say plus infinity minus infinity is equals to 0. No. So that means here addition is divergent. All these things certainly you will learn in mathematics. There is something called p test, 1 by n to the power p. If p is less than or equals to 1, it will be convergent. Sorry, non-convergent, or you can say divergent. So if p is less than or equals to 1, it will be divergent. In first year mathematics, you would have studied these kind of things. In engineering mathematics as well, we will study all these things. But in first year mathematics, do you remember the p test? By integral we used to do, we used to replace this n with x. Okay, even if you haven't studied, no need to worry. In mathematics, you will study that if there is an expression that 1 by n to the power p, and if p is less than or equals to 1, this will be divergent. Or divergent means simply the addition will not be equals to finite number. It would be infinity. Here it is giving infinity, here it is giving minus infinity. So infinity minus infinity, it is again undefined only. So your expression is divergent here. So this statement is not true. Are you getting this point? It is an odd sequence, but odd sequence has to be convergent. It is not convergent, it is divergent. So you cannot say that this statement is true. Okay. So it was a good point here, which you can see. So this is not true. So if I am writing down all these conditions, yeah, this is correct, this is correct. But in the question, it should be mentioned that x of n is a convergent sequence. If it is not mentioned, then the problem doesn't make any sense. It has to be a convergent sequence, then only I will do all these kind of calculation, then only I can do the summation. Otherwise, the summation has no meaning. Okay. So it should be a convergent sequence. Here we go to know that it was not a convergent sequence, it was divergent sequence. Okay. So what I will say, this is a divergent sequence. Although in mathematics all these things will be clear. All these kind of questions, you can call it mathematics question or you can call it signal system questions. In any subject you can put. I will put it more towards mathematics. So because the same thing we will be going to study in engineering mathematics, same D2 thing. Are you getting this point? Okay. Is it a odd sequence? No. Why? 1 minus 1, yes. Minus 2, minus 2, 2, yes. But n equals to 0 is not giving 0. So this is not a odd sequence. Is this a even sequence? Yeah. At n equals to 0, you can have any value. Minus 2, 4, 4, 3, 3. Yes, it is a even sequence. Okay, well and good. Breaking x of n into even and odd part, same thing. X of minus n would be equals to x even of minus n plus x odd of minus n. What this will do? Even part will eat up the negative sign, odd part will take out the negative sign. You can add both of the equations, what you will get? So even part would come out to be x of n plus x of minus n divided by 2. And what about the odd part? Odd part will come out to be x of n minus x of minus n divided by 2. So same was there for continuous time as well. X of t plus x of minus t divided by 2, x of t minus x of minus t divided by 2. Well and good. Which of the following statements are true? If x of n is convergent, it is given. For conjugate symmetry sequence, x of 0 has to be real. For conjugate symmetry. So statement A, conjugate symmetry, x conjugate minus n should be equals to x of n. This is your conjugate symmetry, right? X of 0, put n equals to 0. If a conjugate, this is the conjugate of x of 0 should be equals to x of 0. So yeah, x of 0 has to be real because this is true only for the real number. For real numbers, for real number, let's just take any random example, forget about the statement. Let's take a real number 2. What will be its conjugate? That would be 2 only. Let's take an imaginary number 3j. What will be its conjugate? Minus 3j. Are both of them equal? No. Are both of them equal? Yes. Let's take a complex 2 plus 3j. What will be its conjugate? 2 minus 3j. Are both of them equal? No. So 2 is equals to 2. So x of 0 has to be real. From here what I got to know, if your conjugate is equals to the number, that means it has to be real. Should be real. Or you can write down one statement, for real number x, for real number x, x conjugate is equals to x only. For real number x, x conjugate should be equals to x. So here x conjugate 0 is equals to x of x0, that means x0 has to be real. For second statement B, for conjugate anti-symmetry sequence, x of 0 has to be imaginary. So conjugate anti-symmetry we will check out. X conjugate minus n should be equals to minus x of n. So x conjugate 0, x conjugate 0 should be equals to minus x of 0. Let's add a page. So x conjugate 0 is equals to minus x conjugate 0 is equals to minus x of 0. Now if a number is real, what will be the conjugate? 2. Here what they are saying, this is the number and this is the number conjugate. 2, 2. It should not be equal. It should be equal to the, but there should be negative sign as well, right? If I take 2j, this is a purely imaginary number. What will be its conjugate? Minus 2j. So yes, here if I am putting minus 2j, that would be equals to minus of 2j. Now this is being satisfied. What I am saying, if my number is 2j, if my x of 0 is 2j, my x of 0 is 2j, x of 0 is 2j. If I take conjugate of this, what I will get? Minus 2j. That should be equals to minus 2j only. Yes, it is being equal. So for imaginary it is being satisfied. What about the complex? 2 minus 2j. So is that true? Basically if you take 2 plus 2j and then you equate, first thing is 2 plus 2j and then you take the negative sign here, minus 2 minus 2j. So what you are getting? 2j minus 2. So are both of them equal? No, they are not equal. Both of them are not equal, right? If both of them are not equal, that means this is not true for complex as well. So it is only true for imaginary. But still I am saying that this statement is wrong. Why is that so? I am saying that statement B is wrong. For conjugate anti-symmetry sequence, x of 0 has to be imaginary. You can see it has to be imaginary. But what if the number is 0? If x of 0 is 0? If x of 0 is 0. So what will be the 0 conjugate? What will be the conjugate of 0? That would be 0. That would be equals to minus 0. Yes, 0 is equals to minus 0 because minus 0 is 0 only. So the number could be 0 as well. Here, for conjugate anti-symmetry sequence, x of 0 has to be imaginary or 0. Okay? Has to be imaginary or 0. So this would be the correct statement. This would be the correct statement. So this was true, but this was wrong. Now if I write down for conjugate anti-symmetry sequence, x of 0 has to be imaginary or 0. So yeah, for imaginary it is being satisfied, but it could be 0 as well. Are you getting this point? Okay, well and good. Yeah, so let's see this question now. X1n is given, X2n is given. You need to tell whether they are conjugate symmetry or conjugate anti-symmetry. So let's first talk about X1n. So what I will calculate, X1 conjugate n. First I will calculate X1 conjugate n. So I will go step by step. Okay, so conjugate means plus j will be replaced with minus j. So plus j is being replaced with minus j. And then I need to take the mirror image. So mirror image would be, this comes here, 4 plus j 2.5 minus j2, then minus 4 plus j 2.5. So this is your x conjugate of minus n, and this is your x1n. Are both of them equal? There is no chance that both of them are equal. They are not equal. Let's calculate x1 minus x1n. What will be your minus x1n? So you will multiply with minus sign, that would make 4 plus j 2.5, that would make minus j2, and that would make minus 4 plus j 2.5. Are both of them equal? Yes. So here, from here what you can see, x conjugate of minus n is equals to minus x1n. So that means it is conjugate anti-symmetry, right? So first one is conjugate anti-symmetry. So always go step by step in these kind of problems. In these kind of problems, there is very high chance that you may mess it up in the examination if you are in a hurry, because here a lot of processes are involved. No, first conjugate, then take minus sign, and then compare. So go slowly. Although it is very easy, but go slowly. What about the second one? Second one looks very easy. First, I will calculate x2 conjugate n. That would come out to be, this minus sign will be replaced with a plus sign. So 2.5j, then 2. This would become minus 2.5j. Basically, plus j is replaced with minus j. Then I need to take the mirror image. So this will become minus 2.5j, 2, and 2.5j. What was your x2 of n? x2 of n was the same thing only, minus 2.5j. If you see the expression of x2 of n, this was your x2 of n. x2 of n was the same thing, minus 2.5j, 2, 2.5j, minus 2.5j, 2, and 2.5j. So from here what you understand, that x2 conjugate minus n is coming out to be x2 of n only. Okay. So yeah, that means it is conjugate symmetry. Now in the examination or in some textbook, you can find written like this, x conjugate t is equals to x of minus t. So this is conjugate symmetry. Is this true? But sir, you told that x conjugate minus t is equals to x of t. So both are same thing only, no? Replace minus t with t. Replace minus t with t. What will happen? X conjugate t, and here minus t. It is your conjugate symmetry. Are you getting this point? So minus sign can be taken anywhere. Understandable? Okay. So this was your conjugate symmetry, and this is also your conjugate symmetry. So it can be written in this manner. All these things can be written in this manner. X conjugate n is equals to x of minus n. X conjugate of n, x conjugate of n is equals to minus x of minus n. Although we will remember this one, although we will remember this one, I usually remember this one, x conjugate of minus n is equals to minus x of n. But if I replace minus n with plus n, then what will happen? This plus n will be replaced with minus n. So what I will get? This expression. So any of them could be written. This would be your conjugate symmetry. This would be your conjugate anti-symmetry. Same goes with continuous time as well. X conjugate t is equals to x of minus t. But this is a slightly confusing, right? You may confuse with conjugate symmetry and anti-symmetry. So all the operation conjugate and then taking the minus sign, I do on one particular segment only, and then I equate whether it is equals to x of n or minus x of n. So that is easier to remember. This one is easier to remember. All the operation you do to one particular expression only, and then you take whether it is minus x of n or plus x of n. Are you getting this point? So this is easier to remember actually. That's why I remember in this manner. But other expression can also be written in that manner. Also, it can be written. Okay, so you need to remember both of them. Remember only one, but in the examination, if you need to take two expression, then you can take two expression as well, right? Let's go to next, breaking into complex conjugate symmetry and conjugate symmetry and conjugate anti-symmetry part. So can you do it on your own? Do it on your own first. Do this on your own. So what I will do, I will take the conjugate and take the negative sign. Take the conjugate, take the negative sign. Take the conjugate and take the negative sign. What will be the value of this? Since it is conjugate symmetry, so it would be equals to x conjugate n only. And what about this? Here negative sign will come out. So when you add both of them, what you get? The conjugate symmetry part is xn plus x conjugate minus n divided by 2. This is the this is the conjugate symmetry part. What about the anti-symmetry part? X of n minus x conjugate of minus n divided by 2. Okay, so this is symmetry conjugate, this is conjugate anti-symmetry. If this kind of question is coming, find the conjugate symmetry and anti-symmetry part. Will you be able to do it? Yes. Conjugate symmetry part, what that would be? X of n plus x conjugate of minus n divided by 2. So eventually, and conjugate anti-symmetry. So eventually I need to find out x of x conjugate minus n. So first let's find out x conjugate of n. Go step by step. X conjugate of n, that would be minus 4 plus 5j, 1 minus 2j, and this is 4. Now x conjugate of minus n means, take the mirror image, 4, 1 minus 2j, and minus 4 plus 5j. Now you just need to add both of them. This is equation 1, this is equation 2. So add both of them, minus 4 minus 5j plus 4 divided by 2. So what you will be getting? 4 and this will be getting cancelled, minus 2.5j. 2 by 2, 1, right? And here what you will be getting? 2.5j. So although the same expression we saw here as well, although it was 2, you can take any number. Here it is coming out to be 1, right? And what about conjugate anti-symmetry part? For that, what you need to do? You need to subtract, right? Conjugate anti-symmetry part. From this to this, I need to subtract. So minus 4 minus 2.5j. Minus 2j. 4 plus 2.5j. It is not 2j, it is 2.5j. If you subtract from this to this, so minus 8 minus 5j divided by 2, so minus 4 minus 2.5j, minus 4 minus 2.5j. Then 1 plus 2j, 1 minus 1 plus 2j, so 4j divided by 2, that would be 1 plus 2j minus 1 plus, so it would be plus 2j. I am messing up the calculation. In the calculation, what I need to do? First, I need to subtract these two. So minus 8 minus 5j divided by 2. So minus 4 minus 2.5j. Then 1 plus 2j minus 1 minus 2j. So it would become 4j divided by 2. 2j. And what about this one? 8 minus 5j. That would be 4 minus 2.5j. Right? So we had the same expression here. Minus 4 minus 2.5j, 2j, 4 minus 2.5j. 4 minus 2.5j. Okay. So these are the conjugate symmetry and anti-symmetry part. So that's it about even odd conjugate symmetry and conjugate anti-symmetry as well. So very easy, like there is very rare chance that any question would be asked from it, but you just need to have like these statement wise question can be asked. So there you need to have your good amount of patience, you need to have the ability of solving these kind of problems. I'm not saying that you mug it up, that for conjugate symmetry sequence x of 0 has to be real. Don't mug it up. Derive it there, no? Just simply derive it there. Yes, it has to be 0. It has to be real. And for the next one, it has to be 0 or imaginary. So this will work for imaginary or 0. So just derive it there. just derive. Okay, same goes for these questions as well. Just derive all these things. Derive all these things there. Okay, well and good. Yeah, so let's meet again. We will meet again after a break, and in that we will study about periodicity and average. So that will be the final topic of our this particular chapter. Thank you. Yeah, welcome back. So we need to get started with average. So how do we find out the average of a particular signal in continuous time? So there were two formula for periodic and for aperiodic. So for periodic, what we used to do, we used to integrate over a time period, and then we used to divide by that time period. So that was the formula. So here also the same thing. We will integrate over a time period and then divide by that time period. Not integrate, sorry. We will take the summation over a time period and then divide by that time period. Okay. For aperiodic, what was the formula? You would take a window of minus t by 2 to t by 2 and then you will integrate it and then you will divide by that window, but considering the fact that limit t will be tending to infinity. So here also you will do the same thing. You will take a window, but here I will not take the window from minus n by 2 to n by 2. I will take the window from minus n to n. Here also you could have taken the window from minus t to t. You could have taken the window from minus t to t. Then you would divide by 2t. So here I am taking the window from minus n to n. Now take your time and let me know what I will divide with. I will divide with 2n or 2n plus 1. Let us say I take a window from minus 2 to 2. So how many samples I am taking? Minus 2, minus 1, 0, 1 and 2. 5 samples I am taking. So minus 2 to 2 I am taking the window. So I am dividing by 2n plus 1, no? So I need to divide by 2n plus 1, considering the fact that n will be tending to infinity. Okay, so you need to divide by the number of samples. So if you are taking from minus n to n, so number of samples are 2n plus 1, right? That thing you need to take care. Okay. So now this is a aperiodic signal. You are taking the samples from minus n to n and you are calculating the average value of un. So taking the sample from minus n to n. So what I need to calculate? Average. So limit n tending to infinity 1 by 2n plus 1 n equals to minus n to n, and here x of n I need to write down, that is un. So un is existing from 0 to n only, right? From minus n to 1, from minus n to minus 1 it was 0. So it is existing from 0 to n. It is non-zero from 0 to n only. So what I can do? 2n plus 1, n goes from 0 to n un, and the value will be 1 only. The value will be 1. Are you getting this point? Un will be always 1, no? For 0 to n it would be 1. So limit n tending to infinity 1 by 2n plus 1. You guys need to let me know the value of this particular thing. B minus a plus 1, n minus 0 plus 1. So what that would be? N plus 1. So this value will be, what will be the value of this? That would be n plus 1. N plus 1. Right? Now n is tending to infinity. That means in 2n plus 1, n is tending to infinity. That means this value will be very larger than 1. Right? N tending to infinity means 2 into infinity. Infinity plus 1. It would be very larger than 1. So 1 can be ignored. Same goes here as well. N will be very larger than 1. So 1 can be ignored. So if I am putting n tending to infinity, if I am putting n tending to infinity, so if n tends to infinity, what happens? This 1 can be ignored, and here also this 1 can be ignored. Now n and n will get cancelled out. What I am left with? 1 by 2. So here what is the answer? Average value is coming out to be 1 by 2. How did I solve the limit? Did you understand? Did you understand how do I solve the limit? N tending to infinity. So n is very larger than 1, 1 is ignored, here also 1 is ignored, and get cancelled out. What is left? 1 by 2. So what is the average value of un? That is 1 by 2. Okay. What about this one? Don't apply any formula. This is periodic, you already know. Just calculate the samples. If it is periodic, periodic with periodicity of 2. Sorry, periodicity of 4. 2 pi divided by 2, periodicity of 4. So calculate the samples. So some negative samples would be there, that I don't care. I will calculate the sample from 0. So at n equals to 0, 0 would come. At n equals to 1, sin pi by 2, 1. Again 0. Then minus a. So 0 a, 0 minus a. Then again 0 a, 0 minus a. So it is periodic like this. Always, whether it is energy, average, power, anything you are calculating, I always say when it is a discrete time signal, try calculating the sample, because that would be the best possible way and there is zero chance of error. So now you got to know that it is a periodic signal. What you need to do now? Average you need to find. So you will divide by the periodicity, that is 1 by 4. You will take the sample from where to where you will take the sample. For one time window you need to take the sample. So n equals to 0 and this is n equals to 3. So you will take the sample from n equals to 0. 0 to 3, number of samples would be 4. 0 to 3, number of samples would be 4. So 1 by 4. Then 0 to 3, all the sample I need to take. 0 plus a plus 0 minus a. So a minus a would be 0 only. So what is the average coming out to be? 0. In continuous time as well, the average was 0. In your discrete time as well, the sinusoid average is 0. But what if I take the mode? The same signal is there, but I am taking the mode. So what do you think, what will be your x of n? X of n, negative values would be there, then a, then 0. This minus a would become plus a. 0, a, 0, a. So periodicity which was previously 4, now it has become 2. So periodicity has become 2. So from here to here, where you will take? 0 to 1 you will take, and x of n. So periodicity is 2 and 0 to 1 I need to take it. So 0 plus a. At 0 you are having value 0, at 1 you are having the value a. So what is the answer? A by 2. So what is the average here? Average here is a by 2. Right? Okay, so very simple. Just to calculate the samples. Here also, will you do anything like apply formula, that this formula, that formula? Don't put needless pressure. Just calculate the samples. Just find out the value of x of n. One thing you know that u of n is connected here. That means it will be starting from n equals to 0 only. So if I put n equals to 0, what will be the value? 3. If I put n equals to 1, if I put n equals to 2, if I put n equals to 3, in that manner I will keep on going. Right? So this is my x of n. Is it periodic or aperiodic? This is your aperiodic. Directly I can see it is aperiodic. What I need to do? I need to take the sample. First let's calculate the average. Both they are asking the energy as well, average as well. Energy although we have already calculated, but yeah, first let's calculate average. So what I will do? I will take the samples from minus n to n. Minus n to n. X of n. And I forgot one thing, that is limit n should be tending to infinity. So this kind of average I am calculating. Although you tell me whether it is an energy signal or power signal, it will be decaying, right? So this is an energy signal, and since it is an energy signal, so energy will be finite. So what does that mean? Power will be 0 and the average will also be 0. So although the answer would be 0, but let's do it. Let's do the calculation, right? So let's do the calculation. Although by directly looking at this, you would get to know that it would be 0 only, because all these we have seen in continuous time, right? So what I need to do? Limit n tending to infinity, 1 by 2n plus 1. So I need to take the sample from 0 to n. So let's start with 0. So 3 to the power minus 1 by 2 plus 3 to the power minus 1, and in that manner I need to take the sample till nth term. So that would be e to the power minus n by 2. Say yes or no. So how many terms these are? N or n plus 1? Look, n equals to 0 you put 3 you get, n equals to 1 you put 3 e to the power minus 1 by 2 you get. This was your n equals to 0. N equals to 2 you get 3 into e to the power minus 1. N equals to capital N you get 3 e to the power minus n by 2. So from 0 to capital N you are calculating the samples. So how many samples are there? N plus 1, no? So these are the n plus 1 terms. N plus 1 terms. And what is the what is being multiplied? E to the power minus 1 by 2. What is the value of r? E to the power minus 1 by 2. Common factor is e to the power minus 1 by 2. And these number of terms are n plus 1, right? So limit n tending to infinity, I will just apply the formula now. That would be a r to the power n. What is r here? R is e to the power minus 1 by 2 r to the power n minus 1 upon r minus 1 upon r minus 1. Now you put n tending to infinity. If you put n tending to infinity here, what this will become? A to the power minus infinity, that would be 0. So this would become 0. So this will be a constant number. If I put n tending to infinity, so this will be a constant number, that is minus 3 divided by some number, that is e to the power minus 1 by 2 minus 1. And then here I need to put n tending to infinity, n tending to infinity. So what will be the answer? 0. In this particular expression, you just need to put n tending to infinity. If you put n tending to infinity, e to the power minus infinity, that is 0, 0 minus 1, and this will be a finite number. This is also a finite number. Just put n tending to infinity here. So what is the answer? 0. So what is the average value that is coming out to be? 0 only. So same concept that goes in your continuous time, the same goes here in discrete time as well. So this is the average. What about the energy? Energy would be finite. So x of n is already there. What will be my mode of x of n? Mode of x of n square. So 3, it would be 9 e to the power minus 1, then square I am doing, so 9 e to the power minus 2, then e to the power minus 3, in that manner it will keep on going. So what will be my energy? Just summation of all these. So 9 into 1 plus e to the power minus 1 plus e to the power minus 2 plus e to the power minus 3, a upon 1 minus r, that is 1 by e. So what will be the answer? 9e upon e minus 1. So energy is coming out to be a finite non-zero number, that is 9e upon e minus 1, but the average is coming out to be 0, and that was expected as well, right? So in that manner we need to solve. Simple mathematics we are doing, nothing else. Average, is it periodic? Absolutely no. It is non-periodic, and it is finite duration as well. So I will take my minus n in a manner that the whole nature is introduced. So I will take from minus n to n. So if I need to calculate the average, so always I know that my limit n will be tending to infinity, although I can predict that what will be my average. If it was continuous time, what would have been the average? 0, and certainly it will come out to be 0 only. And then here I am doing the summation from n equals to minus n to n x of n. So what I will do? Limit n tending to infinity 1 by 2n plus 1. I will do the summation here. Summation I will do 2j minus 3j plus 1 plus 4 minus 2j. So this will be a finite value, right? This will be a finite value. Now you put n tending to infinity here. So 1 to the power infinity, what that would be? 0. So average is coming out to be 0. Right? Very simple. Just add all of these, which will be a finite value, divided by n tending to infinity. So it has to be 0. What about the energy? So mode of xn square. Mode of xn square. First you take the mode of xn. What will be mode of xn? 2j. Mode of 2j. That means amplitude of 2. Amplitude of 2j. That would be 2 only. So this would be 2. Amplitude of minus 3j. That would be 3. Then 1. Then 4. Then 2. Now you take the square. What that would be? 4, 9, 1, 16, 4. And then you need to add them up. So 4 plus 1. So 4 plus 9 plus 1 plus 16 plus 4. So that would be 34 joule. So that would be the energy. And 14 and 34. Yeah, 34 joule. Secondly, you would say that, sir, how did you show this? 2j positive minus 3j negative minus 2j negative 4 positive 1 positive. Look, you cannot say this is a negative number because this is an imaginary number. So negative positive you cannot define. This is just a way of presentation, that if there is a negative sign, so I just showed it in negative y-axis. I could have showed minus 2j upper side. If I am showing minus 2j upper side, then I would show plus 2j downward side. So this is a negative number, you cannot say. But since there is a negative sign, so that's why I just showed it in the negative hand side. Otherwise, I could have showed it positive hand side as well. So this is just a way of representation, and we will study about it more when we study Fourier series, right? Let's see this one. A very random example it is, very random. I don't apply any formula, nothing. Don't go with any formula, just calculate the sample. Like try predicting the periodicity. Try predicting the periodicity. So usually this will give the periodicity of 4, but since there is a mode, divided by 2. What periodicity it will give? 2 pi divided by pi by 3. So usually it should give the periodicity of 6, but since there is a mode, divide by 2. Again I am saying this is very rough method, because in the sinusoid and cosinusoid always there can be exceptions, like this one. What do you think, what is the periodicity here? 1. Although usually it should give 2 and then divided by 2. Again periodicity is 1 only, or you can see that cos pi n, put n equals to 0, cos 0 is 1, n equals to 1 minus 1, then n equals to 1, sorry, n equals to 2, cos 2 pi 1, n equals to 3, cos 3 pi minus 1. So 1 minus 1, 1 minus 1, then there is a mode. So it is actually always 1 only. So this is written 1 to the power n. This is actually 1 to the power n only. This function is 1 to the power n. So yeah, periodicity is 1. So our assumption is the periodicity, this is 3, this is 2. So LCM if I take 2, 3, 1. So assumption is periodicity would come out to be 6. So x of 0 I will calculate 1, 2, 3, 4, 5, 6. This is just a rough assumption. 100% nothing is sure. In discrete time signal, 100% nothing is sure. You should always calculate. It is a very low number, right? 6 is not a very high number. If it is 20, 40 or 10, 15, then I cannot calculate. But my rough assumption is that my periodicity should come out to be roughly around 6 only. So let's calculate. X of 0 you calculate, x of 1 you calculate, 2, 3, 4, 5. Let's start calculating. So x of 0, sin 0 would be 0, cos 0 would be 1, and this would be also 1. So value is 2. X of 1. So sin pi by 2 is 1. Sin pi by 2 is 1. Cos pi by 3, that is 1 by 2 plus, that would be 1 only. So what it is coming out to be 5 by 2. X of 2, sin pi would be 0, cos 2 pi by 3, cos 2 pi by 3, that would be cos pi by 3 only, again 1 by 2, and that is 1 only. So next is 3 by 2. Sin 3 pi by 2, mod sin 3 pi by 2, that would be 1 only, plus, here periodicity was 3, is that correct? Cos pi by 3 and it is having periodicity of 3, is that correct? Because if you put n equals to 0, what you get? 1. Then n equals to 1, what you get? 1 by 2. N equals to 2, what you get? 1 by 2. N equals to 3, you get 1 again. Yeah, periodicity is 3 only. So n equals to 3 I am putting, I will get 1 again. Here cos 3 pi by 2, and here also 1 again. So what I am getting? 3. So kind of that I am predicting that periodicity should go to 6. It might happen. 4, cos 2 pi 0, cos 4 pi by 3, 1 by 2 again, and that is 1 only. So 3 by 2. 5, cos 5 by 2, that would be 1. Here 5 pi by 3, again 1 by 2, and that is 1 only. 5 by 2. What about 6? Now if 6 comes out to be 2, then I would be happy. What was this? X of 0. Sin 0 was 0. It was actually 0 plus 1 plus 1. It was 2. So here sin 3 pi 0. Here what you are putting? 6. Cos 2 pi 1, and that is 1 only. So what it is coming out to be? 2 again. So 2, 5 by 2, 3 by 2, 3, 3 by 2, 5 by 2, then again 2. So this signal is being repeated. 2, 5 by 2, 3 by 2, 3, 3 by 2, 5 by 2, 2, 5 by 2, 3 by 2, 3, 3 by 2, 5 by 2. So more samples you can calculate. X of 7 also you can calculate. In that manner you can also calculate. So what we see, this is being repeated. 2, 5 by 2, 3 by 2, 3, 3 by 2, 5 by 2, 2 again, right? Again from here it is being repeated. What you need to find? You need to find the average. So what is the periodicity? 6, and then you just need to add all of them. So 5 pi by 2 plus 3 pi by 2 plus 3 plus 3 pi by 2 plus 5 pi by 2. 5 3 8, 4 4 8. Okay, 5 plus 3 8, 8 divided by 2 4. Actually I am from Hindi medium. Okay, I am teaching in English, but I have been a student of Hindi medium when I was till class 12th. So 5 3 8, I do the calculation in Hindi only, but you can do it in English. So yeah, 5 plus 3, 8. 8 plus 8, 16. 16 divided by 2, 8. 8, 10, 13. This is coming out to be 13 by 6. So this is the average value. Is that correct? Let's check the calculation again. So 5 plus 3, 8. 8 divided by 2. So 2.5, 1.5, 4. 4, 4, 8, 10, 13 by 6. Okay, so average is 13 by 6. So in that manner you need to proceed. Any example you see, cos 2n. So this is non-periodic, that's for sure. If I calculate by samples, let's try calculating the samples. On negative side as well there could be samples, on positive side as well there could be samples. So I will start with cos 0, n equals to 0, that would be 1. Then n equals to 1, cos 2, n equals to 2, cos 4, n equals to 3, cos 6. Certainly it is not periodic. And for minus n as well, the same values we will get, cos 2, cos 4, in that manner, right? So this is your, this is your x of n. Certainly it is non-periodic. So what I will do, average, limit n tending to infinity. Can you let me know what is the value of cos 4, cos 2, cos 2, cos 4, cos 6? I don't know the values, but one thing I'm pretty sure that all these values will be somewhere between minus 1 to 1. Like none of them will go to infinity or minus infinity. There is nothing that will make it unbounded signal. Is that true? Do you agree to this point? There is nothing that will make it unbounded. None of the values will go to minus infinity or plus infinity. It will be somewhere between minus 1 to 1. So if I calculate from minus n to n, cos 2n. So I don't know how many samples I am taking. I am taking the samples, okay, 1 second. I forgot the formula here, 1 by 2n plus 1. So I am taking some samples from minus n to n, but I am pretty sure that whatever the value that I will be adding, that will be a finite value. Are you understanding this point or not? You are adding the values between minus 1 to 1. The addition can never go to infinity because the values will be lesser than minus 1, no, like 1 by 2, 1 by 3. So all these values you will be adding between minus 1 to 1. So it will be a finite number. And then you put n tending to infinity. What will be the answer? 0. Did you understand this point? You are taking the sample between minus n, here your minus n is there, here your plus n is there. You take the sample between minus n to n. You add these values. The values are lesser than 1 or greater than minus 1. You can say it is between minus 1 to 1, or it could be equal to minus 1 and plus 1. But in that particular sample, in that particular range, you will be getting something. It is not a periodic signal, that's for sure. But in that particular range, the values that you will be getting, the addition will not tend to infinity. This addition will never tend to infinity. Say yes or no. No matter how many samples you take, this addition will never tend to infinity. It would be a finite number. And then that is divided by 2n plus 1. Even if you take n to be minus infinity, if you take this to be minus infinity and you take this to be plus infinity, addition will never tend to infinite. That means this addition will never tend to infinite. This will always converge. And if it is converging, then divide by infinity, it would be equals to 0 only. So this will give you an average of 0. Do you understand this point? Right? All good? Okay. So let's go to power now. We can study the power. So we can take a break now. So average is completed. We will study the power in the same manner only. Certain formulas will be there. That formula we will apply and we will get the power. So we can take a break and then we can study power. Yeah, so let's get started with the power. What should be the formula for power? So for periodic signal, what do you think what will be the formula? You will divide by one time period and you will add you will do the summation for one time period, mod of xn square. The same thing we were doing, right? For t naught, mod of xt square, and then I was dividing by t naught as well. So did the same thing. And what do you think what will be for aperiodic? Limit n tending to infinity, I would have taken 2n plus 1 samples and I would be summing up from minus n to n, right? A lot of notifications. Yeah. So now what we need to calculate? X of n AUN. Usually I keep my mobile switch off, but today some order would come, some order delivery would come. Our t-shirts would come. PrepFusion t-shirt would come today. So that's why I have kept it open today. Yeah. So xn is equals to AUN. So again, go by that. I will calculate the samples. What would be the sample? Sample would be AAA, right? Or you can draw the diagram as well. AUN, I can draw the diagram. It would be samples would be A always. Right? These will be the samples. 0, 1, 2, 3. This is X of n. So you need to take from minus n to plus n. Right? Minus n to plus n I will take because it is aperiodic. So D2 same thing. We have all. It should be solved by you. The bottom line is you should not be looking at the solution. It should be solved by you on your own. 1 by 2n plus 1. You need to square them and then you need to add them. But it will be added from 0 to n only. Right? It will be added from 0 to n. Right? So you need to add them. So n goes from 0 to n. So what will be added? Everything is a, so it would be a square. So a square is a constant value that can come out. So limit n tending to infinity, 1 by 2n plus 1, a can come out, a square can come out. What will be the value from 0 to n? That would be b minus a plus 1, n minus 0 plus 1. And do you know how to solve this limit? A square is a constant value that will remain there as it is. How to solve this particular limit? If you put n equals to n tending to infinity, that means n is very larger than 1, 1 can be ignored. Here also 1 can be ignored. So n divided by 2n, n will get cancelled out. What you will be left with? A square by 2. So this should have been solved because we have seen the same thing in the average as well. So this is the answer of power. Okay, this is the answer of power. Well and good. What about this one? What do you think? What will be the answer for this? This will always be A. So I can just copy this diagram. Here the point will be that it will always be A. So you need to go from minus n to plus n, right? So what I need to calculate? Power I need to calculate. Since it is aperiodic, so 1 by 2n plus 1, limit n tending to infinity, n goes from minus n to n, a square. So what it would be? b minus a plus 1. So limit n tending to infinity, 1 by 2n plus 1, a square can come out, a square can come out, b minus a plus 1, 2n plus 1. So 2n plus 1 and 2n plus 1 is getting cancelled. So what you are getting? Limit n tending to infinity, a square, which is a constant value only. So where you will put the limit? You will not put the limit. So answer is a square. This answer is a square. Okay, fine. A sin pi by 2n. Calculate the sample. You can see that periodicity would be 4. Periodicity would be 4. See the samples. Do you remember the samples now? In the negative side as well, there would be samples. At n equals to 0, it would be 0. At n equals to 1, it would be a. At n equals to 2, it would be 0 again. At n equals to 3, it would be minus a. In that manner, we will keep on going. Okay. So these are the 4 samples. What I will do? Power would be equals to 1 by 3. Then I need to do the summation. Summation of what? Summation of square. Here did I put the mode? Yeah, I have put the mode. So I can calculate a mode of xn square here. Mode of xn square. So what that would be? 0 a square, 0 a square. So I need to do it for, what is the periodicity? Sorry, periodicity is 4, right? Periodicity is 4. So I need to do it from 0 to 3 samples. I need to do it for 0 to 3 samples, right? You will say that, sir, mode of xn square has the periodicity of 2 only. But no, you will not put 2 here. You need to see the periodicity of x of n. The periodicity of x of n is 4. So 1 by 4, 0 to 3, mode of xn square, right? 1 by 4. So 0 plus a square plus 0 plus a square. What you are getting? 2a square by 4. So what is the answer? A square by 2. So here power of a sine pi by 2n is coming out to be a square by 2, right? Okay. Sine n, think about it. Is it periodic? Absolutely not. It is not periodic. So what I need to do? Power limit n tending to infinity 1 by 2n plus 1 summation, take the samples from minus n to n mode of xn square, right? So limit n tending to infinity 1 by 2n plus 1, n goes from minus n to n sine square n. Can you solve sine square n? Yes. So same ditto thing again and again I will have to write down. So limit n tending to infinity 1 by 2n plus 1, just open it up, minus n to n. So 1 minus cos 2n by 2. Say yes or no. This is how I can open it up. So what I can do? Limit n tending to infinity 1 by 2n plus 1 minus n to n 1 by 2 minus 1 by 2 cos 2n. So this is the summation is given to both of them. Summation is given to 1 by 2 as well and minus 1 by 2 cos 2n as well. This is cos 2n, right? So I can break the summation. One summation goes to 1 by 2 and this is in the multiplication of everything. So I can break the summation, right? One summation goes to 1 by 2, one summation goes to cos 2n by 2. So what I can do? I can break the summation like this. N from minus n to n 1 by 2 minus n goes from minus n to n cos 2n by 2. Now can you let me know the value of this thing? Yes, it is 0. Here we have seen. No, not this thing, sorry. Here complete n tending to infinity 1 by 2n plus 1. Then it is 0. Basically you take the samples. Just a second. Yeah. You just break it down like this. Now everything is in multiplication, so I can break it something like this. 1 by 2n plus 1, n goes from minus n to n 1 by 2 minus limit n tending to infinity 1 by 2n plus 1 summation n goes from minus n to n cos 2n by 2. So now I know the value of this particular thing. This is equals to 0. Say yes or no. This thing is equals to 0. So now if I solve here, limit n tending to infinity 1 by 2n plus 1. 1 by 2 can come outward, 1 by 2 can come outward. So now you need to sum from minus n to n and here in the common 1 would be left. So minus n to n summation 1, what that would be? B minus a plus 1. B minus a plus 1. N minus n plus 1. So 2n plus 1. This and this get cancelled out. What is the answer? 1 by 2. So power is coming out to be 1 by 2. If here it was a, then it would come out to be a square by 2. So basically, what is the power of a sin n? That is also coming out to be a square by 2, even though it is aperiodic. This signal is aperiodic, right? This signal is aperiodic. So even though it is aperiodic, still the power is coming out to be a square by 2. Did you understand how did I do this step? This step has been already told, right? This summation will give you a finite value divided by n equals to infinity. That would be equals to 0. And from here I am getting a square by 2. So a sin n will give you a square by 2. Here also it is giving me a square by 2, although it was periodic. So whether it is periodic or aperiodic, answer is coming out to be a square by 2 only. Try this one. It is cos with the shift. What do you think? What is the periodicity? periodicity is 3 pi by 2, 4 by 3 into 3, periodicity is 4. So let's check the samples. X of 0, or I can directly write down the samples. For 4 periodicity, I will write down the samples. So x of n directly I will write down in this manner. I will start from n equals to 0. So cos pi by 4, that would be a by under root 2. If I put n equals to 0 here, so cos pi by 4, that would be a by under root 2. If I put n equals to 1 here, so cos 3 pi by 2 plus pi by 4. So all student take copy 3 pi by 2. 3 pi by 2 would be in the 4th quadrant. So again it would be a by under root 2 only. Am I doing it correct? If I put n equals to 1, cos 3 pi by 2. 3 pi by 2 means pi 3 pi by 2, 4th quadrant. And in 4th quadrant, our cos is positive. But yeah, cos is positive. So it would be a by under root 2 again. If I put n equals to 2, cos 3 pi means 3rd quadrant. So it would be minus. If I put n equals to 3, 9 pi by 2. What is the meaning of 9 pi by 2? Next one, here it is also negative. So minus a by under root 2. Then let's check for one more sample. This is n equals to 3, right? N equals to 3. This was n equals to 0. Let's check for one more sample, that is n equals to 4. So if I check for n equals to 4, that is 6 pi plus pi by 4. What is the meaning of 6 pi? 6 pi means 1st quadrant. So that would be a by under root 2. So again it is coming out to be a by under root 2. So yes, it is being periodic with the sample of 4. So these are total 4 samples. So yeah, it is periodic. Certainly it was periodic, but I was just checking. I was just rechecking, nothing else. So what I need to do, I need to calculate the power. Power for 4 samples taking from 0 to 3 mode of xn square. So 4 samples are there. I need to do the summation from 0 to 3. So a square by 2 plus a square by 2 plus this would also be a square by 2 plus a square by 2. So this would be 2a square by 4. So what is the power? Again the power came out to be a square by 2. So till this point you are comfortable that the formula for these particular sinusoid functions in the continuous time as well, it was a square by 2. Here also the power is coming out to be a square by 2. Till this point you are convinced, right? The power is coming out to be a square by 2 only. Till this point you feel like that, sir, we are doing it correct. The formula we can develop here, it would be a square by 2. That kind of formula we can develop. But let's solve this one. What is the periodicity? Why do you care about periodicity? You would see, okay, a cos pi by n. You would see that, sir, power would be a square by 2. But I told you in discrete time, if your periodicity is very low, there could be some exception. So always have the patience when you solve the problem of discrete time, if the periodicity is low. So what is the periodicity? 2 here, right? 2 pi by 2. Periodicity is 2. So let's check. Let's check something. What we will check? What is your x of n? At n equals to 0, cos 0 is 1. At n equals to 0, cos 0 is 1. At n equals to 1, cos 0 is minus a minus a minus a. N equals to 2, you put cos 2 pi is again a minus a minus a. In that manner, it will keep on going. So yeah, periodicity is 2, no doubt about that. But what would be your mode of xn square? You need to calculate the power. Directly, I will calculate the power. So what I will write down for calculating the power? I need to divide by periodicity. Is that correct? Yes. Then I will calculate the sample from 0 to 1. Because periodicity is 2. So I will calculate the sample from 0 to 1. Mode of xn square. Is that correct? Yes. 1 by 2. A square plus a square. A square plus a square again. A square minus a square is again a square. So a square plus a square. What we are getting? 2a square by 2. What is the answer? A square. This went wrong. So again there is some exception. So yeah, we can develop a formula. We can certainly develop a formula. But always in the examination, if I am a student and my periodicity is coming out to be 4. Periodicity is coming out to be, here it is not even periodic. Periodicity is, here also it is coming out to be 4. So if I am a student, for my mental satisfaction, I will always calculate the sample and I will do this method. If I don't have the time in the examination hall, then I will click on a square by 2. Otherwise, I will always calculate the sample because these kind of exception cases can be there. So here there was exception. Here also there is an exception. Why is that so? Because you know that sin pi n will always be 0. Here it feels like that power I can write down a square by 2. But this would also be wrong. Why is that so? Because if you calculate x of n, sin 0 0, sin pi 0, sin 2 pi 0, it is always 0, it is always 0. And if it is always 0, what does that mean? The power would also be 0. There is nothing basically. So from where the power would come? There is no signal. X of n is 0, that means there is no signal. So what would be the power? Power would be 0. Right? So it is not a square by 2. So here in these two cases your formula failed. We developed a formula a square by 2, but here they are failing. So yeah, you will remember the formula a cos omega naught n plus some shift. If that is the case, then the formula is a square by 2. But that formula may fail in some exceptional cases. So if my periodicity is coming out to be a lower number, I will always check my x of n, and after that I will decide whether my answer is correct or not. If my n naught is coming out to be 20, there I will take the risk. I will put the answer to be a square by 2. I will take the answer to be a square by 2. If it is coming out to be larger. So in larger you cannot calculate 20 samples there. But if it is coming lower, then you can calculate the sample and you can see whether your answer is correct or not. So this is the conclusion. Okay. So this is a problem on continuous time signal, which I actually forgot when I was teaching continuous time signal power. At that time I forgot this problem. So you can calculate the problem, you can calculate the power for this particular signal. So what do you think, what will be the power? A e to the power j omega naught t. You need to calculate the power for this particular signal. Is this periodic? Yes. Certainly it is periodic, right? It is periodic with the time period of 2 pi by omega naught. So what I will do? What will be my power? Power will be written as 1 by t naught. It will go from 0 to t naught mod of xt whole square dt. So 1 by period is 2 pi by omega naught. 2 pi by omega naught. 0 to t naught. What is mod of xt whole square? Mod of this whole square. What is your mod of e to the power j omega naught t? That would be equal to mod of a. Now you just need to put mod of a square dot dt. So omega naught by 2 pi into mod of a square can come out integration 0 to t naught dt. What would be this value? T naught only. So mod of a square into t naught. And what is the value of t naught? That is 2 pi by omega naught. So that will get cancelled out. Basically I don't even want to change this one. I will put this 1 by t naught only. I will put this as 1 by t naught only. So t naught will get cancelled. What will be my power? A square. So for a complex exponential signal which is periodic, the power is mod of a square. Right? This is the power. You could have calculated it in the examination, or you can directly remember as well. For a complex exponential signal which is a periodic signal, the power is mod of a square. Let's check it for our discrete time signal. Right? So in discrete time, what I will do? First I can calculate the periodicity from here. What is the periodicity I am getting? 2 pi by 2. Periodicity is 2. So let's not take the risk. Let's calculate x of n. So I will start with 0 only. So n equals to 0 I will put a to the power 0 would be 1. So a I am getting. Then n equals to 1 I will put a to the power j pi, where that would be minus 1. So minus a. Then I will put again 2 a to the power j 2 pi, that is 1. A minus a. In that manner I will keep on going. Right? So if I need to calculate the power, what is the periodicity? Periodicity is 2. I need to take 2 samples. Right? Mod of xn square. So 1 by 2 a square plus a square, that would be equals to a square only. So this is the answer. So for the discrete time signal as well, we are getting the same answer. Here I should have written mod of a square actually, because this is mod, no? So here I should have put mod of a square, because what if this a was a complex number? So answer would be mod of a square. Okay, so answer would have been mod of a square. Mod of a square plus mod of a square is equals to, answer would have been mod of a square. This would have been the answer. Here also the same thing will be happening. If there is a random omega naught frequency, here is there any meaning of omega naught frequency? Basically what will be the time period here? That would be 2 pi by omega naught. Right? The time period would be 2 pi by omega naught. it has to be an integer. You will anyway you will make it an integer. N naught has to be an integer. You will anyway will make it an integer if it is not coming out to be an integer. So anyway you are going to make it integer. So let's check out. So I am assuming that this is an integer already. I am assuming that this is an integer. So what I am going to do? I am going to calculate the power. So power would be 1 by 2. It's not 1 by 2 what I am doing. So power would be 1 by, here what I will put? N naught, which is the periodicity, 1 by N naught, going from n equals to 0 to N naught minus 1. Do you agree to this point? N equals to 0 to N naught minus 1. Is that okay for you? 0 to N naught minus 1, that means number of sample is N naught. So I will, here what was the periodicity? Periodicity was 2. So you are going from 0 to 1. Here the periodicity is N naught. So you will go from 0 to N naught minus 1. Now mode of xn square. So mode of xn is always mode of a. So what I can do? 1 by N naught, 0 to N naught minus 1, mode of a square. Now this mode of a square can come outward. So mode of a square divided by N naught. N goes from 0 to N naught minus 1, 1. Right? So mode of a square divided by N naught. So b minus a plus 1. B minus a plus 1. So what this would be? N naught only. N naught get cancelled out. What is the answer? Mode of a square. So what is the power here? What was the power? Power is coming out to be mode of a square. So exponential never cheats. Okay, exponential will never cheat you. Exponential never cheats, whether it is for periodicity or it is for power. For the exponential, power will always be mode of a square. No doubt about that. And for exponential, the periodicity will always be 2 pi by omega naught. There is also no doubt. Are you getting this point? So exponential is never going to cheat. In the exponential, you can blindly put the answer. You can trust the formula. But in sinusoid and cosinusoid, you have to be aware of these cases. Here I thought of these two cases. The professor may think of some other cases as well, where formula is failing. So if the periodicity is coming out to be lower, then you will check. But in the case of exponential, if the periodicity is lower or higher, blindly you can put the answer mode of a square. Blindly you can put the answer mode of a square. And I have checked all kind of cases. Okay, I have taken different frequencies. I have checked all kind of cases. Always this formula would work. Always the formula is going to work. Well and good. Now someone would be saying that, sir, what if it was aperiodic? I will get the doubt. Some people will have this doubt that, sir, what if the complex exponential function was aperiodic? What if the function was somewhat like this? A e to the power j2n. Is it periodic? No, it is aperiodic, right? Because what will be its n naught? 2 pi by omega naught, that is pi. Can I have any integer number which can make it integer? No. That means it is non-periodic. It is non-periodic, right? So for non-periodic, what is the formula? For non-periodic, the formula is power will go 1 by limit n tending to infinity 1 by 2n plus 1 summation I need to take from minus n to n mode of xn square. What is mode of xn here? Again it is mode of a square only. So what I will do? Limit n tending to infinity 1 by 2n plus 1 n goes from minus n to n mode of a square. So this mode of a square can come outward. What we are getting? Limit n tending to infinity mode of a square divided by 2n plus 1 b minus a plus 1, b minus a plus 1. This and this is getting cancelled. So what I am getting? So exponential will never cheat. I am telling you, exponential will always be giving the correct answer, mode of a square. Here also mode of a square. Here also mode of a square. Right? So what is the conclusion I will write down? Here I should have put this omega naught, because this is discrete time signal, no? So this is discrete frequency. So this is how I can put. So power would be, I can write down the power. The power would be a square by 2 for sinusoid, and for cosinusoid as well, the power would be a square by 2. And for this one, here it is b. So I will put mode of a square by 2. Here I will put mode of b square by 2, and here I will put mode of c square. But in these two cases, there could be some. Here I will just write always check, always cross check, always cross check, because these two formula may fail at some signal in sinusoid and cosinusoid. Some particular signal, these two formula may fail. Examples are here only. Here both of the formula are failing, right? So always sinusoid and cosinusoid you need to check, but exponential will never cheat. Well and good. For continuous time signal, here what will be the power? You will say that, sir, both are orthogonal different frequencies. I don't even need to think of the power. The power will be, so, a square by 2 plus a square by 2. So the power will be 1. But does that work for your discrete time signal? If this is the signal, are they both of them orthogonal? It might be orthogonal, they might not be orthogonal, because we have seen the example of sine pi by 2n and sine 3 pi by 2n. Since they were having the different frequencies, we thought that it could be orthogonal, but it is not necessary that it will be orthogonal. It might be non-orthogonal as well. So always we need to check. Before checking and all these kind of things, first try predicting the periodicity. So what should be the periodicity? Periodicity here is 4. Here what is the periodicity? Here also it is 4. So what will be the total periodicity? 4 only. So let's calculate the 4 samples. Everything will be crystal clear, right? I will calculate the samples. It will be clear only, no? Number of samples are also very less only. So I will just calculate the samples. It will be clear to me whether how I will find the power. So let's go calculating the samples. So I will start with n equals to 0. Sin 0 is 0, cos 0 is a. N equals to 1, sin pi by 2 is a, but this would be 0. N equals to 2, sin pi is 0, but cos pi is minus a. N equals to 3, n equals to 3. So sin 3 pi by 2 is minus a, but this would be 0. N equals to 4, let's check. Sin 2 pi would be 0, but cos 2 pi would be a. So I can sense that a minus a minus a minus a minus a, then again a minus a minus a. In that manner it will keep on repeating. So what is this? This is your aperiodic signal. Periodic signal. Periodic signal with the periodicity of 4. So if I need to calculate the power, mode of xn square I can do, but let's directly calculate the power. So what will be the power? 1 by 4, taking the sample from 0 to 3, mode of xn square. 1 by 4. So a square plus again a square. This will be a square only, plus again a square. So what I am getting? 4a square by 4. Answer is a square. Or what you could have thought that, sir, these are your orthogonal signal, right? Different frequency orthogonal signal. So a square by 2, and here also a square by 2. Just add both of them, answer is a square. But always it will not work. You need to have the patience in the examination hall. You need to check whether they are actually orthogonal or not. So we will not check all these things, they are actually orthogonal or not. We will just check all these 4 samples, and based on these 4 samples I will write down my answer. So I will trust less on the formula if my signal is sinusoid and my number of samples are very less. My periodicity is less and signal is sinusoid and cosinusoid, then I will less trust on the formula. I will trust on the process. Who knows, they may frame a question where your formula might not be working. Are you getting this point? So better in the examination hall you trust on the process rather than the formula in case of sinusoid and cosinusoid and having low periodicity. If here the periodicity was 20, I would have trusted on the formula. Blindly I would have trusted on the formula if the periodicity was 20. But here periodicity is 4, so it might happen that the examination question paper setter, he may think something out of the box and he can ask you the problem. Okay, solve this one on your own. Periodicity is orthogonality, nothing I will see. I will first try predicting the periodicity. Here what is the periodicity? N naught 1 is 1. Here what is the periodicity? N naught 2 is 4. Here what is the periodicity? N naught 3 is 4. So what is the LCM? LCM will be 4. So your periodicity is 4. So 4 sample I can certainly calculate, right? 4 samples I can certainly calculate. So let's start calculating the samples. So let me take a pause, you try doing it on your own. Here the calculation will be a bit complex. A bit complex calculation would be there. But certainly the method is absolutely same. You can do it very easily. Method is absolutely the same, but calculation might be a bit complex here. Okay, so do it on your own. Yeah, so let's calculate x of 0, that would be 3 plus cos pi by 3, that means cos 60, that would be 1 by 2, right, plus sin 0 would be 0. So what we are getting? 4 only, right? 4 we are getting. Are we getting 4? Yeah. Okay. X of 1, 3 plus cos pi by 2 plus pi by 3, pi by 2 plus pi by 3. That means it will be going into the second quadrant. So sinusoid, sin pi by 3 is under root 3 by 2 plus sin pi by 2 is 1 only. So 6 minus under root 3, x of 2. So this will be 0, this will become 0 and this will be 3 only. What about this? Cos pi plus pi by 3, it will be going into third quadrant. Cos is negative, so it would be minus 1 by 2. So this will be 2. What about x of 3? So this will be 3 only. 3 pi by 2 plus pi by 3, 3 pi by 2 plus pi by 3, but this time it would be positive. It is again going into fourth quadrant. This is positive now. Plus 3 pi by 2 is sin 3 pi by 2 is minus 3, right? Sin 3 pi by 2 is minus 3. Sin 3 pi by 2 is minus 3. So what we are getting? Under root 3. So all these will be repeated. You can check at x equals to 4 as well, just for your mental satisfaction. So x equals to 4, this would be 3 plus, if I put 4, 2 pi plus pi by 3, it would be in the first quadrant only. So again 1 by 2 plus sin 2 pi, that would be equals to 0. So what we are getting? 4 only. So yeah, 4, 6 minus under root 3, 2 under root 3. So this is how it is being repeated. So x of n is being repeated in a manner with the periodicity of 4. So starting with 4, next number is 6 minus under root 3, next number is 2, next number is under root 3, then again 4. In that manner it is keep on repeating. What I need to calculate? Power. It is a periodic signal. 1 by periodicity is 4. You need to take the square and then add them up. 6 minus under root 3 square plus 2 square plus under root 3 square. This is the answer. So 4 plus 3, 7, 7 plus 16, that would be 7 plus, first I need to calculate 3 under root minus 6 square plus 16 plus 4 plus 3 divided by 4, 10.30. Power will be 10.30 watt. Okay. So in that manner we will do in the examination. We are not going to make it orthogonal. That kind of process we do for the continuous time. In the continuous time we cannot put the value t equals to 0, 1. In that manner we cannot put the value. So in continuous time we will make them orthogonal and then we apply the formula. If this was the question for continuous time, what you would have done? 3 1 to the power n plus 2 cos pi by 2 t plus pi by 3 plus 3 cos pi by 2 t. Right? And then what you would have done? Since both of them are not orthogonal, there is a phase shift 90 degree already there, but plus pi by 3 phase shift is also there. So for them you will make them orthogonal. You will apply the formula of cos a plus b, cos a cos b minus sin a sin b. Then it will become orthogonal. Then you can apply the formula that bc square plus a square by 2 plus b square by 2 plus c square by 2. Right? You remember the process, right? What about this one? This is again a very random signal, very random signal. We will try predicting the periodicity, but we have already done it when we were studying about our average. So this question we have already seen when we were studying about average. Yeah, so in the average we have seen this question, right? All these prediction, everything we have done, this also we have calculated, and from there we got to know that this is our x of n. So this x of n I can directly copy. So if this is my x of n, which I can directly copy. Right? So what is the periodicity here? 1, 2, 3, 4, 5, 6. Periodicity is 6. So what will be the power? 1 by 6. Now you need to add the square of all of them. So 2 square plus 2.5 square plus 1.5 square plus 3 square plus again 1.5 square plus 2.5 square, right? So this is the process I need to do. So let's do it. 2.5 square plus 1.5 square, that would be 8.5 into 2 plus 9 plus 4 divided by 6. So power is coming out to be 5 watt. Okay, so this is the power. So this is the end of our first chapter, where we studied about basics of signal, continuous time signal and discrete time signal. We are not going to see the assignment of it because every single thing we have covered. In the lecture itself, we have seen so many questions, everything is covered. After the end of systems, I can make an assignment where I will ask the question from signals as well and systems as well. But in the lecture itself, we have seen so many questions, you will be able to attempt every single question from this particular chapter. So you can solve the PYQs now, PYQs of first particular chapter if you want to. Otherwise, first study the systems. After that, you solve the PYQs of first and second chapter together. But now the chapter is completed and I hope you would have enjoyed the chapter. You would have studied a lot of new things if you have already studied it, and if you are a newcomer, then you have covered every single thing about this particular chapter. Next we will study about systems. Okay, so I hope you enjoyed the lecture. You can put a like and you can comment down whatever that you have studied or whatever that you liked about the lecture. Thank you very much. We will study about systems now.